Hey everyone, welcome to Simplilearn's YouTube channel. In this session, we will be learning Tableau for Data Visualization. But before we begin, I would like to take a quick confirmation from our viewers if the screen is clearly visible and the audio is fine. If yes, kindly type yes in the chat section, and in case if there are any problems that we can resolve from our end, please kindly let us know in the chat section so that we can quickly resolve before getting started. Great. I can see a lot of positive responses from our viewers. So it's clear that we can get started. Now let's get started with the agenda for today's session. First, we will get started by a quick introduction to Tableau. Later, we will understand the various data connections that Tableau can get connected to and extract the data. Followed by that, we will understand each and every important field in the data that we get connected. Followed by that, we will understand each and every important field in the data that we got connected to our data visualization tool, that is Tableau. Later, we will also understand those special fields that you need to pay attention to. Then we will understand how to create data extracts from the data that we got connected to. Later, we will understand the fundamentals of data visualization, which includes data sorting, data filtering, organizing data, aggregation that we need to include in our data before creating a visualization, some Tableau calculations, followed by that how to create a quick table calculation using Tableau. Once we are done with the fundamentals, we can move ahead with formatting and annotations in Tableau. Then we will understand pivoting date parts in Tableau in case if your dataset has any dates. Once we are done with all the basic requirements before creating a chart or before actually creating a visualization using Tableau, then we will get started with each and every important type of chart present in Tableau. By now, we have finished the fundamentals of data visualization using Tableau. Before getting started with the actual projects on Tableau, we will understand why you should go with Tableau by understanding the critical differences between the top business intelligence or data analytics tools like Tableau versus Power BI and Tableau versus Excel. So once we are done with discussing the critical differences between the major business intelligence tools, then we can get started with Tableau projects for beginners and also professionals. Once we are done with the projects, we will make things a little more interesting by covering the most frequently asked Tableau-oriented interview questions for data analysts. I hope I made myself clear with the agenda. Now without further ado, handing over the session to our training experts.
This is Ben. Ben started a store that sells automobile parts like brakes, exhausts, tires, lubricants, and car interiors. He made a good start with his business and achieved profits. However, as days passed by, along with his growing business, he faced some business challenges. He received orders from a variety of customers with different needs and requirements. For example, the northern states had higher demand for performance parts than others, and the eastern states demanded farm truck parts and lubricants more. And apart from this, a few products weren't performing well in the market and remained unsold. With the unbalanced requirements and economy variations, Ben had a tough time helping his customers with products on demand. He slowly realized he needed something new that can help him tackle the store's problems. What if Ben had a tool that could keep track of his store's inventory and sales? A geographical map that can recognize the demand for various types of products from different regions. A forecast feature that could predict the economic fluctuations in the market and help Ben visualize every single detail visually on one single dashboard. This software could practically solve many business problems and also could identify new opportunities to improvise and grow the business. Such types of software tools are called business intelligence tools, and one such tool is Tableau. Tableau was capable of learning the store's business patterns and running queries against the data to help visualize the flaws and resolve them quickly. Now, let us understand how Ben used Tableau and solved the issues related to his business. Ben collected his store's entire sales data from the previous quarter and ingested it into Tableau. Now using Tableau, Ben was able to categorize the data based on monthly sales. It took the daily sales and considered it as the x-axis. And then Tableau computed the sales in the store. Now, Ben clearly understood the products that outperformed the sales charts and the products that did not have much demand. Let us elaborate a little. Ben found that the performance parts like sports exhausts, turbochargers, and engine management systems were selling well. With the Tableau Forecast feature, Ben identified the demand for performance products in the next quarter. So he raised the prices on a few products that had the peak demand and earned higher profits. In the second forecast report, Ben found no significant elevation nor a drop in the demand for the tractor parts and lubricants. Apart from this, Ben saw the sales graphs of electronics encountered a drop in the current quarter. Compared to the previous quarter, the sales of electronics, like the music and infotainment systems, were low. To improvise and stabilize the fluctuating sales of electronics, Ben came up with some exciting clearance sell offers on electronic products. Using Tableau's geographic map feature, Ben understood the product demand at a regional level. He found the northern regions were interested in performance kits for their imported sports cars. The eastern regions had good demand for truck parts and lubricants. Using Tableau, Ben could generate various visualizations based on his data and come up with business-oriented decisions. Last but not least, Ben could also monitor his decisions and was able to make some necessary modifications to his business model on the go. Ben is now delighted as working with Tableau is a smooth and efficient process. Today, Tableau is being recognized as one of the best-in-class business intelligence tools because of its powerful and dependable features. Tableau can support and connect to a wide variety of data sources like the cloud, DBMS, Excel sheets, and even get connected to real-time data from websites. And Ben keeps his customers happy using Tableau to solve his business problems. Today, more and more leading business organizations are leaning towards business intelligence tools, intending to improve their business. Upon quite a success in his business, Ben decided to get a detailed understanding of Tableau by enrolling in Simplilearn's Tableau training program, which is led by industry experts who can train him according to the current business and IT standards to make his business even more successful.
So what is Tableau? So before we understand what exactly is Tableau, let us imagine a simple situation. Imagine that you're an office worker and you get some loads of data, maybe like millions of rows or billions of rows, and you are supposed to extract the insights of that particular data. So what do? You basically load that data into a database and try to write the SQL commands and then try to extract the insights of that particular data. So this kind of approach is basically time consuming and you get exhausted. Now, what if you had a tool which could write all the SQL commands for you in the background and all you had to do is just to drag and drop the data? Sounds interesting, right? So Tableau is just the same. All you have to do is just drag and drop the data and it will automatically write all the SQL commands you ever wanted to write on that particular data, and it will give you live data interactions and advices for the future. Now with this, let us understand the definition of Tableau. So basically Tableau is a business and analytical software tool developed in America. Tableau helps people to understand, visualize, and make data-driven decisions in real time with extreme agility and accuracy. Now with this, let us continue with the next topic, which will be about the various versions of Tableau. So at first, we have the Tableau Desktop. So Tableau Desktop is a data visualization application to facilitate you to examine virtually any kind of structured data and generate highly interactive, beautiful graphs, dashboards, and reports within minutes. Once a quick installation, you can tie to virtually any data source from spreadsheets to data warehouses and display information in several graphic perspectives. Designed to be easy to utilize, you'll be working more rapidly than ever before. Next, we have the Tableau Server. It is a business intelligence application that offers browser-based analytics anyone can utilize. It is a rapid-fire alternative to the slow pace of traditional business intelligence software. It is an online solution meant for sharing, distributing, and collaborating on content created in Tableau. What makes Tableau different? It is proposed to everyone. There is no scripting required, so everyone can grow to be an analytics expert. You can grow your deployment as you require it. Train online for free, find answers in minutes and not in months. That's the speciality of Tableau. Now followed by the Tableau Server, we have Tableau Online. So Tableau Online is a business intelligence application that offers browser-based analytics anyone can utilize. As discussed before, it is a rapid-fire alternative to slow-paced traditional business intelligence software. So Tableau Online is a secure cloud-based solution for sharing and collaborating on Tableau views and dashboards. Next up, we have the Tableau Public. So now I want to give you guys a serious heads up if you're a beginner in Tableau. Tableau Public is like an open source. Whatever the data you choose to work on using Tableau Public, it goes to public. So kind of like Tableau Public is not preferable if you want to work on your company's sensitive and confidential data. Tableau Public is a free software to facilitate anyone to get connected to a spreadsheet or a file and create interactive data visualizations for the web. It is delivered as a service that permits the user to be up to and running overnight. With Tableau Public, users can construct amazing interactive visuals and publish them quickly without the help of programmers or IT. It is designed for organizations to facilitate their websites with interactive data visualizations. There are higher limits on the size of data you can work with, and among other features, you can keep your underlying data hidden. And lastly, we have Tableau Reader. Tableau Reader is a free desktop application that you can use to open and interact with data visualizations built in Tableau Desktop. With Tableau Reader, you can filter, drill down, and discover humongous loads of data. Now moving ahead, we have the features of Tableau. So these are the few important features that you might want to consider. Those are the first one, robust security. Tableau takes special care of data and user security. It has a foolproof security-based authentication and permission systems for data connections and users access. Tableau also gives you the freedom to integrate with other security protocols such as Active Directory, Kerberos, etc. An important point to note here is that the Tableau practices low-level filtering, which helps in keeping the data secure. Followed by that, we have the collaboration and sharing feature. Tableau provides convenient options to collaborate with other users and instantly share data in the form of visualizations, sheets, dashboards, etc. in real time. It allows you to securely share data from various data sources such as on-premise, on-cloud, hybrid, etc. Instant and easy collaboration and data sharing helps in getting quick reviews or feedback on data, leading to a better overall analysis of it. Another extremely useful feature of Tableau is the use of time series and forecasting. Easy creation of trend lines and forecasting is possible due to Tableau's powerful backend and dynamic frontend. You can easily get data predictions such as a forecast or a trend line by simply selecting some options and drag and drop operations using your concerned fields. Next up, we have live and in-memory data. Tableau ensures connectivity with both live data sources and data extraction from external sources as in-memory data. This gives the user the flexibility to use the data from more than one type of data source without any restrictions. You can use data directly from data source by establishing live data connections, or keep that data in memory by extracting data from a data source as per their requirement. Tableau provides additional features to support data connectivity such as an automatic extract refreshes, notifying the user upon live connection fail, etc. Next, we have informative view and even the mobile view. One of the key features of Tableau, and the one that got its popularity, is its wide range of visualizations. In Tableau, you can make visualizations such as bar chart, pie chart, Gantt chart, bullet chart, motion chart, tree map, box plot, and many more. Like you name it, Tableau got it. You can select and create any kind of visualizations easily by selecting the visualization type from the Show Me tab. Apart from that, it is capable to represent data in mobile view as well. Tableau acknowledges the importance of mobile phones in today's world and provides the mobile versions of Tableau app. The next and the last feature is that being capable of accessing data from various kinds of data sources. Tableau offers a wide range of data source options where you can get connected and fetch data from data sources ranging from on-premise files, spreadsheets, relational databases, non-relational databases, online cloud data, data warehouses, and many more. So followed by the features, now we'll discuss about the advantages of Tableau. So following are the advantages of using Tableau. First one, it has remarkable visualization capabilities. Of course, the unparalleled capabilities of visualizing information is on top of the list of Tableau's software benefits. Followed by that, we have the ease of use. The tool's intuitive manner of creating graphics and a user-friendly interface allows non-developers to utilize the basic app's functionalities to the fullest. Users arrange raw data into catchy diagrams in a drag-and-drop way, which facilitates information analyzing and eliminates the need for the help of IT department and pattern building. Next, high performance. Apart from its high visualization functionality, users rates its overall performance as robust and reliable. The tool also operates fast on big data, which makes it powerful performance on an important point on the list of the advantages of Tableau. And next is the mobile friendliness. One of our best advantages out of the Tableau benefits is its efficient mobile application, which is available for both iOS and Android. It adds mobility to Tableau users and allows them to keep statistics at their fingertips, as well as supports their functionality that desktop and online versions have. And finally, we have the thriving community and forum. Tableau has a rich community. The number of Tableau fans who invest their expertise and skills in the community is increasing rapidly. Business users can beef up their knowledge on data processing and reporting and get many useful insights in this community. Also, forum visitors are ready to help settle any user issues and also share their experience. Next up, we have the disadvantages of Tableau. The first major disadvantage is the high cost. The Tableau is not the most expensive visualization software, especially compared to such business intelligence giants such as Oracle's and IBM solutions. All the same, the license is quite costly for small and medium companies, which makes it one of the considerable Tableau's disadvantages. Next is the inflexible pricing. Tableau's sales team is not flexible enough to provide case-by-case approach for their customers, ignoring the fact that each company has its own unique requirements for visualization tool package. The Tableau sales model requires clients to purchase and extend license from the start. As a result, a lot of companies that use Tableau arrive at the conclusion that they don't need all their licensed features. They would prefer to buying a set of requirements and scale them if necessary. Followed by that, the next disadvantage is poor after-sales support. On multiple message boards, users complain that Tableau software lacks proper after-sales maintenance. If customer has software performance problem, the support team does not settle the matter by investigating the problem's root and eliminating it. Next, we have the poor BI capability or the poor business intelligence capability. As previously mentioned, the tool provides best-in-class information visual interpretation. However, it lacks the functionality required for a fully fledged business intelligence tool such as large-scale reporting, the building of data tables, and statistics layouts. And lastly, the poor versioning. Only the recent Tableau versions support revision history, while for the older ones, software rolling back is impossible. Now, with the advantages and disadvantages discussed, let's move into the top companies hiring. The companies which are desperately looking for Tableau experts are Accenture, EY, PepsiCo, Deloitte, Wells Fargo, Capgemini, and many more. Now let's discuss the humongous and handsome salaries offered by these tech giants. So according to Glassdoor, the average salary of a Tableau expert in America is 82,000 grands, and for a beginner it is somewhere around $60,000 per annum, and at the highest rate it is $110,000 per annum. Similarly, the average salary of a Tableau expert in India is 5,06,000 per annum, and for a beginner it is somewhere around 3,60,000, and for a highly skilled, experienced Tableau expert, the salaries range from 8,75,000 per annum.
So let me now begin with connecting to data. Now in this particular topic, we are at the end of this lesson. You will be able to understand how you can connect to Tableau Data Server. You will be able to differentiate between a join and blend. How can you perform a join on a data? How can you blend a data? We will discuss the various connection options available. We will understand how Tableau Server works in terms of the Kerberos authentication. All right. We will understand various performance optimization techniques as well, shadow extract, as well as different methods that we can prepare in terms of the data that we want to analyze. All right. So let me begin. Now, the very first topic, which is connecting to Tableau server. So I'm going to first take you through a couple of presentation slides here and then quickly move on to the environment where we will actually then start exploring the topic. So now, when you want to connect to a data source in Tableau server, it's pretty simple. You can connect to a flat file in your local machine. So one is you will click on to the server in the start screen, and you can specify the server name. You can specify and show your log in your credentials, the username and password, and based on that you can perform you can have your connection to the database. All right, so that's how you can connect to the Tableau server as well. All right, so that's the very first basic. So the Tableau administrator is the one who assigns the roles and creates these data sources. All right, and you have Tableau has the facility in order to import different forms of data for the analysis for your ease. And once you're connected to the Tableau server, then you need to select the Tableau server data source. On the data menu, you will need to select the data source to download a local file, a local copy. You can select and create a local copy, and then you can also duplicate a duplicate of that data source will be added up into your data window. So that's how you can connect to Tableau server as well. All right, and it basically promotes various features wherein you can then connect to the Tableau server for your data. So you are in this example, you can see that you're able to connect to the Tableau server as an admin and connect to the sample superstore, and it downloads, it creates a local copy and duplicates all the data in that particular data window. That's how we can see the sample superstore, and you can connect to the server. Next, we're going to also understand what is joining and blending. So before I move on to the presentation slides here, what I'm going to do is I'm going to move on to the environment directly. Let us start exploring these blending and joining features right therein. All right, I'm going to simply just clear these sheets that we have, and let's go back to the connect to data source window. All right. Now, in terms of this is where you're able to connect. You can see the Tableau server. So it's through the server that you can connect, wherein you can specify your server credentials, and you can click on connect, and based on that, that's how then you can provide the credentials and log in. All right. Now, I do not have a server connection wherein I can show that example, but this is how you can click on any of these servers. You will have to type in the URL, click on connect, and then provide the usernames and login provided, and that's how you can connect to your data source using a server option. All right, I'm going to show you the file option wherein you can connect to an Excel, and let us discuss the join and the blending part here. All right, so let me click on Excel. We have the sample super data store here, and in this, when I pulled in order, all right, I pulled in the first sheet. So there are 3 sheets in that particular Excel file. When we pull in order, this is how now you can identify that whatever are, these are the header names, these are the dimensions and measures, that's how it's getting identified. You can notice all the dimensions are first place. You have all your measures, then you're able to identify the data type and the role, and ABC, which is a contextual value or numeric value, that means it's a dimension with a pound sign. What kind of a data role is it? Tableau is automatically identifying each of these roles as well. All right, even in the metadata, that's how you can see the field names, the field name that you're going to see onto your your view, and the table from which it's going to be getting pulled in from. In this, you can rename in case you want to change the particular name, hide it, alias it, or describe it. All right, so this is how you connect. Now, connections is where you have the option to connect between live and extract. Now, if you connect to live, that means you're connected to this particular sheet live. That means any update happening onto your sheet, any kind of updates on the sheet, there is a live connection. It will automatically update your views as well onto your sheets that you're creating. And in case if you select on an extract, All right, this is what it means, that it allows, what it does is it imports that data into the Tableau data engine first. In the data engine where it's going to perform the queries, it will create an extract, and based on these we can then start using the connections. All right, so what it does is it disconnects. It's more like a small extract, more like a cube if you understand it in that manner. Tableau creates an extract of that file, providing you a disconnected, wherein it allows you to give you a better performance, a better query. That's how you can then work on and start creating and working on these extracts. Now you can refresh these extracts at a timely manner as well. So that is what Tableau extracts are, where it extracts it as a copy of the data and saves it in the engine, and that's how then the performance as well gets better in terms of using, where you can connect to your particular data. All right, so you can work with multiple data sources. Data sources can be of any type. All right, wherein you can edit from the number of lists that you can see. It can be a flat file, a server file as we saw, or a saved one. And we can also then join multiple tables within the data, or we can also blend when it's coming in from different data sources. Then we can also perform a blending. So let me first show you an option for join. Now you can see we have the order table here. When I drag and drop the people sheet as well here, you can see that Tableau has automatically created a join. All right, it has automatically created a join when we have pulled in two tables coming in from the sheet, and by default, all right, we have the inner join that Tableau creates. So it creates an inner join here, wherein again you can then click on the join option here, and you can specify and modify the join based on whether you want it as an inner join, which is a default, you want a left join. Now if you see, the right join has been disabled here. Okay, I will show these options here. By default, the right join is disabled by Tableau by default, and to enable that you will have to connect to your Excel sheet in a different manner. I will show that to you shortly. So that's how you can change and you can perform your joins. This is where you can explore and show the join clause. And here again, then you can specify, like you can see a join that's being created amongst the data source, which is region and region people among these two data. All right, so it's also showing you the join and whether it is equal to or not equal to. All right, so you can connect to multiple tables, and based on that, you can add in tables, you can specify the different joins, and based on that, then when you click on sheet, you will then be able to see that there is a join being performed. There are two tables now, the people's table also that has been added in, and it has now performed an inner join on our data, and you can start using this particular option. So let's say I'm going to pull in the region on my columns, and I'm going to have my sales onto my rows. It's now providing me details of my sales at a regional basis. Now, let's say I also want to analyze the people belonging to these regions depending on the color. So it's going to change the colors based on the central, east, south, and west. All right, that's how these are the people, number of people belonging to each region that it has identified. So that's how it has taken up the region people. As you saw, there was a join that was created and it's given us that particular option. And based on that, you can see here, we just have this particular data source here. And that's how you can see. Now, I've used it earlier as well. If you remember, we had pulled in one particular table. Hence, the blue tick mark sign here enables and shows us that this is the primary data that's being used. Now, this comes in picture when we're using a particular join. So let me right now just use this particular detail here, and we're not going to require this. All right, so let's just close this. We just need one right now because we're discussing on blending. I'm going to show you the blending part later. Right now we're discussing on joins. So that's how you can join in your data sources, and you can combine multiple fields using these joins. So when you have multiple tables, you can simply connect to the data. Let me go back to the data source page. This is the startup page, the data source page. And you can see the joins that's been performed. Now, let's say you want to create a join where you want to force, due to certain situations and scenario where you want to force a right outer join, all right, or right join or for that matter, you want to write a custom SQL. Now, you're not able to write a SQL right here in the drag area pane where you can drag and drop your sheets from the Excel file or any kind of a file that you're connected to. For that, and to enable the right join, you will need to connect to your data in a specific manner. So let me open up a new instance of Tableau here. And let me show that to you as to how we can enable the right join and how we can have our custom SQLs as well. So in case if we want to write in a custom SQL on our view, then how can we perform that initial custom SQL, all right? Okay, so let us connect to our data here. And I'm going to take you on to the Excel file. Now, when I click on the sample superstore here, okay, what we had done is we clicked on open, and that's how we opened up the file, all right, and that's how we could see the sheets. Now, instead of using the open option directly, what I'm going to do is in the drop down, all right, here instead of open, we have an option that says open with a legacy connection, all right. This is what is going to enable us to write a custom SQL where we can specify a query rather than using the entire data source or pulling in the entire table. So clicking on the second option in the drop down in the open tab here, you will be able to see the open with legacy connection. I'm going to ensure that you've selected that, and that's how you will then connect to the data source. And with that, you now have a new custom SQL option that's opened up for you all. This is where you can, once you've connected, you can double click on the new custom SQL and you can write in your query. You can write in the SQL where you want to perform the query and pull in your data. All right, so you can have your select from, and let's say orders. All right, so that's how you can perform, and you can write in custom SQL, and you can pull in the required data. You can have your required table that you can pull in terms of creating a SQL that you want to pull in and have your data. All right, so you can have your select from the orders and preview the results. So here you can see the orders table has 9,940. We have a preview of the data available in that particular sheet that we pulled in. All right, and we can now parameters is what I'm going to cover when we come on to that particular topic. So I'm going to leave this for now. So that's how you can write your custom SQL, and you can click on OK, and that's going to pull in your entire data. And as you can see now, instead in the earlier view, I'm going to just switch to the earlier instance of Tableau. You could see the name of the table that I dragged and pulled in. You could see the name order. But in case when we write a custom SQL, then it gives us the name which is written as custom SQL query. All right, and this is where you can get the information. You can edit the query in case you want to change the results and requirements. So that's how, instead of clicking on open, you click on open legacy connection, and you can have your own custom SQL defined. Now, along with this, all right, when you open and when you click on a legacy connection, when I drag in the people's table here, you can see that even the options for right joins have now been enabled. So by default, Tableau disables the option for right joins, and in case in certain situations and circumstances you want the right join to be enabled, you will in the same manner have to import and connect to your data using a legacy connection, and you will have the right join which is going to be enabled there for you all. So you can have your custom SQLs or the right join in that case which gets enabled, and you can use a custom SQL or a right join. Right? So that was custom SQL. Then joining is where you can, as I mentioned, identify and choose between the clauses and the clause that you want to add in. Right? Now let me show you an example of blending as well. So I'm again going to open a new instance of Tableau. All right. And with that, I'm going to show you the example of blending. So let's say you have you want to join in, and when is the best time, when is the best way that you should use. Now, joining is when you have all your multiple tables that you want to join coming in from one data source. Blending would be required when you want to join in multiple tables coming in from different data sources. Or for that matter, you can also blend, even though the tables are coming in from a single data source, there might be instances that you might want to have still perform a blend instead of a join. So let me show that option to you. All right, so let me connect to the data. Let's connect to Excel, pull in our sample superstore file that we have. We have the order table, all right, and I'm going to go on to the sheets here. All right, so we have one order, we have one data, which is the order table. Now I'm going to again click on add a new data source coming in from the same Excel file, and this time I'm going to have the people's table and move to the sheet. So now if you notice, we can see two data sets here, which is one for the orders and one for people here. And in here, now this is where the blending will take place. This is where you will have a blend automatically when you pull in a view, if there is a common view that comes into picture. Now let's say I'm going to first pull in the order date onto the columns, all right? And as soon as I pull in, you can see that my order table has now got a blue check mark, which has become a primary data source. All right, and now let me pull in sales onto my rows, and from people, let me have from the people's table, let's have region pulled in and added to the colors. So region has become a secondary data set, and now you can see a blend sign, right? A linking or data blending that has automatically been performed on both these two data sets, all right, that we have the order table and the people's table, blue being primary and people which is being secondary in this case, all right. So that's how you can mention. Now in terms of blending, what happens is you cannot specify the joins here in this case. There is a primary and secondary data, and it is automatically blending in the data for you. It is automatically pulling in the data. You will not be able to here select on the kind of join. You will not be able to manipulate the join. So that's how, even though at times you have the same tables that are coming in, as I mentioned, there are times where you might want to perform and change the joins. So that's when you can use the joining table option that comes into picture. So that's the difference between your blending and between joining the tables, right? So you can see this available link, and you can see how it was simple to drag a particular view and pull in data. And here as well, region has been added to the color fill, because of which the legends have been created, identifying all 4 regions present in the data. And it's also letting us know here in the marks that region is coming in from the secondary table. You can see the orange amber tick mark here, and that's how you can identify that region is coming in from the secondary table that's been created, all right? In terms of connecting as well, wherein you can combine and have the joins enabled. Now, depending on the kind of data, all right, going back to the data source, depending on the kind of tables and the kind of data that we have, that's when we can enable and have the joins that we can decide on, all right? So one is you would require and need to have a multiple legacy connection with which you can then define the right outer join, all right? And that's how you can proceed and have additional joins that you can work on. We also discussed how we could create and connect to a custom SQL query, all right, and that is how we could, using the legacy connection, also enable the right outer join, wherein we could then perform a right join on our tables as well, all right. And in case if it's a query, then it gives in the name of the query as a custom query, which is what we saw onto the preview and the extract there, all right. Now, in terms of extract, all right, now extracts are basically your saved subsets of the data source which will help you in improving the performance. So instead of, as I mentioned, instead of being connected to a live connection, it is better that we select an extract which creates a subset and stores it in the Tableau engine, wherein it performs the queries, and it takes advantage of this functionality where it is not connected to the original data source. And with this, it can actually reduce the total amount of data in terms of defining and limiting it. So that's how you can create an extract. And let's say once you've created an extract, you can then perform, like I said, you have the edit option where you can edit the additional detailings. You can allow an incremental fetch happening, where then you can refresh the data each time your data is updated. You can provide an incremental fetch. So this can help you in improving your performance. You can take advantage of the functionality in terms of the data source for using the discounts, the distinct counts as well. And moreover, it's more like an offline mode. You're actually accessing your data as an offline access where it's not directly connected, and you're able to use it like a data, local data. All right, so that is the difference between a live and an extract. So that's how you can make use of the legacy connections as well. So let's go back to the presentation slides and have a recap. Now, these are the joining tables. That's what we discussed, that in terms of the tables that we have, we can join a table and we have various joins available where it makes it easy for us to analyze the data that we want to view. We can join two or multiple tables, and based on that we can customize the inner, the left, the right, or the full outer join. Now the full outer join also depends on the kind of data source that you're connected to. All right, so in case of an Excel file, we still do not have the right outer join option which is enabled. So this possible option, again, when you open with a legacy, depending on the data type, is how you will have the right outer join that you can force and have it enabled. So this would be depending on the kind of data source file also that you have, and you have these 4 join types that you can use in terms of joining tables in Tableau. Now, when would you want to use a join? All right, so a scenario is that you have a sales manager of an online shopping website and he wants to analyze the customers who have returned at least half the number of orders that they have placed. Now, to fulfill this requirement, he will require a worksheet wherein he can join the orders and the return table on a particular common dimension. All right, so that's how then he can create a join. He can change this between the inner default to a left join between the order tables and the return tables, and based on that he can then get to know the customers who have returned at least half the number of orders that were placed. All right, now in terms of enabling a right outer join, this is taken care of by the Microsoft Jet Data Engine driver. So in case if you all are facing a trouble where you're not able to connect and see that particular option, it's throwing an error. This legacy connection options comes in only when you're using a Microsoft Jet Data Engine driver. This is easily available. In case if you do not have it, you can install this driver, and with this it will enable the right outer join and the custom SQL for us. All right, to enable the right outer join here, that's how you open it with a particular legacy connection. Now, in terms of a right outer join, we saw an example. We can force and use a right outer join. We can select on a new custom SQL where we can type in and have a custom SQL generated. And that's how we can work on with the SQL, where we can provide the SQL syntax, and based on that, the data source will then be generated. Now, in terms of blending, this is what happens when you have multiple data sources in your view, or when you want to establish a link between them, or you want to blend your data. It does not create a row level join. So in case like the example that we did, although it was coming in from the same sheet, from the same Excel file, but we did not want to create a row level join, then that's when data blending would come in handy. You can use it with the related data across multiple sources that you want to analyze in one particular view. So that's how you can blend your data, which creates a primary and a secondary data. So we saw that in this example, you can see that there's a customer segment, department, and sum of sales, wherein the bars are being created, which are coming in from the primary connection. But in terms of the sales plan, all right, these sales plan are coming in from a secondary data. You can see the amber connection here, the amber line here, that is allowing you to understand and segregate and differentiate that it is a secondary connection. So in Tableau, that's how you can identify, as you saw, that your primary source and you have your secondary source, wherein you can identify and distinguish. You can distinguish between the common fields that are present in your data, and you can establish a connection. In case if it has not established a link, you saw that there was an automatic link, then you can provide a link by explicitly defining a link as well. Let me take you back to the environment. All right, so this was the custom SQL. Now, in this case, in case if there is no link provided, then you can provide a particular link onto your view. You can have the option, if it has not enabled, then you can select your particular, you can see that it has not implicitly defined, but it's giving you an option that there is possibility of linking. So you can explicitly define, you can click on this link and use person as a linking field, and this has also linked in your data with the previous data that you have. All right, so that's how you can define and explicitly mention the way that you can blend your data and you can identify. Another way can also be wherein you can edit the connection in the mapping, and that's where you can perform. So you can go back to your data sources and you can explicitly define, you can identify whether the first rows are the names, whether the rows here are automatically generating a field or not. All right, so that's how you can have these two tables, and you can define the blending whether you want it or not. You can disable the linking as well in case you don't want to perform a particular link. So coming to that, now let us understand, I've already discussed the difference between the joins and blends and where you can use it. So let's have a recap again. Now in terms of joining, joining is a SQL term wherein it's combining two data sources coming in from a single data source. While in terms of blending, it's more about combining two different data sources into one single sheet. All right. Joining is done once at the data source, and this can be used for every worksheet, while blending will be done individually for every worksheet. Okay, and both the tables that are joined must exist in the SQL database. While in blending, it helps us combine the database which is coming in from different sources, different locations. And in case if it's a multi-dimensional source, if it's a cube, then you cannot perform a join. And in terms of blending, you have a primary source, and but in terms of a primary source, it cannot be a cube, but your secondary source can definitely be a cube that you can use in terms of performing a blend. All right. So that's how you can optimize your connections. You can select whether you want to have perform a blend on your connections, you want to perform a join depending on the kind of connections that you have, and that's how you can work with them with the different data sources that you have available.
We are going to be discussing, once we are done, once you've completed this particular lesson, you're going to be able to understand how Tableau works with date hierarchies in terms of pivoting date parts on shelves, how you can differentiate between a discrete and a continuous date, how you can create and make use of custom dates, what are date dimensions on a fiscal year, and how you can filter on date dimensions dynamically using your relative date filtering, and also understand the working of date hierarchy with cubes. So that's in store for us for this particular lesson. So let me now move on and begin with the first topic here. Now, if you remember previously, we had discussed that in terms of dates, Tableau handles, depending on the kind of database data source that you're using, be it relational or a cube data source, it handles and works with the date differently depending on its data source. All right. So you can see it automatically separates the date field into multiple levels of time hierarchy, as you can see here. All right. So in case when you have a date, it breaks down, you can see from year to quarter, onto month to week and day. All right, so it creates its own level of hierarchy here that it can make use of and separates the entire field. Now this is in case when you're using a file, when you're using a relational file. All right, so at the end of this, we would also discuss that in case if it's a multi-dimensional cube file, then what happens. So right now we're talking about the basic Excel sample file, and that's how we've seen that Tableau automatically divides into multiple levels of time hierarchy. All right, so in this case, you can see back on our Excel, you will find that we have the order date, which is a single level and column here that you can see. All right, but the moment we pull in that data, so let me show that to you in the repository as well. The moment we pull in this particular data, order date, all right, that's how you can see it onto our sample superstore data dimension here, and it automatically creates a hierarchy. So we've seen this earlier now, that as soon as we add it up, we can drill and we can keep moving ahead. All right, so let's understand, let's take up a scenario and discuss on how dates are dealt with. So Jason Michaels, now he is the sales manager of an apparel manufacturing company. Now in Q4, the performance, he has a performance review meeting, which is next week, all right? And in that case, he needs to present the year-over-year sales report, wherein he wants to highlight how his new marketing strategy that was introduced in this particular year has increased the sales considerably, all right? And for that, he needs to see the sales report initially at a year level, and then additionally, he should be able to drill down to the sales performance at a quarter and monthly level. Now, let's see, assuming that we are Jason Michaels here, how are we going to achieve this particular scenario, all right? So let me switch on to my, so I'm going to move on to my Tableau environment here, wherein I have already added in the order sheet from the sample file provided by Tableau. Now, to achieve that particular scenario, what we're going to be doing is, let's first build a normal view where we can have the order date and sum of sales, all right, wherein then we can proceed further, where we can achieve that, achieve a view where as Jason Michaels, we will be able to see the sales at an initial yearly level, all right, and then we should be able to drill down at wherein we can show the sales performance. So now, since we're talking about wanting to see a yearly level with related to time that we want to see, what we're going to do is, let's have our sales and order date selected, all right, and based on this, in the show me option, you can see it gives us the option to create a line. Now, that is one of the best charts that you can make use of in terms of analyzing something which is time related, which is time based. So whenever you want to analyze something time related, time based, your line charts, your line graphs is what is ideal in terms of choosing the kind of view. All right. So here we have your order date. So if you notice, we already have the order date, and Tableau has automatically created the hierarchies, the level here for us. And by default, it's taking in the highest level of the time hierarchy here. So it takes in the level at a yearly level here for our sales that we can see. Now, this is how Jason will be able to achieve his view where he can see the sales at a yearly level for all the years that are present in the data source, all right? Now, he should be able to drill down as the requirement was, that he should be able to drill at every level in terms of seeing the performance, because he had introduced a particular plan, a particular sales plan, and he wants to see whether that implementation has been beneficial. So he can simply click on the plus sign here, and that's how now we've drilled down from year to a quarter level. So we are able to see the sales year for every year divided at a quarter level, all right? And then finally, we can drill down even more further by clicking on the plus sign, which can then in terms of drilling down to a monthly level, wherein now we can see that we're able to see the entire data at a yearly, quarterly, and monthly division here, all right? So it's January, February, and March that you're able to see, which is the first quarter in 2011, and that's how you're able to see your sales across time, all right? So that's how Jason can achieve this particular scenario where he can see the sales over time. Dilip has a question that says, how do we get the plus sign? Dilip, in terms when we're using the relative relational data source, which is the sample data source. The moment you drag and drop your order date onto the columns or any field, it will automatically give you the plus and minus sign. Because what happens is, like I mentioned, Tableau basically refers and it deals with date in a special manner. Alright. So if it's a relational source, it automatically creates a time hierarchy. Now you can see we don't see any hierarchy that is created here. But what it has done is it has identified the role. It has identified it is related to date and time, and that is the reason it has automatically created these levels of hierarchy for us. So in our data, whatever are the dates, the year, the quarter, based on that, Tableau has automatically identified and created these hierarchies for us. Alright, so you can directly, the moment you drag and drop a particular, when you drag and drop the order date or any date related field coming in from a relational source, you can automatically see the plus and minus sign. Alright, I hope that answers your question. So that is how we have Jason, who will be able to achieve, where now he can have the entire, let's go back to the demo, let's go back and see. So he wanted to highlight how his new marketing strategy was introduced in that year, increased the sales. Alright, and he wanted the initial report at year level, and then finally he should be able to drill it down to quarter and month. And that's exactly how we could achieve this scenario. So first we created a view with just year and the sales, and that's how we can see that there has been a considerable increase in terms of all the sales that have been taking place, all right, based on the introduction of the basic program, the marketing strategy that he had introduced. All right, so that's how one, we've achieved and seen how we can achieve the scenario, and moreover how Tableau handles the date in terms of when you're using a relational data source.
So not putting in time here, we're going to proceed further in understanding how we can create data extracts. Alright, so as I mentioned, the extracts are where you create a subset of your data source. You can extract a particular data, you can save it as a subset, which will help you in performing and improving your query. So instead of the live, you can simply click on the extract, which will create a Tableau extract for you. Alright, so let me just show you, let me take you to the repository, and in that you will be able to identify in my Tableau repository data sources. You can see that we have a Tableau extract here for world indicators. So what it's done is it has created a subset of the world indicators data source, and it's disconnected, it's an offline mode which can allow us to improve the performance. It can be accessed offline as well when you're away, when you're probably traveling, and we can then create an extract where we can keep refreshing it with the original data, and we can then replace it with the content, or we can provide a complete incremental refresh with these. Alright, now extracts can also be created from within our data sets as well once you perform. So let's say, let me go back to our view here, and let's have category in our columns, let's have quantity on our rows. Now even here you have the option of going under the data menu where you can click on the extract data. So whatever you've selected, any kind of performances and any kind of the aggregations that you perform, now this is your data that you perform. Now instead of, even though it's a live connection, you can still go to the data menu here and you can click on create and extract a data, which will create a subset. Alright, which will create a subset for you where you can create this data and you can provide the different fields wherein you can select what you want to filter, whether you want to add a specific filter to your field, whether you want to specify the aggregation data for the visible dimensions. This is where you can select the option for the measures to be aggregated. The default, instead of using the default, what is the kind of aggregation that you want to use. So this can allow you to minimize the size of your file as well and increase your performance. You can click on aggregation and you want to roll up the dates to year, to quarter, to month, you can select on the aggregation. The number of rows that you want to allow in terms of the incremental fetch here, you want to provide the incremental fetch for all rows or just the top particular selected rows. So you can select on that particular option. Once you've specified all these detailings, you can then click on extract, and that's going to save the subsequent file in the location that you have saved in terms of the extract, and it will save up an extract for you. All right. So when you click on extract, it will ask you for a subsequent location of where you want to save it. There is a custom query that we had used. And let's say if we save it on the desktop itself, you can see the save type, which is a .tde, which is a Tableau data extract. And the next time you can start working using these data extracts, and you can start performing, where you do not need to then have your custom SQL written in or any other detailings. You can simply use the extract and start working on it. All right, you can actually restrict the size and improve the performance, and you can perform data extracts on these as well. All right. And then again, in the data menu option here, you have the option to replace your particular data source. So let's say you have your option where you want to perform incremental fetch, then you can replace the data, or you can upgrade it, or for that matter, you can go to this particular table, you can refresh your data with the connection where you have the additional refresh data. You can view your data, you can duplicate it, rename it. We just discussed how we can create the extract data options as well. So that's how you can perform and see and have an extract of your data. So that was using your data extracts. Now, you can also write custom SQL. So we've discussed that. Let me take you back to the presentation slide and have a recap. So here, this is the window that we saw in terms of the extract, where you can add in the qualifications, where you can narrow down your data even more further. You can select an incremental fetch, whether you want it for all the rows or limit the number of rows to be included in that particular extract. Then we also saw that how we could write a custom SQL. We could open it in a legacy connection that helped us to open up a custom SQL window where we can write down the SQL with the exact data that we want to analyze. This can again help us in improving the query performances, where we can write down and provide an optimized query against our data that we want to use. All right. In terms of the supported data sources, a lot of you all had questions, what kind of data sources are supported. Now, Tableau Desktop is supporting the, it determines the support depending on the kind of license that you have purchased, all right? So only when you have the required license, it will support the different data source types. And you have a personal edition, which provides you and allows you to use the support for a lot of databases. But it is the professional edition that provides you additional database options that you can connect to. So data such as text files, access files, Excel sheets, and so on, these can be connected through the personal editions. While in terms of a professional edition, the professional license, this is where you can connect other than the personal editions. You can connect to the personal additional databases like your Oracle, SQL, and you can connect to certain more additional connections here, which is supported, 40+ data connections, which is supported in the professional edition. All right, so that's how you can connect to these different connections. Now, also along with that, once you have your server that comes into picture, what a server does is it provides you a Kerberos authentication, which is a supported trusted authentication that it uses in terms of your single sign-on. All right. So what it does is, in this case, is that as you can see, it is a protocol that is provided to trust the authentication between your machines, and that's how it uses a third-party network service called as the KDC, the Key Distribution Center, which provides a secure connection between your desktop and the server machines. And this is supported based on the Kerberos authentication. All right, and that's where you can, it uses only one user authentication, the permissions and the access control. In such cases like the workbooks is going to be now the workbooks and extracts will not be handled by Kerberos, but the permissions and access control, those are the things, those are the detailing that Kerberos will be handling in terms of your data connection. Alright, so basically if your Tableau server has a Kerberos enabled on your machine with a valid active directory credentials, then what Tableau does is it connects to your server and it completely skips the step of authenticating. So in case, let me take you to the environment. Here in the environment, you can see the server option, and in this you have the publish workbook. Now let's say when you've created your workbook and you want to publish it onto your server. Now this is where it asks you to connect to the server here. It asks you to provide the credentials, and then based on that, it then asks you, once you've connected to, let's say you've connected to your server, it is then going to ask you a sign-on for that particular configuration. Now, if you have a Kerberos environment which is activated, then it's going to skip these basic steps here and it will directly allow you to connect and skip these connection that comes in between. So that is what is Kerberos authentication. All right. So it's a single sign-on method. And once you have that enabled, then you can make use of these. You need to configure your Tableau server with these Kerberos configurations. All right. So it's a three-way authentication protocol. Now, how this works is a mechanism of mutual authentication between the client and the server is provided with the Kerberos authentication. So when the user logs into the directory, it directly asks for the credentials which are authenticated by Kerberos, and once this is authenticated, a ticket is generated and sent to the user's computer. And then when the user tries to connect to the Tableau server from the desktop or the web browser, the Tableau server authenticates the user and it directly allows us to perform. Now this mechanism is provided before the network connection is opened up between the client and the server. Right? So how does it work in terms of a single sign-on? How does it support it? Is it supports a single sign-on option wherein you have the server configuration, and in this you have a Kerberos tab where you can define enabling the single sign-on option in terms of the environment where you can connect. Individually you can connect with a single sign-on to connect to the server from your desktop or the web browser. Alright. In terms of trying to optimizing your query, now how can you optimize your query? Tableau adopts various query optimization techniques to improve the query performance. Alright. So what it does is it provides parallel query where it improves the performance speed of the dashboard by performing and providing a capability of executing a parallel query. So in this case, what happens is it executes more queries at the same time. It is independent queries that start at the same time, and hence they are faster and improves the performance. So this is what Tableau does. It provides the parallel query. Next in it has the query fusion. In this, what it does is Tableau has the ability to reduce any kind of complex or large number of queries into a fewer simple ones. So that's how it again optimizes your performance. Right, and then it also has external query caching. In this, it quickens up the process of optimizing your data by processing it into a cache. All right, so that it does not need to go and hit in the warehouse every time that you require a particular data. So this is possible with the external query caching. So Tableau adopts these various methods. It also has a data engine vectorization, wherein it has an in-memory analytics column, and it's a faster query which helps in reducing the extract size and creation time. So based on these, that's how it can improve the performance, and that's how it optimizes these techniques, and Tableau handles and takes care of each of these. So it performs a parallel query by its own. It uses a particular query fashion which is short. It does not, it shortens up all the queries, the external query caching that it uses, and also provides a data engine vectorization where it makes it even more quicker and faster. Now, in order to quicken the process of your loading of data, what Tableau does is it creates and saves a shadow extract file on its own. Alright, what it does is in the repository, for you to load your data faster, other than you creating an extract, it takes up the content of a shadow extract in your repository file and it saves it up as a shadow while you're working on the workbook. All right, and that's where then when you're creating and working based on the legacy, non-legacy Excels or text files or statistical file, it creates a shadow extract file automatically wherever you have your repository. So in case when you're working on something, what it does is in your repository folder, all right, where you have your repository, which is in My Documents, in the data sources, you will be able to see that it provides you a particular extract, that is a shadow extract that's been created, and you can see that it creates a shadow extract right there where you can make use of. All right, in the background. So this is done automatically by Tableau to quicken up the process. This is something that you do not need to handle by default. The folder, there is a folder that gets created. When you have a proper licensed version, then you will see that in the repository folder, you will have a shadow extract folder. And based on that, that is how you will see that at least the first 5, at least the top 5 shadow extracts will be saved with the .ttde extension, and that's how it uses and replaces the oldest one. So when you have a licensed version in that case, then that's when you will be able to see this extract folder, and this is when it quickens up the entire process. So let's understand and see how we can perform sort. Now your sort refers to arranging your dimension members in a specified order, whether you want to have it as descending or whether you want to have it as ascending. All right. So you can perform your sort wherein you can sort directly on the axis on a particular field, or you can do it manually as well. Now what Tableau supports is it supports computed sorting as well as manual sorting. So I'm going to show you both these options of how you can sort based on your computed sorting as well as manual sorting. So let me quickly show you the options in terms of how you can sort on your data. All right, so now we have region in column and sales in my rows. All right, now you will find the sort option. You can see the sort option already available in your toolbar in terms of whether you want to sort your data either in an ascending or a descending manner. So this is a quick sort. All right, you can have your data sorted as an ascending or a descending manner, and the moment you've sorted on your data, notice on region and on sales you're able to see the sorting sign, right? It's sorted in, it's performed a quick sort, and hence you're able to see the sorting sign that has been enabled in terms of our region and sales, a quick sort that you can make use of from the toolbar. All right, now there is also a way that you can sort your data manually as well. So that was a quick sort that you can perform. All right, so you can allow a quick sorting, but in this case you also have the option that you can perform a sorting. Now when I move on to the axis here, you can see that I can use the sorting option here as well and change the order of sorting. All right, I can sort in a descending and ascending manner. So when I hover over, you can see that my data is getting sorted. Let me clear the sorts all together and then again show you, so that when we hover onto sales, you can see that we have the sorting that comes up, a floating sorting icon. So one is you can sort from the toolbar, the other is a floating sort icon appears when you hover onto the axis, and you can sort your data accordingly. All right, so that is another way of doing it. And in terms of, let's say we want to manually sort our data as well. So what you can do is then we can simply use the dates and we can do a computed sorting. So in this case, let's say in the drop down, you have the option here that says sort. In the drop down pane on region, you can click on that. This opens up the computed sorting of the order that you want in terms of region, whether you want it as ascending or descending, whether you want it sorted based on the data source order which is present in your data source, the alphabetic order, all right, so it's going to take in the alphabet, or whether you want to use it sorting based on a particular field. So I want to sort it, let's say, based on sales aggregation. So how do I want to sort my region? And I can also perform a manual sort where I can choose that instead of my central, east, south and west, let's say I want west right on top. and I want east, west and central. I want east probably after south. So I can manually sort it as well, irrespective of it taking in the ascending and descending based on the alphabet or the data source order or the field. So I can manually sort my data here as well. So this is where I can perform a manual sort, where I can specify the position of the manual bars. All right. What is the data source order? Diksha, in your data source, now we are connected to this particular Excel file, right? So the Excel file in this case is our data source, and however region is in terms of our Excel file, we are saying sorted based on that data source order. Alright, so instead of the alphabet or instead of the field or the manual, I'm saying whatever. So let's say if your south is first in your data source and your central is last, then it's going to take in that particular ordering and it's going to sort it based on whatever is first to last in the data source Excel. So that's how you can sort on your data, as we saw. So that was another way. This was to do with your computed sorting. So one was a quick one where you can use the toolbar or the axis, or then you can click on the drop down pill of that particular field, and based on that you can perform your computed sorting as well as the manual sorting. Alright, now this changed it to the level of sorting because we used the manual one and we made changes, and that's how we positioned our bars manually based on the selections that we wanted. Let's have a quick recap. So we can sort on the axis on a specific field, or we can do it manually as well, as we saw. Tableau supports computed, where we could use the toolbars or the axis, or we could perform a manual sort as well. When we clicked on a particular pill, we had the option to manually sort our fields also. So here it comes. Before sorting, when you've done it on the axis, as I said, you can hover over the particular axis, a floating icon appears and you can sort your data. Alright. In terms of a specific field, you can then click on the drop down and open up a sort for that particular field and decide whether you want to, what kind of sorting you want to enable. You want to sort as ascending or descending, what is the order that you want to use for your sorting, or whether you want a manual sort, the third option available for you all in the sorting window. Now that was about sorting. So moving further, so what is filter? So your filter helps you in narrowing down your data. It can be applied to a dimension, that is your contextual value, to measures, which is your numerical value, or to a date field as well, where you want to narrow it down to a specific value or a range of values, all right, in Tableau. So what are the ways that you can possibly filter? Now, what are the different conditions that you can possibly filter is, one, you can select the data to filter in the view. Alright, so you can add it up to the filter shelf directly and choose whether you want to include or exclude the option. The other way is you can have it added up to the filter shelf as well, or you can turn on the quick filters, which opens up a new card where you can quickly add in or alter your data in terms of filtering. So let me take you to the window therein, and let's start exploring these options of how we can use filters and how we can manipulate our data in terms of narrowing it down. Alright, so let us start beginning with the very first one, and I'm moving on to the interface here. Alright, now first I'm going to show you how we can filter on the dimensions. Okay, so let me take in a new sheet. Alright, and let's say I'm going to have the customer name filter. So I'm going to use my customer name dimension and add it up to the filter shelf here. This opens up the filter window. All right, and in this particular window, you have 4 tabs, as you can see, one being the general, one being wildcard, one being condition and top. Now, let me first explain each of these tabs, and then we'll proceed further in understanding how we can filter on the dimension here. All right. So in the general option, you can select the list that you want in terms of filtering, and whether you want to include it or you want to exclude that particular selection. All right. So in clicking on exclude, will exclude whatever selections you've made. Unchecking this option by default means whatever we've selected, I need to only include those customer names onto my view. All right. The next is you can have a custom value list, or you can also have a use all feature where I'm saying I want to use all the options and I want to include these. So that is the first general option. The second option is in terms of having a wildcard. So a wildcard is where you can specify a particular match value, whether you want to, that value contains that particular alphabet or starts with that alphabet, ends with that alphabet, or exactly matches that alphabet. So let's use the wildcard option and say I want the names starting with, all right, the alphabet. Let me choose the alphabet S. All right. So I'm saying that all my customer names should start with the alphabet S. So when I click on this and then I use the customer names onto my view, I will only be viewing customers with the name starting with S. All right. So conditions is where you can apply a condition based on a particular field or by a formula. And top is where we can apply the field to be the top 10 customers based on a particular dimension or a measure or by a particular formula. So we'll understand these tabs with different options of filtering. Let's use the wildcard. All right. Now, in terms of the wildcard option, so we mentioned it starts with the letter S, and I click on OK. All right. Now I'm going to add in the customer name onto the rows. So you can see that we only will have the names beginning with S. It's filtered down because we said that we need the name starting with S, and we have all the customers names starting with an S here. Let's add sales to our columns, and we have all the names of the customers beginning with S. That's how you can filter on a particular dimension. All right. All right, Srikar, in terms of the, Srikar has put up a question in terms of, can we explain the custom value list? In terms of the custom value, Srikar, what happens is, let me just open up the filter here so that I can explain that to you quickly. When you talk of select list, you can select from the particular option that you want, all right? And in terms of a custom value, now let's say you want to randomly have different names, one beginning with A. Now this is a huge long list, all right? So in terms of a custom value, I can simply enter the names or keep adding in the names that I already know. So let's say if I take in an Al, is there an Alan in our name? Or let's say we already know there's a Sally in our name. So do we have a Sally? I'm going to say add the name Sally up, add the name Sanjeet up. So I can use a custom list because I already know the list. So instead of avoiding the pain of scrolling through this huge list, I know my values. I'm going to simply add in, enter the text and keep adding it. So that's a custom value list. I'm going to cancel the option because I want to right now stick on to customer's name beginning with S. All right. So that was an example where we can filter on a field. All right. Where I can filter on a dimension field. In terms of case sensitive, yes, we have to check on that because in most cases, Tableau is usually very case sensitive when it comes to names. So let's say we already know that we have a Sally in our list. Let us check if I have Sally added in as, so then in that case, you can see it's giving me a drop down option to select from in terms of the case sensitivity. And then all the possible names that are available for Sally, it's giving me the options to choose from. So that was filtering on a dimension. Now let me show you how you can filter on the measure, all right? So before that, let me show you one more option in using the conditions tab, okay? So from the wildcard, let me take a new sheet this time, and let's have a condition specified in terms of the filter. So this time again, let's have our customer names added into the filter. In the condition, now this is where you can specify whether you want it by field or how do you want to select it, whether you want to use a particular card, whether you want to specify a particular condition. Now, before I move in here to the conditions, there is one important thing that I need to perform. Back here, now here, there is no wildcard that's been used, all right? But let's say if it was the same filter in the previous one, then you will need to go back to the wildcard option and clear and uncheck the option because it will not then be able to take in all these tabs and detailings. So here I'm creating a new sheet, hence no worries. But if we do it in the previous sheet itself where we had the wildcard, then it's going to consider that it needs to be beginning with S as well as these conditions. But only if you want the conditions to be applied, then you need to clear the wildcard. all right? So the wildcard here, and let's say I want to know the field, and in terms of I want to know the customer names, wherein my sales, all right, is, let's keep the aggregation. Now these are the aggregations that you can choose from. Let's keep it default at sum, and my sales should be greater than 10,000, all right? Let's click on OK. Now you can also provide a minimum and a maximum range value, or you can then apply a particular formula. So you can apply a condition, click on OK, and now when we add in the customer name, now you can drag and drop it in the fields as well specified here. And now we get to see only those customers which are having the sales as we specified, which is about 10,000. Let's add sales, and we'll be able to see, let's enable our data labels. All the sale values are about 10,000 for these customers, all right? So you can add in a condition. Similarly, we can also change these and apply. So now I'm going to this time go to the conditions tab, and I'm going to click on the none option, because we're now going to have the top customers by field, where we now want to filter our data based on our top customers. All right, so let's keep it to default. You have the option of you want to see the top customers or the bottom customers. How many by numbers, 10 or a particular parameter. Those parameters is where we will be discussing when we proceed ahead and discuss the parameters topic. So yes, you will be able to filter on the dimensions and measures as well. So you can have the top 10 customer names based on my sales here. All right, or let's say you can have it on the basis of profit also. You can change it to profit this time. We're using a lot of sales. And let me click on OK. All right, so now what happened is, notice in our view, we're able to see the customer names, the sales by each of these customers that have been generated. For the top 10 customers, giving us the top 10 profits. So although profit is not in my view, these are my top 10 customers based on profit. All right, and what is the sales generated by each of these top 10 customers, and who these top 10 customers are. All right, so that's another way that we could use in the top tab option in the filter when we are filtering on a particular dimension. All right, now there's another way that you can filter. So you can click on a particular option and keep only or exclude it. So that is one way of filtering right onto your data. The other one, as we saw, was filtering, adding it up to the filter shelf. All right, right in the drop down, it also shows quick filter. So when you click on the quick filter option here, it gives you a special mark card that opens up where you can quickly keep analyzing instead of going and editing the option. It gives you the general option where you can keep analyzing a particular customer name that you want to see, and these are limited by the top 10. All right, so that's your quick filter option. You can remove it, you can apply it to the sheet, you can even customize. You can display how you want it to be viewed in terms of the filter option that is displayed, whether you want it as a multiple list or slider or drop down, a multiple value drop down, a custom list, or a wildcard match. All right, and based on that, then you can also mention whether you want to include these values or exclude these values, and finally you can hide the cards as well. All right, so that was your quick filter. Now you can also, as I mentioned, filter on dimensions. So let me add in a new sheet here and show you how you can filter on your measures now. So this time let's have our customer names onto rows. All right, let's have sales onto the filter shells this time. So we're going to be filtering. Now this time, if you notice, the filter shells, because it's a measure, it opens up as to how you want to filter. What is the aggregation that you want to use, whether you want to use all the values, whether you want to use a particular aggregation or some additional analysis in terms of deviation or variance. All right, I'm going to stick to the sum, the basic one, and click on next. This opens up the option now whether you want to filter based on the range of values, all right, whether you want to filter based on the least values. All right, so these are the different options. Let me explain each of these options as well to you all. So in the range of values, you can specify a particular range as minimum and maximum that you want to explore. So you can use the slider here as well and specify, let's say we want a value of approximately 5,000 and narrow down this particular data, all right, from 5,000. Now, you can see at times when you just want to use an approximate value, then it's fair enough to use these sliders, or another way of doing it in a simpler manner would be you can simply type in the details, all right. So you want it at 10,000 and 5,000, so you can also use the slider or use the particular type in box where you can type in the range of values. Next, you have at least. Now, this includes all the values which are greater than or equal to the specified minimum value. So it needs to be greater than or equal to 5,000 is what we are specifying. So any value that we add in, our same value should be above 5,000. That is at least. And at most is obviously then the opposite, that we are mentioning it should include all the values that are less than or equal to this maximum value that we're specifying. So if you're saying it should not be above 5,000, we are only wanting to see the sales of 5,000 and below. So that's the minimum and maximum value of at least and at most. And in terms of special, this is to do with handling your filter, your null values in your view. So this is a filter that helps you narrow down on the null values, whether you want to include the null values, whether you want to have the non-null values, or you want all the values added up in your view. All right. So based on that, you can have your selections and finally click on OK. All right. So let me click on the range here in this case. And you can select on a range, as I mentioned. You can click and have the option of, let's say, 5,000 onto 15,000 and click on OK. So now you're going to be able to see your sales, which is going to be in the range of 5,000 unto 15,000 only. All right. Similarly, you can also filter on dates. Now, when it comes to date as well, the filter window opens up in a different fashion. So we saw in dimensions, it opens up in terms of 4 tabs. In terms of the measure, it opens up the aggregation we want to use and then the values that we want to specify. Now, when it comes to filtering on dates, then in this case, what happens is that Tableau opens up a different kind of window when you're wanting to filter on dates. So let's have a look at that as well. So let me open up the filter dates option for you all. So let's have the order date added in onto my filter here. So this opens up the filter window wherein it is specifying the date here. Date field in Tableau is created in a special manner, a special dimension, and it often handles it in a different way. As you saw, even when it comes to hierarchies, it automatically creates a hierarchy for you in terms of dates. So even with filters, it handles it in a different manner. Here it specifies one, whether you want to use the relative date filter or the range of dates. Now, when you use the first option, which is the relative date filters, then here you're going to be defining a range of dates that is going to get updated based on the date and time that you open the view. All right. So it's more like whatever view you select. Let's say you want to see the year-to-date sales for the records of the last 30 days. All right. So in that case, you can actually specify selecting on the relative date, and that's where you can mention the detailing of I want to see today's date and the last 30 days of whatever is today's date. So that's how to use in the relative dates. The next option that you have in terms of the range of dates is where you can provide the range of a particular date, where you can give in the kind of date that you want to choose. All right. So in terms of range of dates, you will be specifying a particular range. And once you've decided and selected between these two options, then you need to select on whether which kind of a filter that on the drilling that you have, whether you want to do it on a year, on the quarter, or on the month. All right. So that's how you can specify that particular date. And let me click on the relative date option here and click on next. So when we open the relative dates, then in this case, you can see again, it's giving us special 4 tabs here. So the relative date in this case is we can specify, let's say the sales in the last couple of days. So we can specify whether we want to see the sales yesterday and last how many number of days, today with the next how many days, or we want to see the days, the sales for tomorrow. Similarly, then you have range of dates where you can specify a particular range. All right, whether let's say you have the data here coming in from 1st of April 2014 going up to 31st December. You can make use of the calendar and choose your specific date range. You can also use the slider here to specify. The starting date, again, it's more like the minimum and maximum. So starting is all the days starting from this date and above, and ending is that we want to have and see our data wherein the ending date should be 31st of December and sales achieved until this specific date, nothing beyond that particular. In case even if it's present, any data present above 2014 31st December, we're still limiting it that it should be until 31st of December. And then the special tab, which again gives us the flexibility in terms of filtering whether there are null dates, non-null dates, or you want all the dates to be included. All right. The option we have in terms of filtering on our dates. All right. So as you saw, we can filter right in the view where I mentioned you can have the exclude or include option. You can drag a particular field right into the filter shelf. You can also turn on the quick filter and make use of it. So that is the filter shelf. We saw depending on the type, we can filter on a dimension or we can filter on a measure or a date as well.
For complex analytical projects, organizing and simplifying data is one of the crucial tasks. It is important to be able to simplify data for proper analysis. Organizing and simplifying data is a critical part of Tableau mission to facilitate you to see and understand data. Tableau can help you with all stages of an analytics project by using these advanced capabilities. In this lesson, we will discuss advanced capabilities to complete sophisticated analytics projects. After completing this lesson, you will be able to perform filtering and sorting on data, create combined fields to merge data from different dimensions, create groups and define aliases, create and work with sets and combined sets, drill to other levels of data in your hierarchies, add grand totals and subtotals in a view, change aggregation functions for a measure, split a measure value into bins. The first topic that you will study in this lesson is filtering data. Jenny, the sales manager of a chain of departmental stores, is planning to launch a new branding policy for a line of furniture that sells well. For this, she needs to analyze the subcategories under furniture with sales over $30,000 in the year 2013. To discuss the matter, she calls one of the sales executive, Alex.
Hi, Alex. We are in the process of launching a new branding policy for a line of furniture with good sale. But to decide on the categories, I need to analyze which furniture sales crossed over $30,000 in 2013. Can you recommend a way to complete this task?
Sure, Jenny. I think what you need is a bar chart where you can filter the results as per your analysis.
That's right. How can we do this in the most efficient manner?
We can use Tableau application that provides a number of features to create bar charts and filter large amounts of data as per your desired analysis.
Great! You can start working on this task and present the analysis to me when you're done.
So before we proceed further, let's discuss what is a filter. Yes, you guessed it. Filters let you filter data. A filter is a condition which can be applied to dimensions, measures, or date fields to narrow down the data displayed in a view. In Tableau, they can be either static or interactive. Being able to filter data is essential to any analysis. With Tableau, data can be filtered in different ways. You can apply filter using one of these methods. Select data to filter in the view. Drag fields to the filters shelf. Activate quick filters. When you select data to filter in the view, the filtered fields are added to the filters shelf and the unwanted fields are removed. When you drag fields to the filters shelf, a filter dialog box opens. When you activate quick filters, the filter dialog box opens as a new card where data can be quickly added and altered. So, how can the dimensions be filtered? Dimensions can be filtered either on the filters shelf or in the quick filter. When you drag the dimension to the filter shelf, a filter window will appear. These are the key tabs of the filter window.
So how do these tabs function?
Let me explain each tab one by one. The first tab is the General tab, which helps you select the list of elements you want to include in the filter. You can use one of the following options to define the element list. Select from list. This option allows you to select the elements you want to include from the list. Next is the Custom Value List. In this option, you can use the search box to directly locate the elements. And the last one is the Use All option that allows you to include all the elements in the filter. Now you understand how General tab functions.
Yes, I do.
Great! Let's move to the next tab, the Wildcard. In the Wildcard tab, you can match the names of elements by selecting one of the following options: Contains, Starts with, Ends with, Exactly matches. Next, you have the Condition tab. With the help of this tab, you can specify a filter condition. In this, only the elements that satisfy the condition will be included in the view. To define a condition, you can use the None, By Field, and By Formula options.
These tabs allow you to perform.
You can use the None, By Field, By Formula options.
Thanks, Alex. Tableau really has some amazing capabilities.
Let me now explain how you can apply filter on measures.
Before you begin with that, Alex, I have a quick question. Does Tableau allow me to filter on a measure wherein I can select to either filter row-level data or an aggregated value of data?
Indeed it does. Tableau allows you to filter at row-level data in which measure value is calculated individually for every row in the dataset. No aggregation functions are used for row-level calculations. While in summary-level calculation, measure value is calculated using an aggregation function on the row-level data. Aggregation functions are used for summary-level calculations. In Tableau, the data is automatically aggregated by performing summation when a measure is placed on a shelf. When you apply filter on a measure, it allows you to filter row-level data, select all values. To filter summary-level data, select one of the available aggregation functions. Date filters are extremely common. Date fields are a special kind of dimension that Tableau often handles differently than standard categorical data. So far, we have learned how to perform filtering and sorting on data. Greg is planning to launch a new branding policy for a line of furniture that sells well. This demonstration will help you understand how Greg analyzes the subcategories by creating bar charts and applying appropriate filter to it. Open Tableau 9.0. From the home page, connect to the saved Sample Superstore dataset. Create a horizontal bar chart with subcategory dimension and sales measure. Drag the category dimension to the filters shelf. Filter only for the furniture category. Drag the order date dimension to the filters shelf. Select Filter Field as Years to filter only for 2013. Drag the sales measure to the filters shelf. Filter for subcategories with sum of sales greater than $30,000. Observe the change in bar chart after applying filters. Rename the sheet as Filtering Data. Save the workbook as Furniture Subcategories with Sales More Than $30,000 in 2013. close the workbook. This completes the demonstration on filtering data. The quick filter can get started for existing filters as well as for non-filtered fields. The filter dialog box includes these filter modes: single values, list, single value, dropdown, single values, slider, multiple values, list, multiple values, dropdown, multiple values, slider, wildcard match. The data can be selected from the given list as well as can be searched using the search icon present in the title area of the quick filter. With the quick filter option, you can quickly add and modify filters. You just need to follow 3 simple steps. Firstly, activate a quick filter on the region dimension. Notice a smaller representation of the filter dialog box opens as a new card. Quickly select what to include in the view. And you are done. Now, let us move to the second topic, sorting of data. Sorting data is an integral part of data analysis. Sorted data is easier to analyze. Sorting a data view refers to arranging dimension members in a specified order. You might want to put a list of names in alphabetical order, compile a list from highest to lowest, or order rows by colors or icons. Sorting data helps you quickly visualize and understand your data better, organize and find the data that you want, and ultimately enables you to make more effective decisions. In Tableau, you can sort data in numerous ways. Sorting can be performed on axis, specific fields, and manually. Tableau supports computed sorting and manual sorting. Computed sorting uses programmatic rules to sort the view, such as sorting alphabetically or from lowest to highest. Manual sorting enables you to reorganize the order of dimension in the table and can only be implemented on distinct fields with a distinct measure. Now that you know that the data can be sorted in different ways, let's discuss each of these in detail.
Sure, I would like to know more about it.
To sort on axis, you can single-click the sort icon on the measure axis to sort the bars in descending order, or double-click the sort icon on the measure axis to sort the bars in ascending order. The data can be automatically sorted using the Sort button on the axis to give a better view of data. To sort on a specific field, use the Sort menu option to sort by one or more fields in a specified order, then select the Data Source Order option to sort data in the order of the data source. The Sort dialog box includes these criteria. Sort Order displays the output in ascending or descending order. Sort By sort either by data source order, alphabetic, or by fields. To perform a manual sort, use the Sort menu option to sort manually. Then, rearrange the order of dimension members in a custom order based on your business specifications. Manual sort can be done in 2 ways. Use Sort Toolbar button on the selected item. Locate and drag headers in the view. Let us now move to the next topic, creating combined fields. Combined fields are used to create a cross product of members from different dimensions. 2 or more dimensions can be combined to create a Cartesian product of dimension members. The view includes all combinations of each member of the dimensions. Let's look at an example. A combined field has been created using segment and region. When added to the view, it displays all combinations of segment and region elements. Creating groups and defining aliases are some more features that Tableau offers. Let's understand each of these concepts. Let's say you want to view data at levels that are not already present in the data source. In such situations, groups are used to combine dimension members to create a higher level member. When a group is created, a default name is automatically formed using the combined member's name. The new grouped field takes over the dimension on rows or columns. For example, a group can be created by combining the sales for envelopes, labels, and paper for analysis. Now, the question arises that, can alternate names be provided in this case? And the answer is yes, you can. Aliases will provide the flexibility for renaming dimension members to help make more sense in the current view. The good part is Tableau does not change the original data on changing an alias in your view. You can change aliases at any time using the Edit Aliases dialog box. There are some things you need to keep in mind, such as aliases can only be defined for discrete dimensions and dates. These can be applied to dimensions only and not to measures. Moreover, the method for creating aliases depends on the type of data source you use. Following is an illustration of defining an alias for the east element of the region dimension. Let us now move to the next topic, working with sets and combined sets. Usually, you have large sets of data that you want to visualize. In such a condition, you might find that limiting the amount of information displayed to an important subset of records helps you work with and answer questions about the data more effectively. Sets are custom fields that define a subset of dimension members. A set can be created for specific dimension members in the view, or it can be based on a condition. Computed sets are dynamic as the number of members in the set can vary at runtime based on the condition. Furthermore, you can also drag a set to the filter shelf to quickly filter the view to display only the members of the sets. Likewise, you can also create a set by combining existing sets. All you need is to specify the logical operator between the two sets. New sets can be formed by combining the sets consisting of either all the members from the sets, only shared members, members existing in one of the sets. The dimensions of the sets should be the same in order to combine two sets. By now, you have a brief idea on how to create groups, define aliases, and create sets and combined sets. Greg is planning to launch an advertising scheme for certain product subcategories that are related to each other. This demonstration shows how Greg creates a visualization that displays the aggregated profit ratio and highlights the bottom 5 subcategories by sales. This demo will give you an overview on how to create a group to combine dimension members, create a computed set to include dimension members automatically, open Tableau 9.0, from the home page, connect to the saved Sample Superstore dataset. Create a horizontal bar chart with subcategory dimension and profit ratio measure. Select Tables and Chairs to create a group. Create a set on subcategory. Name the set as Bottom 5 Subcategories by Sales. Click the top tab. Under By field, select Bottom 5 Subcategories by Sales from the drop-down. Drag the Bottom 5 Subcategories by Sales set to the color shelf to the Marks card. Rename the sheet as Groups and Sets. Save the workbook as Working with Groups and Sets. Close the workbook. This completes the demonstration on working with groups and sets. Now, let us study how can we drill to other levels in a hierarchy. Jenny is required to present the company's sales performance across different regions, states, and cities in an upcoming meeting. She calls Alex to help her make this report in a quick and efficient manner.
Hi, Alex. I need you to create a report for me to present the company's sales performance across different regions, states, and cities.
Sure, Jenny. Are there any specific points that you want me to keep in mind?
Yes, I want to use the same data source for the detail and summary information. In other words, I want to create a report where all the data is contained within the same report. Can you suggest a way to do that?
Sure, Jenny. For creating such reports, Tableau offers the feature of hierarchy, where you can drill down to several lower layers of detail.
Great! Please start working on this report and share the final output with me.
I was just wondering, can we drill to other levels in a hierarchy? Yes, we can. A hierarchy is a grouping of related dimensions depicting direct parent-child relationships between them. Built-in hierarchies are not present in relational databases, but it can be inherited from the relational databases that have similar dimensions. It is useful in the following ways. It facilitates analyzing a high-level overview of your data and then drilling down to lower levels of detail. What's amazing is that Tableau separates the data fields automatically into hierarchies, so you can easily break down the view by year, quarter, month, etc. Moreover, it also enables you to create your own custom hierarchies. If you want to view your data at a lower or higher level in the hierarchy, then drilling is what you're looking for. For instance, you can drill up from date through year, or you can drill down from year to date. That way, drilling is one of the most suitable ways to navigate hierarchies. Various methods of drilling are available in Tableau. It allows you to drill using fields on shelves or drill using headers. Let me show you how. Drilling using headers can be referred to as uneven drill, as only desired members are displayed rather than all the members from the list. You can click a header value in the view and select Drill Down or Drill Up from the menu. Let's say it is drilled down from year level to quarter level. You can expand or collapse a dimension in the rows or columns shelf to drill down or up, respectively. The plus and minus signs on the fields that are placed on the shelves shows the drill status. So that means the plus sign indicates that it can be drilled down further, while the minus sign indicates that you can drill up but cannot drill down further. Greg is required to present the company's sales performance across different regions, states, and cities. He is required to create a report such that all the data is contained within the same report. Let's see how he does that. Open Tableau 9.0. From the home page, connect to the saved Sample Superstore dataset. Create a hierarchy by dragging state onto region. Name the hierarchy as Geography. In the Geography hierarchy, drag City below State. Create a report with region and sales. Right-click West, select Keep Only. Drill down from region to state. Right-click California, select Keep Only. Drill down from state to city. Rename the sheet as Sales Analysis. Save the workbook as Company Sales Performance. Close the workbook. This completes the demonstration on Drill Down Report. Now, let us discuss another important feature of Tableau, grand totals and subtotals. Totals facilitate the aggregation of data in a view. You can compute grand totals and subtotals for the data in a view. These totals can be applied only on grid-type visualizations. Tableau does not compute subtotals and grand totals as just an aggregation. Instead, subtotals and grand totals are computed as a separate calculation of the measure at a coarser level of granularity. Totals facilitate the aggregation of data in a view. You can compute grand totals and subtotals for the data in a view. These totals can be applied only on grid-type visualizations. Tableau does not compute subtotals and grand totals as just an aggregation. Instead, subtotals and grand totals are computed as a separate calculation of the measure at a coarser level of granularity. Tableau computes subtotals and grand totals as the original measure at a higher level of aggregation. Let us proceed with understanding how to define aggregations other than the predefined choices. Tableau allows you to define aggregations other than the predefined choices such as summation and variance. You can change the aggregation function by right-clicking a dimension in either the rows or columns shelf or by right-clicking a field in the data pane. Here, we have changed the aggregation function to average. Next, we are going to study about Tableau Bins, which are useful to create a range of data. Bins are custom bandings of the values of a measure based on a specific size. You can bin data only for relational data sources. It does not support this feature for multidimensional data sources. Bins can be referred to as buckets of values and can be created for numeric dimensions. There are two types that you can create: fixed-sized and variable-sized. You can create a fixed-sized bin by specifying the size of each bin in the Create Bins window. Keep in mind that by default, Tableau creates even-sized bins based on a size you specify. As you can see, I have created fixed-sized bins on the discount measure of size 10 each. To create a variable size bin, create a calculated field with an appropriate script. You will learn about calculated fields in detail in Lesson 8, Calculations. For now, just remember that you need to create a calculated field to create bins of variable size. Look, we have 3 bins on the discount measure of variable sizes. Now that you've gone through the need and importance of organizing and simplifying data, let us have a quick look at the key takeaways. Filters enable you to narrow down the data displayed in a view. Sorting refers to the arrangement of dimension members in a specified order. Combined fields are used to create a cross-product of members from different dimensions. A group is a combination of dimension members that make up a higher-level category. Aliases are alternate names for specific values within a dimension. Sets are custom fields that define a subset of data based on some conditions. Drilling helps you analyze the data in a view at a lower or higher level in the hierarchy. Bins are custom bandings of measure values. They can be created either as fixed-sized or variable-sized. Time for some hands-on practice. Let's now understand the below scenario and work on it together. You are an owner of a store and want to analyze the existing discount strategy offered by your store. You wish to view the number of customers who have been offered discounts between 0% and 10%, 10% and 20%, and so on. Create a histogram with discount bins and count of discounts and answer the following questions. How many customers were given discounts between 0% and 10%? What is the total sale recorded when customers were offered a discount between 20% and 30%? Now, wasn't that a great experience? You will be happy to know that we have 2 more similar scenarios for you to strengthen your understanding of organizing and simplifying data. Read the scenarios carefully and perform the task on the Tableau 9 tool downloaded onto your device. You can evaluate your steps by referring to the solution guide provided in the Download Center. Scenario 1. You work in an e-commerce company's division that deals with the dispatch and delivery of shipments is facing losses. You are required to identify the customers who mostly tend to return their orders. You need to focus on the list of customers who have returned their orders more than half the time. Using the Sample Superstore Excel sheet, you have to create an appropriate visualization and answer the following questions. How many customers do you have on your list? What is the distinct order count for customer Hillary Holden? Which customer has the highest count of order returns? Scenario 2. You are a store manager of a leading retail chain in the United States that wants to launch a discount campaign to promote the sales of related products. As a part of this campaign, you need to analyze the aggregated sales for envelopes, labels, and papers. You are required to see the combined sales of these products on a graph. Create a bar chart showing the accumulated sales for paper products and answer the following questions. What is the total sale of paper products? What is the profit ratio for paper products?
We have our next topic, which is working with aggregation options. Alright, now this again you've noticed a couple of times that by default we have our calculation wherein Tableau takes in a default calculation, alright, being the sum. But you can change these aggregation functions. You can see an entire list that Tableau provides to us, alright, and that's how you can make use of these aggregated functions. That is your whether you want to have a summation, whether you want to have an average. Alright, so there are different mathematical functions here that you can see, and these each will produce a particular aggregated data. Alright, so these are what are called your aggregation functions. Alright, and these will help you perform the kind of aggregation, the kind of calculation that you want to perform on that particular field. So you can make use of these functions. Alright, and so now understand one thing, you can use Tableau to set up your aggregations only for measures in your relational data sources. Alright, in terms of a multi-dimensional data source, it contains the aggregated data already. Alright, so it provides you these list of predefined aggregations here, as you can see. So let's understand each of these functions. Now when it comes to an attribute, alright, in this case, this is going to be returning the value of your expression, which has a single value for that row. Alright, so let me move to the environment here to understand and explain what these particular functions are. Alright, I'm going to pick up and discuss a few of them. Now let's say we have sales. Alright, sales by default, when we talk about the aggregation function, so you need to right click and go to default properties, and you have the aggregation option where you can see sum is set to default. You can change these default properties to the aggregation that you wish to, which are present here. Alright, so you can have an average, you can have a median, a count distinct, and then various other options present here. Right, so when it comes to using an attribute, alright, or the attribute aggregation function as specified, then in that case it's going to return the value, alright, of the expression as one particular value of the row. Okay, so in this case it shows the field then changes to a text icon attribute where it ignores any kind of null value if it's present. Okay, so you can basically make use of these when you want to only pull in, let's say, values of all the rows which is otherwise displayed as a different values in it. Okay, so that's when you can make use of it. Now that is not present here in this case, as you can see, as an attribute. That comes in handy when you're using calculated fields. Alright, so let's say when you open up a calculated field, you will see you have the attribute which is termed as ATTR, the attribute expression. Let's say we're saying the attribute of sales. So you can notice it gives you the entire definition. It returns the value of the expression if it only has a single value for all the rows in that group. And in case if not, then in that case it will display it as an asterisk sign. So that's what it does. It's useful. Basically, this aggregation is useful when you want to aggregate a particular dimension. Alright, let's say we have customer names. We want to aggregate and come on to the number, the names, the total number of customers that you have. So in that case, it will only return single values of that row. If not, then it will otherwise display as an asterisk. So that's when this kind of a function comes in handy for us. Not that you cannot use it with measures, but just an example of the best use when you want to aggregate a particular dimension and you want null values to be ignored, you want to know the single values of all the rows, then this particular aggregation function is going to be helpful. All right. Then in terms of your next one, you have dimensions. Now these again will return all the unique values, all right, in your measures or dimensions, both. So it's going to only bring in all the unique values here in this case. And in terms of sum, we are already aware. In terms of average, then you have median. Now this is again to do with, it's going to return the median of the numbers in the measure. Then you have count and count distinct. All right. So count is going to ideally return the number of rows in your measure or dimension, and in that case, null values are again going to be ignored. But in terms of count distinct, it's going to return the number of unique values. So count will return all the values, the number of values which are present. But in terms of count distinct, it will return the unique values in a measure or dimension. All right. So that's how you have various aggregation functions, and to know details of each of these, you can make use of the Tableau provides the details about each of these, because you have various, as you can see, your various inbuilt functions. There's an entire list of functions that you can make use of, and anywhere you need to know additional details. Now these are the basic ones that you can see, the inbuilt ones. So if you want additional aggregation functions as well, you can make use of these functions from the calculated field, and each of these has its explanation provided. But in terms of the basic usage one, the ones that you can change it to default, here's a basic list that Tableau provides. So it has additional functions as well, but that's when you'll have to then open up the calculated field and make use of those functions. So that was your aggregation functions. All right. Then comes in your grand totals and subtotals. We're already aware, we've seen this in our earlier examples, that we're able to make use of our totaling option. We're able to add in the grand totals as well as subtotals of the data, wherein we can see the grid that is displaying the subtotals and the grand totals here for us. All right, you can see the grand total right here, and you can see the subtotals for each category level as well. And the grand totals across every subcategory for its particular category towards its particular year. All right. Now, to enable your grand totals, you can simply go to the analysis menu. So you've seen that in our earlier examples as well, and that's where you can go to the analysis totals, and you can make use of and have your totals enabled. So that's how you can have your totals.
Let me begin with the next topic, which is calculations. All right. Now, in terms of calculations, these are pretty much, these help us in terms of understanding, in terms of creating an extractful, meaningful result of our data, all right? So sometimes it's pretty much necessary that we make use of calculated fields. Now, you've already seen that I've been making use of, we created the ship to date, and I created various calculations, and I've been mentioning that, I'm going to discuss these in detail in the next topic when we have, like, we created the primary table, the secondary table. I showed you the quick table calculations. So you're already pretty much aware of how I was using them, but let us understand these in detail now, all right? So let me begin. So at the end of this session, in terms of when we complete this topic, you are going to understand how you can make use of strings, dates, logical as well as arithmetic calculations, how you can work with different aggregation options, how you can make use of the grand totals and subtotals, the quick table calculations which are inbuilt by Tableau, how you can create automatic and custom splits, discovering the ad hoc analytics which is offered by Tableau, and how you can perform the LOD, that is level of details calculation. All right. So let's begin with the very first topic, how you can work with strings, dates, logical and arithmetic calculations, wherein you can create a completely new field which is not present as part of your underlying data. You can actually create that using a specific formula. There are functions and operators provided. So you can use a string, all right? You can use a date, you can use logical operators or arithmetic calculations, and based on that you can then apply certain functions and operators and finally create a calculation. So you can create these 4 kinds of calculations: the arithmetic, date, string, and logical ones. Alright, so let us understand and explore how we can use, how Tableau provides us various built-in functions wherein we can use a calculated field and create an arithmetic calculation. So we've seen an example where I created a profit margin or a profit ratio in our earlier exercises, in our earlier demonstrations, wherein you can use, let's say when you want to create the profit ratio, we use the sum of profit divided by sum of sales. So that's how we created an arithmetic calculation. Similarly, we can create and use string calculations. Alright, so I'm going to show you an example of each of these. And then we can also, we saw right now I created the days to ship in the earlier example for one of our views, wherein I used the date calculation where we created the day, and we will also make use of one of these logical calculations to see and understand how we can make use of the if-else, the logical calculation operators and functions, and make use of these calculations. So we have a scenario here. So before that, let me move on to our Tableau environment here. All right, and let me start showing you one of the examples of each that we can use in terms of creating them. All right, and in here, let me quickly create one simple view. So I'm going to add in. So I'm going to add in my states to rows, and I'm going to add sales to my columns, and quickly create one bar chart here. All right. Now I want to have my, let's say I want to analyze the sales across each state here, all right, but I also want to know the count of distinct items, all right. So in this case, what I'm going to do is, let me have my product name, all right, because I want to know the count of distinct items. I'm going to right click on the product name here, and I'm going to then drag and drop this to the columns over here, all right, onto the column section. Now, because I've selected the right click option and then dragged and dropped in the product name dimension onto the columns, it opens up the drop field as to how I want to use it, whether I want to use, since I want to use a distinct field in analyzing, all right, it's opened up this particular window of whether I want to use a count product name or a count distinct product name. All right, so I'm going to select the count distinct because we want to distinctly analyze the counts of the items. All right, and click on OK. All right. What are aggregation functions? Aggregation functions, Diksha, the sum, the average, these are the different aggregation functions. So right now the basic default is sum. All right, so it's summing up the measure, whatever measure we've selected, that's the aggregation function. So whether you want to sum it up, you want to average it out, you want to use median, count, minimum, maximum, these are all the inbuilt aggregation functions provided by Tableau. Or then you can also use the aggregation functions when you're using calculated fields beyond the ones provided. So those are aggregation functions. Yes, we have a bar chart. I'm going to still analyze and show these details to you further in terms of aggregation. So what I did was, instead of just using the product name as it is, I've used a count distinct, all right. Could you please drag and drop the product name? You want me to show that to you once again, Siva? Yes. I'm going to take this off my columns here. Now, when I want to add my product name, if I directly drag and drop it onto the columns, it's just going to add up the details asking me how I want to use it as a dimension. Now, that's not what I want to do, because as per the analysis, I want the count of distinct items, right? So for that, I'm going to simply right click on product name, and then I'm going to drag and drop the product name onto the columns. So in that, it's going to then ask me what is the aggregation I want to use on my dimension. And I want to use the count distinct. So you can see count product name and count distinct product name. So I'm selecting the second option and clicking on OK. Now I want to see the sales per item sold, and this particular field is not available in my data set. So what I'm going to do is I'm going to create one using my calculated field, because I want to see the sales per item. All right. So let me right click on my sales here. All right, in the data pane. So one way of doing it is you can right click, or in the drop down you have the option of clicking on create a calculated field, all right, for that specific field, or in the data pane, in the drop down here it says create calculated field. Okay, you can select either option. When you select the drop down from here, it's blank and you'll have to input the formula. When you select a particular field and do it, then in that case it opens up and adds in the field by default, wherein then you can specify the functions and operators. So let me specify the arithmetic calculation here. So the first type that I'm showing you, the very first option in terms of calculated field, the arithmetic calculation. All right. So let's have our sum of sales, and I'm going to divide this because I want to know sales per item sold. Now that is the reason I've created the count distinct product name here. So Diksha, when you mentioned you're seeing 2 bars, the only reason I did that was right now I'm just trying to create a count product name, and once I add in the details, I'm then going to replace the particular view from it, all right? So I'm going to divide this with the count product name, all right? So that's how we are creating our sales per item calculation using the arithmetic calculation method, sales per item. So I'm dividing the sales based on the count distinct of the product name, all right? And let me click on OK. And with that, in the measures, we have a new measure that's added up, which is the sales per item. This particular calculated field, I'm going to place it, it's getting placed in the measures directly because it's returning a particular number, right? The numerical value, and hence it's placed in measures. Now let me add my sales per item into the columns. So I'm going to replace my count product name here, all right? So here I can now see, you can see notice, and this shows aggregated, all right? This shows it's an aggregated, means it's a calculated field that's been used now, all right? So I'm able to see the sales per item. So I'm comparing the sales versus the sales per item on a distinct basis, all right? And I cannot change the aggregation function here. So notice earlier when I specified the default function is sum. We can change these aggregation functions for a particular measure from the inbuilt ones, or we can specify it as a calculated field. Now in this case, it does not give us any option to change the aggregation function. It shows it's aggregated already because it's a calculated field. It's taking in the aggregation as we specified in the arithmetic calculation. All right. So that was your example of having your calculated arithmetic calculated field. So here we can see the sales per item for each state, right? So this kind of an example is an arithmetic calculation. Great. So let's move on. Now we've already seen, we've covered up the first type, which was arithmetic calculations. Now let me show you an example of how we can use calculated fields and create a string calculation. All right. So let's say we want to analyze the customers beginning with the name S, all right, the one that's illustrated in the slide here, which says that we will be analyzing the customers beginning with S. Okay, so in this case, let me add up my customer name into the rows, right? And let's have profits in the columns. All right, so we have customer names in rows and columns. All right. Now, what I'm going to do is, let's consider that at this point of time, we have a range, we have a scrolling, and we have a range of customer names here. And I only, let's say, want to, at this point of time, let's say I want to develop and come up with a scheme that all the customer names beginning with the word S, all right, they are entitled to getting a discount, all right? We're coming up with a particular offer. Now, it would be pretty difficult if I add up the customer name in the filters here and then manually select the one with S, right? Or I can also use the wildcard, wherein I'm using the option to select one with an S. Similarly, I can also make use of the calculated field to achieve the same scenario. So let's click on create calculated field. Let's name this as customer with S. All right, customer beginning with S. And now we're going to provide, now if I expand this arrow here, you can see there are a lot of functions provided by Tableau in terms of number, string, date, type conversion, logical, aggregate, user, and table calculation. And that's where, based on that, you can make use and selections. And it also specifies the kind of requirement of a small definition and example preview of it. All right. So in case it's difficult to remember all the aggregations, it's difficult to understand how it's created, you can simply click on the types, and that's how you can come up with the definitions of these as well. All right. So let's have the function starts with, because we want all the customer names starting with, and we want it for customer name beginning with S. Now, in terms of the calculation, it's telling us there is a particular error. So let's find out, does that. All right, and now my calculation is valid. I have my customers beginning with S. All right, I'm creating a calculated field and click on OK. Now this is going to bring in a string function. So when I click on OK, it adds up a Boolean logic, a true and false data type, and it adds it up to the dimensions because it is related. It is based on the string functions here for the customers. All right, so this is how we have a calculated field selected. And let me this time add up the customers with S into the filters. All right, and now it gives me the option of true and false. All right, whether I want to include it, whether it's true or false. And let's say I'm going to say that I want to include that particular option with the customer name beginning with. All right, and we do not see data here. Let's just check what is the problem here. This is excluding our data. Just give me a moment. We have our customers. Let me quickly edit. Starts with customer name S. And this is absolutely okay. All right. So we have the true and false option, and we want it true as the customer's name beginning with S, and click on OK. And we now see a list of customers' name that is beginning only with the letter S. All right. Jacqueline, start with customer name. So this is how we can make use of the string calculations. All right. Next, now let us see how we can make use of the date calculation. Now we've already performed this kind of a calculation, so I'm going to explain in terms of the date calculation when we wrote in the dates to ship, what each of it meant, all right, when we wanted to analyze the difference. Yes, it's going to be case sensitive in that case, Sujay, you're absolutely right. So in case if it's not a lowercase, it's not going to take in the function. Tableau somehow has a case sensitivity and it only takes in a lowercase. I'll show that example to you. So when you're saying that, no, in terms of the letter S, it's not going to be case sensitive for the alphabet because you're saying customer names beginning with the alphabet S. In this case, it's not, but overall it's case sensitive. I'll just show you that example in terms of the date calculations right away. So going back on our Tableau sheet here, we have the dates to ship that we've already created. So I'm just going to click on edit. Now in this case, if you notice the date difference, what needs to be specified for a date difference is there are three parts to this. All right. So let's say now we wanted to analyze the number of days it took for the order to get shipped. All right. So in our data set, we already have the order date. We have the ship date. All right. And we want to calculate how the number of days is required in terms of shipping the product. So I've used in the date difference function. And in this case, then, we need to use, there are three inputs that comes into picture, all right? There are three cases here. So the first one is wherein you want to specify what part, what role is it going to play, Alright, so it's going to play the role of a day, because I'm finding out on the basis of day, you can add it as week, month, depending on the role that you want to play. And then the difference between those two values that you want to subtract, the difference that you want to have between these two. So we have the order date and ship date. Now, if the same day, you can see the calculation is valid. Now, let me change this to day. And you can see that it shows an error in the calculation. So in this case, it needs to be a lower case. That's when the case sensitivity is, it takes an effect and it's going to throw in an error in case if you're going to write that. Right, in terms of the first parameter, all right, it's not going to be case sensitive because you're only specifying the customer name here. So you're picking up that from the customer name, what is the letter alphabet that it should take up, all right? But in terms of the date, ship to date calculation field, you need to, it's case sensitive where it only works with lower cases. Because here you're specifying what part is it going to play. The day to ship, what part will it play in terms of the difference? It's going to play the part of day. Alright. So that's how you can create the days to ship, and you can make use of the date functions and you can create a date calculation. Alright. That's how we have the days to ship option. And we can make use of it, although it was not present in our data, and we can analyze our entire data here in terms of creating the days to ship. So that was your days to ship date calculation. Similarly, then you have the logical calculations. All right, so I'm going to show you an example of how you can use a condition or a logical calculation and use them in terms of your analysis. So let me go back to our environment here. Let me create a new sheet. Now let me give you a scenario here that we want to highlight all the subcategories that has sales of more than 100,000. Alright, so for that we're going to create a calculated field that will only specify the sales of subcategories of 100,000 and above. So let's create the calculated field. Let's give it a name as sales KPI. And now this is where we're going to provide logical functions and operators. And let me enter the syntax. So I'm saying if my sum of sales so the bracket, if my sum of sales is greater than 100,000, then high, else low. And let's end the syntax here. Is my calculation valid? Yes, it is. And I'm going to now create a sales KPI so that I can highlight the subcategories having sales more than 100,000 as high and low. All right. Let me click on OK. And now we have the sales KPI that's added up to the measures. But we've used, you can see, although it's a measure, it's showing the ABC icon here in terms of the data type because we have it as high and low measures here, all right? So in terms of the expected, let's see the expected output here and see how we can make use of it. So I'm going to add in my subcategory into the columns, and let me add my sales into my sales KPI into the row, right? And or rather I can add up, let me add sales to my rows, all right? And this is where now when I want to highlight, that's how I can create the calculated field and add it up in the colors so that it can distinguish between high and low. So I'm adding up the sales KPI into the colors, and now we can distinguish that the KPI is one which is above 100,000, it's high or then low. So these are the ones we can identify between high and low, the alerts that we can make use of. Elias, you have a question in date difference. Is it considering the order date minus ship date or ship date minus order date? Minus referring to minus. 1 second. Let me just open up the ship date. When you're saying it is order date minus the ship date, right? So that is what it's going to refer to, because whatever is the order date minus the ship date, that's how we're going to get the date difference, right? The day it took to ship. Excellent. All right. Yes, I am at sales KPI. Let me open that up in terms of editing if you want to edit that particular. Yes. Dilip, you asked me to open up the sales KPI. There you are. Can we use a multiple condition? In terms of multiple condition, if you're saying that high, average, and moderate, is that what you're saying? Like, let's say you want to say that if sales is 1,000, then it should be high. Else if sales is 80,000, then it should be moderate or low. Then you can use the else if operator. That's how you can add up the else if operator and make use of the detailings. That else if sales is greater than or less than 80,000, then create it as, so you can use that multiple option. Only thing is you'll need to use the else if option then in this case. Yeah, so you can use multiple conditions. Like, let's say, let me quickly show that example to you. So if you create a calculated field here, you can use a case in which you can mention the east, west, or low. Right? So you can use different kinds of examples and cases and scenarios where you can mention the different sales and budget. That if my sales is so much, then it should be that particular date or else. So you can use multiple functions. That's not going to be a problem. All right. So this is going to be an example of your logical operator.
Now, coming on to quick table calculations, let me now discuss on this because the other topics were recaps that we've been performing. Now, you've also seen that there were instances when I performed quick table calculations, all right? So, these are basically calculated fields when we apply a particular calculation at a data set level. All right. So Tableau provides certain functionalities. It provides certain functionalities here in terms of applying the calculation at your table level. So as the name suggests, table calculations, it allows us to provide that kind of functionality wherein it computes the applied values. All right, in your entire table. And this is basically dependent on the structure, the table structure that you have in your view. Okay, so that's how you can make use of table calculations. And what Tableau does is it provides some inbuilt functions which are usually in use. It provides it as an inbuilt quick functions where you do not have to input any kind of formulas in those functions. You can simply click on those options and it's going to immediately compute the entire range specified that you're selecting. All right. So let's see one of the examples. So I'm going to take you to the environment here and let's have our order date in columns. Let's have our sales in rows. And let me just enable the labels as well. All right. So that's created a line view since it's a series over time. So if you remember in the chart types, the best example is to make use, the best reference is to make use of a line graph, and hence Tableau automatically creates a line chart here for us. All right. Now we have the yearly sales as we can see. All right. Now let me add sales again to the rows. So what I'm going to do is we can see two sales calculations here. So what I'm going to do is with the second calculation, I'm going to, in the drop down, you have a quick table calculation consisting of all your detailed calculations here as you can see. So you have the running total. So this is going to show you a cumulative total. All right. Then you have the difference. So this is in terms of showing you the entire difference about some absolute change between the measures that you have. All right. Then you have the percent difference. So this will give you difference in terms of a percent value. All right. It shows you the difference in terms of those options as a percent. Then you have percent of total. So this is going to give you the values as a percent to the entire total. So what is the contribution of each year in this case to the entire total that you have in terms of the contribution, all right, the sales. Then you have rank. So this is going to rank our values numerically. We have percentile, which is going to compute our values in a percentile manner. We have moving average. This is going to calculate the fluctuations in terms of identifying any long-term trend, all right. Then year-to-date tables, then you have compound growth rates year over year, all right. So there are various such functions that you can see here, which are provided by Tableau, all right. Now I'm going to change and use the percent of total, all right. So this is going to give us the values of the percent for every year that it is contributing towards the entire total, what each year is contributing. So let's click on percent to total. And now we can see here the second sales bill, there is a calculation icon here in terms of the triangle icon that you can see, which says that we performed a table calculation on the second sales bill, all right. So in that case, we can now see the percent to sales for all the years. What is the contribution? All right. So that was a quick table calculation where it allows us to apply based on our requirement the defined functions. We can simply click and view those calculations instantly in our view. All right. And now in a lot of cases, we might want to customize these calculations. So that's when then you can have your additional table calculations that you can manually perform. All right. There is a question put up raised by Shubhani. Shubhani, in terms of moving, now when we're talking of moving average or any kind of moving function, all right, here it says moving average, but this is one of the calculations. So it can be a moving average or any other calculation, wherein moving calculations will ideally show us a fluctuation that we can identify in terms of long trends, all right. So that is what moving calculations are. So we will see an example of this, of what are moving calculations, and that's how you'll be able to understand the difference of what these are, right? And again, like I said, to understand these in details, we can also make use of the aggregation functions, the calculated field, where it can give us the entire detailing, right? So this was a quick example. Let me add this as a quick table calculation. Now next, as I mentioned, these are inbuilt ones that we made use of, but there are times where we might want to customize these tables, all right? So in this case, let's have our order date back in columns. Let's have our sales in rows, right? We've again created a view. Let's have, now in this case, I'm not going to add in another field. I'm going to perform the calculation on the sales bill itself that we have here, right? So here on the sales bill. Now instead of quick table, I'm going to select on add table calculation because we want to provide a customized one. So if you've seen an example earlier when we wanted to build in a Pareto chart or other kind of charts where we made use of table calculations, right? It calculated our data in terms of calculations across at the table level. So let us understand how these calculations come into picture, how they compute the values at the table level. All right. So these are the drop downs again provided in terms of the functions, the computations that we want to make use of and apply to the rows in our database to calculate our values. All right. So let's say I'm going to select running total this time. All right. And instead of the, how do I want to summarize? So I want the running total, and here again, whether I want it as a sum, as an average, or minimum or a maximum. Let's say I'm going to pick up average. So what we're doing is we're going to be seeing our sales as an average running total here. All right. And in terms of running along, whether you want it across the table, a particular cell, all right, or a particular field in this case. So we can specify. Now, since we have order date in our view, it's giving us the option to select from the available view. So let's have it running across, and let's have it across the order date. All right. So that's how we can select each of these different requirements and compute the value that we want to perform. All right. So that's how we can have these computings that are taking place. All right. So when you talk of table across, then in this case it computes the entire table. It will compute the entire table across here that we can see in terms of the tables here which are present in our view. Alright. When we talk about calculating in terms of the cells, alright, then in that case it's going to pick up the individual cells present in our row. Alright. So in this we are addressing to the individual cells which are present. Now had I changed this to a table view, then that's when we would specifically talk about, let's say we were at a year level and we had aggregated this as a quarter level. Let me just change that option and show it to you all so that you'll get a better idea. Let's have this at a quarter level, alright, and let's say let me add in region as well. Now in this case, we would be talking about individual. When we talk of table calculations happening at cell level, we're talking of an individual level, alright. So we're talking of for 2011, for the central region, for quarter 1, alright. So I wanted to address individual cells and perform the calculations, alright. So that is what would be the cell level. Or then I can select an individual field. So that's when we were selecting the order date. And in that case, we could select a particular field and mention that it needs to compute at that particular field that I'm specifying. Alright. So I'm just going to undo and go back to our previous view where we were performing our table calculation and we selected the running total. We had our summation summarizing at average and we selected a particular field. Alright. And let's click on OK. Let me enable the data labels. So here now we can see a calculation where it's performing a running average of sales here for us now. Alright. Now in the same case, let's say we want to also have a secondary. Now that was our basic calculation. Now let's say I want to perform another calculation. I want to apply it to this particular table. So then we can also apply a secondary calculation in that case, wherein we can combine two calculations and we can perform one on one of these calculations. So let me, on the drop down you have the option of edit table calculation or clear it. So let's click on edit and this is where you can see the checkbox that says perform a secondary calculation on the result. So what Tableau will do is it will first calculate this particular primary calculation that you have, alright, the basic calculation, basic table calculation that you're providing. Once it computes this particular calculation, it will then perform a secondary calculation, a second calculation on this particular result. Alright. So that's how it's going to then compute and combine two calculations in this case. So in the second example, let's say, let me specify, let's have the difference from, let's keep it to basic. So the first we want it as the running total. Once it's given us the average running total, I then wanted to perform a secondary calculation on the running average of sales where I want to know the difference from in terms of what is the calculation that I want it to provide. Alright, so let's again keep it at the level of let's select order date again. Alright, so again I wanted to perform at a particular field. And what is the level that I want to specify? So here in this case, since we are mentioning the order date, do I want it at the deepest level, alright, the granular level, or do I want to specify it at a particular yearly, quarterly, monthly or daily level, or the entire aggregate of the order date? So let's say I'm going to specify at a yearly level that I wanted to select, alright, and let's click on OK. So it's now performed a secondary calculation based on the previous one, and that's how we can make use. This is useful when we want to perform our calculations to our data in the table, and instead of a single calculation, there might be times, there are instances where we might want to combine two calculations. So that's how you can make use of the basic and the calculations in terms of having a secondary one as well. So let's say you want to calculate the year-to-date growth. Alright, and once you have the year-to-date growth, then based on that you might want to then compute that once I have that calculation, I should get the percent difference for each total in the previous year. So then that's how you can apply and make use of your secondary calculations. Alright, now you can also customize these calculations. Alright, so we have the option, as I mentioned, you can go to the edit selection, and that's where you can edit your tables and have the editing provided. and we have a scenario here now, a company, and they want to increase their market share, right? And in this case, they want to ensure that they're having higher profit margins, all right? So what Jennifer needs to do is she needs to ensure her company's sustainability, and hence she needs to identify the opportunity for business and how she can make the most of it, right? So for this, she needs to determine the sales variance for year-over-year growth based on a quarterly breakdown. So let us achieve this particular scenario. Now, to achieve these as Jennifer, what is Jennifer going to require to do, all right? So let's first quickly on our notepad add in our requirements. So for us to achieve this particular scenario for Jennifer here, what we're going to be doing is, firstly, we will create, now since we are going to talk about year-over-year, we're talking about time-based analysis, we will create a line chart, right? So we will have a line chart in terms of our sales based on orders at our yearly level. Next then, to further proceed with the scenario, now we need it at a quarterly breakdown. So we're going to drill, and we're going to drill at a quarterly level. Finally then, we are going to create a table calculation because we want to know the sales variance for year-over-year growth. All right. So hence we will create a table calculation, and this is going to be in case of difference because we want to know the difference, the variance for year-over-year growth for our sales. All right. So let's achieve this particular scenario going to the environment. And let's begin with our analysis here, all right? Let me have my order date as mentioned at a yearly level. Let's have our sales, all right? And that creates our line chart. We are done. Next, we need to drill at a quarterly level, all right? So let's drill our data and have a quarterly level, all right? And finally then, let us now we need to perform, we can see the sales, and now we need to know the variance, the difference, all right? We want to know, we want to create a table calculation with difference. So I'm going to add in another instance of sales here to our rows on which we perform our calculations, all right? And now I'm going to make use of the quick table calculation because we want to know the variance, the difference for year-over-year, all right? So in this case, I've dragged my second pill, and let's have it at our the difference level here, all right? So we can see the difference. Now that is one way, but if you notice, it's still a little difficult in case of judging the entire view here, all right? So what I'm going to do is, to make our view better, let's have our sales fill, all right, from the row shelf. Let's add it up to the color shelf. So what it's going to do is, on the existing sales view, it's going to identify and distinguish between the colors for the difference that we have, and that's how we'll be able to identify the difference. So let me just drag and drop it, and we can now see our view where we can identify our sales and the difference which is based on its color. The red, the darker the side, the difference of sales is, our analysis here says that it's in minus, all right? And in terms of a greener, the difference is on a higher side with green, right? So that's how when you hover as well, then at a quarterly level, you can see that for 2007, we have a particular sales and its difference that we can see, right? In terms of the previous table. So that's how you can make use of your calculations and achieve our scenario. So let's name this as sales analysis, right? Right, so that's how we're able to achieve and have the sales variance of year over year, that we can notice the growth, and based on that we saw the quarterly breakdown as well, where she can now identify the growth opportunities for business, right? So that's how we can make use of table calculations.
Hey, this is Tyler Lubin at Visual Intelligence Consulting, and today we're going to talk about the difference between sets and groups. Sets and groups are very similar. They're almost the same thing in the aspect of groups are a simpler version of a set. So when you want to group something, you select multiple things and then you group them into a higher category. So you're creating a higher category of a smaller subset. That would make more sense once I show the example, but the main thing here is you are grouping in one dimension and creating a new dimension with that grouping. A set is a more complex and dynamic grouping. So as I said, with the grouping, you're looking at one dimension and grouping the members within the one dimension. With sets, you can group across multiple dimensions and also set conditions to make it a dynamic set. So today we're going to show you some different groups that we can make, how we can create a region by grouping states, and then show some examples of a constant set, a dynamic set, and then how you can do a join of two different sets to make a combined set. So here we're going to jump into the standard grouping. So here's an example where we have subcategory. So we have all of these different subcategories, and I want to group these into a main category, which is going to be furniture, office supplies, and technology. So I'm going to click on the first one and hold Shift to select all the ones under it. So bookcase to tables. I'm going to hit this little paper clip, and then I grouped all these into another group. So as you see here in the data, we have subcategory, which was the dimension that was in the view, and then once I grouped it, it created a new dimension called subcategory group. So now this is the one that we're working with. We're not replacing subcategory, we're creating a new dimension of the grouping that I'm going to do to subcategory. So now I'm going to continue grouping. I'm going to grab appliances and go all the way down to supplies. And those are going to be all my office supplies. And then I'm going to grab accessories all the way down to phones and group this. And these are going to be my technology. So here I right click the group, edit alias, rename this. Same thing with my office supply groups. And my furniture. All right, so here I have the new subcategory group. I'm going to bring over the original subcategory. And now you see that I created this new group here with all of the subcategories under it. All right, so let's go ahead and just bring over profit, create a simple bar chart, and let's color this by this new subcategory group we created. So now I can see easily the different main groupings. All right, so this is one example of grouping. Another example of a grouping is to group states into a region. So now if I have all of these different states and I have custom regions or just a standard region, I can group these states into a custom region and then map it. So in this example, I'm going to create Central, East, South, and West United States. So here I'm clicking Illinois, and then I'm going to go all the way down to Wisconsin, and I'm going to group this, and this is going to be my Central. I'm going from Connecticut all the way down to West Virginia. This is going to be my East. I'm going to click Alabama and go all the way down to Virginia. This is going to be my South, and the rest will be my West. So as you see, I created a new calculation, state group, rename these, Central, East, South, and West. And I'll do the same thing. I will bring over the original state because I did not replace it. And now you can see the states are being grouped into a higher category called state group. So then I can rename this to region. And now I have regions here. So let's remove state. Let's bring profit over. And then now let's map this. So now you see I have the region that was created by the states mapped into this nice visualization. All right, so just to clarify, as you see, groups are looking at one dimension, grouping them, grouping all the members into a higher category. So that is very helpful when creating ad hoc analysis, as well as creating standard dashboards if you don't already have those groupings in your data. Next example would be an example of constant sets. So in this example, I'm going to look at profit and sales by subcategory. All right, so here we see all of the different subcategories plotted out by profits and sales. So sales going horizontal, profits going vertical. So I wanted to only capture people that have high sales and high profits. So that is going to be this group right here. So once I highlight them, go over here, and next to the paperclip, you'll see sets. Create set, and call this top sales and profit subcategory. So as you see, it grabs all of the members that I created, that I selected here. All right, so now I can say, well, instead of coloring this by subcategory, I want you to color this by this set. And then it's going to color anybody that is in that set. I'm going to make it green and red because those are my more profitable and higher sales subcategories. So that is how you create a constant set. You grab the data that you see in the visualization and create a set for it. And you can use that set on other visualizations. So now let's do another example using that set. So let's look at discount. So let's say, are we giving more discounts to the people that are profiting more and have higher sales, or are they just better customers? We can figure it out by using this new set. So we got discounts here. Let's look at order date. And then let's split this graph by the set. So the people that are in the set, which I manually grabbed, are offered around 20% discount compared to people who are not in the set are offered around a 12% discount. So pretty much it's saying if we offer a higher discount, we're going to get more sales and better profit. So that's a good way to use sets, is to see people that are in a certain set, what's going on using different types of data, different types of view, different types of drill down. So you can use that constant set throughout your different analysis. Now there's a dynamic set, which is a little more complex. So we could have done the same thing here by just grabbing these and grouping it and then seeing what this was and splitting this by the group. But in a dynamic set, you can create a dynamic calculation across multiple dimensions. So in this example, we're going to look at subcategory, and we're going to look at profit and sales again. All right, so in this example, I want everyone that has a positive profit and over 100,000 in sales. Now I can manually just grab people and group them. I could do it that way, but then once I update the data, I have to manually grab them and group them again. So I would want a smarter, more dynamic way of figuring this out. So the first thing we're going to do is create a set for profit over 0. All right, now let's bring this into view. So now we can see that everyone that had a negative is out of this set. So let's create another one for sales over 100,000. And let's bring this set over. All right, so now everyone that has over 100,000 is in this set. So what if I want profit greater than 0 and sales over 100,000? I can combine these sets together to create a new set. So if I right click on the set and do create combine cassette, I grab profit greater than 0, sales greater than 100,000, and I do an inner join. So I'm only going to grab people that are in both of these. And let's call this profit greater than 0 and sales greater than 100,000. All right, so now you see you're only in the set if you satisfy both of these conditions. So now I'm going to create a new chart with profit and sales by subcategory. And now I'm going to color this by this new set I created. So now instead of grabbing these manually to create them in a group or doing a drag and click to create it in a constant set, I now have a dynamic set, so whenever the data updates, this set will update and all the new members will become in the set.
So talking about date and time, it handles the details, it handles it in a different way, all right? And moreover, it also, now let's say we have, in terms of pivoting the date parts on the shelves, all right? Tableau also allows us to pivot the date part, wherein we can pivot the data granularity levels between our days, week, month, or quarter, all right, where we want to gain a better insight. And we can pivot these dates by simply placing these fields with different levels on different shelves. Okay, now how that is going to be achieved, I'm going to show that to you all. So let me move on to the Tableau environment here. Let me add a new sheet, all right. Now, assume, let's say that we have a line chart, all right, that is going to display the year and the year for the sales, all right. So let me first create that view. Let's have our order date in columns. Let's have our sales in rows. Now, in case if you're not sure whether which particular dimension or measure or which particular field should be placed into the columns and rows to create this view, you can simply, as I mentioned earlier as well, multi-select the fields that you require, go to the show me options and make your selections, all right? So that way it will automatically place up the required fields onto the columns and rows. I'm doing this manually here so that you can keep getting used to the tool and get an idea of how it's created. Now, I'm going to have, you can see we have the year, we have the sum of sales. Now, earlier we saw that we achieved this particular level by drilling onto the data. Now, instead of drilling, I would also instead color encode my marks, the line here based on quarter, which will give me 4 lines on the quarter basis at a yearly level. All right. So that's another way that I can achieve my drilling. I can achieve it based on a color coding using quarter in this particular scenario. So what we can do is, I can simply click on the order date and drag it onto the color shelf here, all right? And it's now divided it based on, sorry, it's taken in the sum here. Let's have the order date. So you can simply right click, you can use the control option, and based on the control option, you can drag this particular pill and add it up to the color shelf here. And this is how then you can divide. You can have it based at the quarter. So you can now see it's encoded the color. So you have a yearly level. There are now a color encoding which is happening at the quarter level as well. Alright. So this is how you can separate the particular view. You can separate. Now you have a color encoding for your year. Alright. Which is at a quarterly level that you can see. Now the same thing, let's say you want to achieve and you want to have your years and your month and quarter instead. Alright. So you can simply again pivot back your quarter. Alright, now you want to have your quarters as well as you want to analyze and code it with a monthly level in terms of every quarter of that particular year. You can simply pivot your quarter from your colors marks onto the rows, alright, and you can then add in you can simply drill, have your month, alright, so this is your monthly order date which you've drilled, and then move this fill directly, pivot it from the rows onto the color shelf. Alright, so that's how you can keep drilling and pivoting. So we can now have, as you can see, we're now having an analysis of our sales, which is happening at a monthly level for every quarter for its particular year. So again, this is another way of achieving this particular scenario also. Alright, so that's how you can pivot dates in Tableau, wherein first we saw that the same way we could achieve where we could create the view. Let me just take off the product names and have it back to our original view. Alright, so initially we had created our view with sales, and so let me have my sales back again in the row and the drilling. Alright, so you can see that here it is separating each of it, drilling down at every year level for every month. Now this same view, alright, in terms of drilling is what we understood that Tableau allows drilling, but for it to give it a better look, a better enhancement in terms of analyzing as well, we can simply then pivot whatever we had added in. So all our years, quarter and month, we pivoted them and added them. So we pivoted our quarter to rows and our month to colors, and that's how it's all in one view, and it's easier. The view is much more better in terms of analyzing it. Alright, so that's how we can pivot our data and make our data look even more useful, even more meaningful. Okay, so let's go back to our presentation slide here, and so that's how we can make use of the pivoting and make our views, enhance our views and make it better.
The charts in Tableau. So for the charts in Tableau, I'm using two different datasets to just make things look a little bit more interesting. So the first dataset that we will be dealing with is the Amazon Prime TV dataset. So this particular dataset has the following columns: the serial number, name of the serial, year of the release, number of seasons, language, genre, IMDb ratings, and age of viewers. So we will be using this particular data and we'll try to extract some insights from this data using the charts in Tableau. So followed by Amazon Prime TV dataset, we have another dataset called as the Tableau Superstore dataset. So this particular dataset is a sample dataset available in Tableau Public, and it is open for all. You can take this dataset and try to extract some insights from this as well. Now without further ado, let's try our first chart, that happens to be the bar chart. So what exactly is a bar chart? As you can see on the left side, we have a sample image which explains how a bar chart typically looks like. So a bar chart basically represents the data in the form of rectangular bars with the length of the bar proportional to the value of the variable. Now this might be a little deviated, I can understand that. So to understand this in a much more better way, let's get back to Tableau and execute some practical examples and understand what exactly is a bar chart in a much more detailed way. So here we are on the Tableau. So you can see I have already executed some examples on the Amazon Prime dataset, and we have all the charts that we'll be going to discuss today. We have the bar chart, Pareto chart, side-by-side bar chart, text chart, tree map, etc, etc. Now why am I showing this? So I have actually saved this dataset or what do you call it as book? Yeah, we call it as a book in Tableau. So I've executed all the charts and I have saved this in the form of a book in the Tableau public. And I'll also give the link to this particular book so that you can have a reference to this and you can try to execute your examples on your own in your local system. Now for our reference, let's try to create a new sheet. So we can name this new sheet. Just double click on that. So I'll rename this as bar chart too so that we don't have a confusion between the existing bar chart and the new bar chart. Just press enter and it's done. So to execute a bar chart, let's select genre and drag it down to columns, and the prime TV shows and drag it down to rows. Now you can see that we have a bar chart here which explains us we have different genres such as action, comedy, adventure, animation, etc, etc. So now let's kind of sort it. So now you can see in the particular type of genre, which is drama, we have the most number of prime TV shows. So basically the audience would like to see the drama based seasons or serials at the most compared to others. So remember we discussed the length of the bar, which shows the volume of the variable. Let's get back to the definition once more. So you can see a bar chart represents data in the form of rectangular bars. That is, we have the data represented in the form of rectangular bars, and continued with that, with the length of the bar proportional to the value of the variable. So we have the drama at the maximum number of series. So 125 number of shows based on drama. So this happens to be the biggest one, and followed by that a little smaller one which has a little less number of seasons or shows, which is the type genre comedy. So you can see that if the value is bigger, the volume of the length or the length of the bar is bigger. So that's how the bar chart works in real time. So it basically shows the biggest bar for the biggest amount of data. Now followed by the bar chart, the next chart we have is this side-by-side bar chart. Now what exactly is a side-by-side bar chart? So a side-by-side bar chart is completely similar to the bar chart. No rocket science or nothing big difference in between the bar chart and the side-by-side bar chart. If we get back to Tableau, you can see that we have different genres here. So we have drama, comedy, kids, action, etc, etc. So if we wanted to change this into a side-by-side bar chart, then we can add one more data into the columns, which happens to be the name of the show. So what exactly will be happening here? So we will be getting few more bars over here. So those few more bars will be of the name of the show. So in the genre of drama, we'll be having different shows, right? For example, the show name A is in the form of drama, show name B is in the form of drama, and followed by that we have AA in comedy, BB in comedy. So that's how you categorize. So basically the bars will be represented, that's for sure, and the data is represented in the form of categories. So we have few serials in the drama category, we have few serials in comedy category. So that's how it happens. Now let's see that practically. Now let's drag the show name to columns and we'll see that happening. So you can see that happening over here. Now let's kind of sort it again. Yeah, it's sorted. So you can see we have the first category, that is the arts, entertainment, culture. So in that particular category we have different shows, Tommy Little and the Son of Abisha and Paul Chowdhury, etc, etc. So basically we have categorized them and we have the side-by-side bar charts comparing each other. Now we'll get back to a little farther, and there you can see we have the genre here and the series happening in this particular genre. So this is the drama genre, and inside that we have various amount of series, The Good Fight, The Good Doctor, etc, etc. So that's what the bar chart does in real time. So basically we had the same bar chart, but the only difference is the fields were divided in different categories. Now followed by the side-by-side bar chart, the third type of chart that we will be having today is the Pareto chart. Now what is a Pareto chart? So Pareto chart has bars and a line graph. So far we have discussed bar charts. We will also discuss the line graphs in the further section. So line graph is no different from bar charts, but the only difference is you can see here, right? So if we pull out the names, so we have this bar chart. So we can actually change this chart into a line chart just by clicking on line. So you can see this has converted into line chart. So we'll deal with that in a little more detail. We don't worry about it. So this is how a line chart basically looks like. So I have explained you the line chart just because we have the two different types of charts in the Pareto chart. So there is an inclusion of a bar chart as well as a line chart, or the line graph. So a Pareto chart has bars and line graph. The individual values are shown in descending order by bars, and the ascending cumulative total is represented by the line. So we will understand the definition in a bit more detail practically by getting back onto Tableau. Now let's get back to Tableau 1. So now we are back on Tableau. Now let's create a new chart or new sheet. Let's rename the sheet as a Pareto chart. Don't worry, we have already a Pareto chart over here. I'll just rename it as Pareto 2. Don't worry, at the end of the video, I'm not going to save anything onto this particular book. We'll be having the book as it was when we started the tutorial, so that you don't have to face any duplications in this particular book. So Pareto chart 2. Enter. And now we have the Pareto chart 2 over here. So to create a Pareto chart, let's drag the Jenna into the columns. Yeah, now we have the Jenna into the columns. Now into the rows, we'll drag the number of Prime TV shows based on that particular Jenna. So now we are back on the bar chart now. Tableau has automatically selected the type of chart to be used for this particular data, which is the bar chart. Now let's right click on the Jenna, and now you can see a sort option. Now we have the dialog box over here. Let's select the sort by option by field, and let's select descending order and aggregation by count. So we'll select this, and the aggregation is count, and it's done. Let's close it now. Now the second step is we will drag the Amazon Prime TV show dataset again onto the rows. Now we have two different bar charts. Now everything starts from here. We'll change few things so that we create a proper Pareto chart. Now we will select or right click the second count Prime TV shows, and now we will select dual axes. Now you can see the chart has changed itself into the dots type. Now you might have a doubt. We had two different bar charts. Now we just have one axis, that is y-axis and x-axis, and the two charts have gone into one. So what's happening here? So what's basically happened here is we just merged the x-axis of both the measures. So we have the measures over here, right? The count of Prime TV shows and the second count of Prime TV shows. So we have basically merged the x-axis of both these measures. Now we'll enter into the step 3. So now you can see on the marks card we have two different count Prime TV shows. So we'll now select the first one, and inside that we have the pop-up of marks card where we have the options of selecting the kind of charts for our data. And now for the first one we will select the bar type of chart. Now you can see that we have the bar type of charts over here. Now we will select the color for our bars. So to select color, you just need to select the color option, and inside that we have various types of colors. Now let's select kind of green. So we have green over here. Now let's get back to the second count of Prime TV shows, and inside here let's select line. So we have line over here. Now we can actually kind of select the color for that as well. Now we'll select some opposite color for that. Let's select pink. Or you can also go with orange, kind of more visible. Yeah, we are done with the color selection. Now the next step. Now we'll get back to the second measure over here. Now we'll right click it, and inside that we will select add table calculation. Now we'll select the calculation type, and we needed the running total of this. and we're going to compute this using table across, and the most important step is the last step, to select the add secondary calculation. By clicking on this, we'll have another dialog box, and we need to add some more details into this one. So here we'll be selecting the difference from, and we'll change that to % of total, and next we'll select the table across, which is the default one over here, and we are done. So as discussed in the definition, the individual values are shown in descending order by bars, and the ascending cumulative total is represented by the line. So you can see the individual values of the genre are represented in the form of bars, and the ascending cumulative total is in the form of line. So this is how we use the Pareto chart in real time in Tableau. Now moving ahead, the next type of chart that we will be discussing today is the text chart. There is nothing much of a rocket science in text chart. It's just a simple tabular way of expressing your data. Text charts are created by placing one dimension on the row shelf and another on the column shelf. Text tables are also called as crosstabs or pivot tables. Now let's get back to Tableau and try to execute a simple example. As you can see in this particular book, I have already executed a text chart. Now to avoid confusion, let's try to recreate another sheet and rename it as text chart 2. It's done. Now let's drag in the genre and the name of the show to the rows. So you can see that the Tableau has automatically selected the text chart for this particular data, and we have our text chart over here, which shows us the genre, which is action, the name of the shows under genre category, and similarly action, comedy, adventure, animation, etc., etc. Now with this, let's continue with our next type of chart. So the next type of chart that we will be dealing today is the waterfall chart. So the waterfall chart displays the cumulative effect of sequential positive and negative values. It shows where the value starts, ends, and how it goes there incrementally. So the waterfall chart is a little complicated than the other charts. Now I want you guys to follow me up a little bit more cautiously. Now let's continue with the waterfall chart. So for that, let's drag the language from dimensions into columns and prime TV shows data from measures to rows. Now we have our bar chart over here. Now the next step is select the prime TV shows data, which is in the rows. Now the same thing is in the measures as well. So keep in mind that you need to select the prime TV shows from the measures. Let's right click on that and you can see a create option, and inside that select the calculated field option. Now let's rename this. And remember to add a negative symbol. Now I'll tell you why we are going to add the negative symbol. As we progress into the waterfall chart, we convert this particular bar chart into a Gantt chart as a step of the process. So in that particular stage, we might have to make some space between the bars. So that's the reason we have selected negative of count over here. You'll see that happening in the next steps. Now you can see we have a new measure, which is a negative of count. Now let's drag and drop that onto our size option in the max card. So you can see I've selected the negative of count, which is in this particular case. The complete uppercase is for the first waterfall chart what we made. So we have our chart over here. Now let's get back to our rows. Click on this option. Now we have our quick table calculation option, and that will be selecting the running total. Now we are almost done. Just one step is remaining to convert this particular chart into a Gantt chart. So there you go. We have our waterfall chart over here. Now the next one in the list is the heat maps. So you can see how a typical heat map in real time looks like. So a Tableau heat map is used to display the data along with colors. We can create a heat map using one or more dimension member and measure value. Now let's get back to Tableau and try to create a heat map. let's create a new sheet, rename it as heat map 2, enter, and there we have our heat map. Now let's drag in some data to create a heat map. So for that, let's select genre from dimensions and drop it down to, no, we're not going to drop it. So we'll be selecting both the data at once. So the genre one, now let's hold the control button and select the number of seasons from measures. Now we will go to show me option, and you can see that we have various options over here. So this particular icon is for heat maps. Now let's select that. Now we have the heat map. Now let's drag the IMDb rating from the measures into size. And this one, IMDb ratings into size, so that we have the different sizes for the boxes over here. So the biggest one here and this next leading one over here. Now the problem is we have the same color for all the boxes. Now for that, let's try to drag the genre into color so that we have different color for different genre. So that's how the heat maps are done. Now the next chart in the list is the Gantt chart. So a Gantt chart looks something like this. Now what exactly is a Gantt chart? Gantt chart shows the progress of the value of a task or resource over a period. It is used in project management and other types of variation study over a period. Now to create a Gantt chart, we will be using the second dataset, which is the Tableau Superstore dataset. So I have already created a Gantt chart over here. This is how a sample Gantt chart looks. So we have discussed that a Gantt chart is used to study the variation in the standards for over a period of time. So here we are selecting the first class, same day, second class, standard class deliveries over a period of time. So we have the dates over here, or we can say that the period of time has been selected in the form of dates or day. Now let's recreate a Gantt chart and see how it's practically done. So for that, let's create a new sheet, G. Now we'll follow this in a step-by-step way. First, let's drag the order date into columns. Now let's select this or right click it and change the order to day. Now we have the days 1 to 30 in a month. Now let's move on to the menu bar and let's select the analysis button. And in that, let's select create calculated field. Now we have our calculation tab over here. Now let's type in the calculation. Now we are going to use this particular Gantt chart to study the shipment. Now once the creation of Gantt chart is done, we will study how the shipment is done based on what kind of class is selected for shipment as the days passed. Now inside the calculated field, we'll write the formula date difference. So this is the one, and inside that we'll be going to select the day, next order date, next ship date, so these particular order date and ship date are from dimensions, so just when we type them, we had them readily available. Now our formula is ready. Let's just select OK. Now in the measures segment, you can see we have a new input or new addition, which is the ship, the formula what we just created. Now we are going to select this and drag this onto the marks card, and on the marks card we are going to drop it on the size. Now our Gantt chart is almost ready. The only thing remaining is to drag the ship mode to rows so that we can have the details of that particular shipment mode, the standard one, the first class one, etc, etc. So for that, let's drag in the ship mode from the dimensions to rows. So there you go. We have our shipment mode. Now the next type of chart that we will be dealing with today is the pie chart. So pie chart represents data as slices of a circle with different sizes and colors. The slices are labeled volume and the volumes are represented in the form of a chart. Now let's continue with the pie chart. So to create a pie chart, let's select the language option from dimensions and hold Control button and select the number of prime TV shows. And you can see the show me icon over here. Let's select that, and inside that you can see a pie icon over here. So just select that and we have a pie chart over here. Now I can see that the pie chart what we created looks a little bit smaller, so don't worry. Now let's just select the standard option here. From that, let's select the entire view, and there you go, we have a little bit more bigger pie chart. If you're still not convinced with the size, you can just go to the size option and try to increase the size, and there you go, you have the pie chart. Now the next type of chart available in our list is the bubble chart. So the bubble chart looks something like this. So bubble charts display data as a cluster of circles. Each value in the dimension field represents a circle, whereas the values of measure represent the size of those circles. Pretty simple. Now let's get back to Tableau and try to execute a bubble chart. So this is how a standard bubble chart looks like. Now let's create a new sheet. Rename this as bubble. Now let's select genres from dimensions and number of seasons from measures. Now the genre will help us to know a particular value, and that particular value will be a circle in the bubble chart, and the number of seasons will provide the size of the bubble. That means the highest number of seasons for a particular genre will be having the biggest circle. Now let's select the show me, and inside that you can see the bubble chart. Let's just select that, and you can see we have different circles and different sizes of different circles. Now we have the same color for all the circles. To change that, let's drag genre into color, and now we have different color for different genre. Now the next type of chart that we will be dealing is the histogram. Histogram is one of the simplest charts available and also easiest to create. So histogram is a chart that displays the shape of a distribution. Histogram looks like a bar chart but groups values for a continuous measure into ranges or bins. Now to understand this better, let's get back to Tableau and try to create a new chart. So we are back on Tableau. Let's rename this as histogram. Let's just select enter. Now let's select the IMDb ratings. Now we'll be using the IMDb ratings measure to create a histogram, and we'll be having the biggest bar for the highest rating of IMDb. Now we have selected IMDb rating. Just hover over to show me tab, and in that you can see the histogram tab over here. Let's just select that, and we have the histogram chart on our window. So there are many shows, and each and every show has specific number of IMDb ratings. So a maximum number of shows are having 7.2 as the IMDb rating. Now followed by histogram, we have the next type of chart, that is the highlight table. So highlight table is completely similar to the text table that we have already dealt with. The only difference is we have various colors for various data cells inside that particular table. Now in Tableau, highlight tables are used to compare categorical data using color and represented in the form of tables. That's what we discussed. Now let's get back to Tableau and try to create a highlight table. Let's create a new sheet and rename it as HD. So to continue with the highlight table, let's select genre from dimensions and hold Control button and select the number of seasons available. And when you hover over to show me, you can see a table called highlight tables. Let's select that option, and you can see we have the highlight option over here. Now you can see that we have different colors for different number of seasons available in that particular genre. Now you can see that they are not ordered, so let's just select the sort option and sort from descending order. So there you go, we have the highest number of seasons available for drama, that is 339. Now the next type of chart that we will be dealing is the line chart. So a typical line chart looks something like this. So the line charts connect individual data points in a view. They provide a simple way to visualize a sequence of values and are really useful when you want to see trends. Now let's get back to the Tableau, and here we are going to use the Superstore dataset so that we can have a look on the trends. Now let's create a new sheet and rename it as line 2. Now let's drag the profit into rows and see if the profit is increasing day by day or not. As you can see, the Tableau has automatically selected the line chart for us, and there you go, we can see that the profit is increasing day by day or year by year. We can just kind of select the plus icon over here and see we can have a quarterly update over here. So Q1, Q2, Q4 of the year 2014 and 2015, 2016 and 2017, the Q1, Q2, Q3, Q4. So that's how we use the line graph. Now the next type of graph that we will be dealing is the bullet chart. So a normal bullet chart looks something like this. So a bullet graph is a bar graph that replaces dashboard gauges and meters. It is used to compare performance of a primary measure to one or more measures. Now let's get back to Tableau and see how a bullet chart is made. Now let's create a new sheet. Let's rename it as bullet 2. Enter. Now for a bullet chart, we'll start with the analysis button on the toolbar or the menu bar. Click analysis and now select create calculated field option. Now inside that, let's try to set an average for profit. So we can kind of estimate a profit over here. So let's rename it profit estimated. So basically we are going to use the bullet chart to estimate the profit in future. Now inside that, let's have an average value. So average value of profit must be something nearly 250 to 300. So just write in 275,000. Just select OK. So this is the average what we're expecting. This must be the average amount of profit that we should be facing in the near future. Now we have a new measure in the measures section, that is the profit estimated. Now just select that and hold Control, and now we're going to select profit. Now we are going to hover over the show me option, and there you go, we have the bullet graph option over here. We're going to select that, so we have the bullet chart over here. So there you go, we have the bullet chart over here. We can kind of increase the size of that as well. So there you go, that's how we use the bullet chart in real time. Now the next type of chart that we will be discussing today is the scatter plot. So scatter plot shows how points are scattered in Cartesian plane. It is created by plotting values of numerical variables as x and y coordinates in the Cartesian plane. Now let's get back to Tableau and see how scatter plot is used in real time. So we are back on Tableau. So a scatter plot should be looking something like this. Now let's try to recreate a new scatterplot sheet. Let's rename it as scatterplot 2. Now to create a scatterplot, let's try to drag the genre from dimensions into columns and the sum of seasons from measures. Now we have the bar chart by default. Now let's just select the marks card, and inside that let's select the shape option. Now we have the data scattered across the different points in the Cartesian plane. Now just select the genre and drag it into color. So we have different colors for different genres. So this is how the scatter plot looks like. Now let's continue with the next type of chart. That is the area chart. So an area chart is a line chart where the area between the line and the axis is shaded with a color. Now let's get back to Tableau and see how exactly an area chart looks like. So an area chart looks something like this. So let's try to recreate area chart once again. New sheet A2. Now we're going to see how the sales are happening according to a particular area. For that, let's select order date and hold control and select quantity so that we can have a sheet which shows us the sales happening in quantity on particular dates. Now we have the show me tab and we have the area chart option over here. Let's just select that and we have the area chart over here. Now you can see that we have one single color for all the sales and quantity. Now to have the details of the regions, like in what region what kind of sales are happening and what quantity, we want to select the region and drag that over color. So we have 4 different colors for 4 different regions: the central, east, south and west. So this is how we use the area chart. Now followed by area chart. Now the next type of chart that we will be dealing is the dual axis chart. So what exactly is a dual axis chart? So a typical dual axis chart looks something like this. So dual axes are 2 independent axes that are layered on top of each other. According to Tableau, dual axes allow you to compare multiple measures. Now let's get back to Tableau and try to create a typical dual axis chart. So a typical dual axis chart looks something like this. Now let's try to recreate this one. Create a new sheet, D2. Now the dual axis chart is really simple to create. Let's select order date from dimensions, hold the control key. Now you want to select the quantity from measures. Now again hold the control key. Now you also have to select the sales options. So we have selected the order date, quantity and sales. Now we are going to select the dual axis chart from show me. So we have the dual axis chart on my screen right now. So what we are going to learn from this is we are going to learn the quantity of sales happening according to the years. So in the year 2014 we have the quantity of sales which is something around 7.5k, and it has grown gradually from 2015, 16 and 17 and reached above 12k. So this is what we get to know from dual axis chart. So the number of sales happening and the quantity of sales happening. So the line shows us the number of sales and the bar shows us the quantity of sales. Now with this, let's continue with the next type of chart in our list. So the next type of chart that we will be dealing is the symbol map. So the symbol maps are simply maps that have a mark displayed over a given longitude and a latitude. So now we are back on Tableau. Now let's try to execute the symbol map. So symbol map looks something like this. So we have the number of sales happening in a particular country and a particular city. Now to create a symbol map, let's select city, hold control, country, and again hold control and select sales. Now you can see that we have 2 different maps over here. The first one is symbol map and the second one is maps. Now let's select the symbol map and there you go. We have the symbol map over here. Now we have the same color for all these sales. Now let's kind of select sales and drag it to color. So we have different colors for different amount of sales happening. So the darkest one shows the highest number of sales and a lighter one shows the least number of sales. So that's how we use symbol maps in real time. Let's get back to the presentation again. Now the next type of chart that we will be dealing with today is the map chart. So a map view is one data point created since geographic role is assigned to a country. Tableau creates the map view as shown in the image here. So similar to the symbol maps, we can use the maps which shows the amount of sales or profits or anything happening in that particular country or city. Now let's get back to Tableau and try to create a map. Now a sample map looks something like this. Now let's try to create a new map. M2. Now to create a map, let's select country and hold control, and now let's select kind of profit. So let's select the map icon here, and so now we have different colors for different profits. So this particular state or country says that we have a profit of 286,397 numbers, or it might be even dollars or something. We can also select the country and hold control and select sales. And now we can also select maps again. So this is how the map chart looks like. Now let's get back to the presentation. And the next type of chart that we will be dealing with today is the tree map chart. So what exactly is a tree map chart? So the tree maps are used to display data in nested rectangles. You use dimensions to define the structure of the tree map and measures to define the size or color of the rectangles. Now let's get back to Tableau and try to create a tree map. So you can see that we already have a tree map. Now we are back onto the Prime TV dataset. So we have used the genre and we have used the sum of IMDb ratings to create the tree map over here. Now let's create a new sheet and try to recreate the tree map so that we can understand how to create a tree map in real time. Let's rename it tree map. So the tree map is being recreated. Now just select the genre and from that hold the control key and select the IMDb ratings. And now hold the control key again and select the number of seasons available. And now when you hover over to the show me tab, you can see the tree maps icon over here. Let's just select that. So there you go. You can see the tree map on the screen right now, and we have different colors for different genres. So the darkest color for the drama has the number of, or the highest number of IMDb ratings and the highest number of seasons available, and similarly so on. Now the least one is the comedy, arts, entertainment, culture with the least IMDb rating of 6.2 and only the number of seasons available are 1.
My name is Michelle and I'm with the Simplilearn team. Today we will be building dashboards from start to finish. First about world population, then health. Next we'll build a dashboard about economy, and finally we'll build a dashboard about business ease. I would recommend getting access to the dataset before you start this tutorial so you can build along with me. If you would like access to this dataset, please comment below and we'll get you access. So first we're going to build a dashboard that revolves around population. So we're going to build a map based on country. So I'm going to double click on country and it's going to map out all of the countries. And then on our marks, I'm going to change it to map. So it's a filled in map. And we want this to be colored by population total. And we can see who contributes the most to population. We're going to label it with population as well. But you can see that it's labeling it the total population, and what we want to label it is how much it contributes to population by percentage. So let's add a table calculation, and we're going to have it do percent of total based on country. Okay, so now we can see which countries contribute what percent. Let's also bring the country name onto the label, and let's put it on top. So country name's on top. Now it's getting a little bit crowded in here, so we're going to unclick Show Marks Label, and we're just going to show the ones that we want to see specifically. So we can right-click on China here, hover on Mark Label, and click Always Show. And on India, since these are our two biggest contributors, we can see that this one's a little bit darker than the others in that area. And here. And that's just a manual way to choose which ones have indicators, labels, and which ones do not. And we're going to put a note here. So we're going to annotate an area that explains that China and India contribute the most to world population. Just calling out this section of the visualization. And let's name this sheet. So here we have our visualization, and when you hover you can see both the total population and its percent contribution and the country name. Our next visualization for this dashboard is going to be population over time. So let's bring on our time element. But one trick for bringing on a time element, if we just drag it on, so year with the calendar mark here, if we just drag it on, it'll default to a discrete version. So let's take it back off. And then we could edit it there. But one thing you could do is if you, on a Windows machine, you right click on it and drag it on, then it will pop up with a dialog box that allows you to select what kind of date value you want to use in the first place. So we're going to use year here. And now we have, instead of discrete, we have a continuous axis. And we're going to bring on population total. And we can see that over time. One thing you can do when the value is up so high in your axis is you can uncheck this box that says include 0, and it will not always include 0 in your axis, but this can be misleading. So you can see that it looks like population growth is something really dramatic by increasing that slope of the line, whereas it really wasn't quite as dramatic as it seems. So as long as it's communicated well and you're not doing it to mislead your users, you just need to keep in mind that this include 0 can change what your graph is saying. So we're going to not include the 0 at this time, just so that we can focus in on our data a little bit. Now we're going to add our forecast. So we're going to click on forecast and drag it on, and it adds the forecast to our visualization right there. And now we can right click here and see forecast result is actual and forecast. So you can see that the forecast picks up here in 2012 and pushes out what it thinks it'll be in 2013 as well. You can change how far out that forecast goes by right-clicking on the line and clicking forecast option. And we can change, it says automatically the next 2 years, but we could change it so that it's the next 10 years. And it will go out into the future, out to 2022. You can change prediction intervals, or if you don't want to show them, you don't have to show them. And this is just kind of a visual guide for those prediction intervals. Okay, and then you can also have your trend line show, where it shows your trend line following out from where your population growth is, and also the trend line for your forecast right there. And we'll call this world population trend. Excellent. And we're going to make one more visualization for this, and it's going to be a pie chart. So the pie chart is also going to be based off of population. So we're going to click on population, and we're going to control click on country and come over to show me and click your pie chart. Great. So I'm going to make this the entire view so we can see the pie chart better. And this is getting really crazy in here. And so I have changed my mind, and instead of country, I'm going to drag region over top of country. And now we see something a little bit more manageable. So we can see that here's Asia, and it makes up the biggest piece of the pie, and then here is everybody else. So right now, each of these is population total, and we could keep it that way, or we could do what we did last time and change it to % of total, so that on hover we can see the population and the percentage of population that it contributes. So for this pie chart, we're just going to show Asia versus everybody else. So we need to make a group. And what we'll do is select all of these, and we're going to right click and click group. So now we have all of those things we selected, and we have other. Let's edit our group. Right click, edit group. We're going to rename this group Asia, because that's all that's in there. And we're going to rename this group rest of the world. Okay, so now we have our group. We can drag it onto label, and we can see Asia and rest of the world. And now see how it's breaking it up into those different sections? That's because we still have region on our detail right here. So we pull region off. Now it's just split Asia, rest of the world. We can change our colors. Make it a little bit more visually interesting. Now we can still see our percentages. And now, let's rename it, and then we'll put it all together on a dashboard. Great. So let's make our dashboard. We have this new dashboard button down here, and you can choose what sizes you want. So we have a fixed size where you just select the width and height. We have automatic, which will just fill your screen. And we have a range, which has a minimum size and a maximum size. Some of the good things about fixed is that once you have it, you can have it always look that way, so no matter where they're looking at it, you know that it's going to be laid out the way that you expected. However, if somebody's looking at on a screen that is bigger or smaller than yours, then it doesn't fill up the screen, or it will fill up the screen too much and they'll have to scroll up and down and left and right. If you have automatic, then it will fit the screen that it's displayed on. However, the things that you've placed might get squished too close together. And then the range gives you a minimum size and a maximum size, meaning if the screen is too big, it still won't fill up the screen, but it can get closer. And then as they get smaller and smaller screens, you at least know that it will never make it get smaller than this particular size. So there's some benefits to that as well, where you still have a little bit of control of what it will look like in the end. Great, let's bring on our worksheets. And you can see that where you hover, it fills up that space, and that's where it's going to show up. You can also adjust the lines in between different visualizations for things that need more space or less space. Another important thing to recognize is that when you click on a visualization, like this one, up here it will tell you how it's viewing that visualization within that space. So if you click standard, then it will do a standard fit, versus if you have entire view, where it will make it fit inside the box. Over here we could have fit width or fit height. On some of the visualizations, it doesn't make as much of a difference. However, when you have a visualization that maybe has a lot of text in it and they need to be able to scroll, you'll want to have it fit width, but you don't want it to fit height, because then it will shove all of that information into the box and not allow you to scroll up and down. So if you saw, as we dragged these on, it took these legends and added it to the left here. We can modify that and make them floating and drag them next to the visualizations that they are relevant to. And this particular one has a couple of things wrong with it. We might not want the title of this to be region group, so we could come in and we could edit the title and then maybe just call it region. However, I don't think we need this legend at all because it's very clearly marked on the visualization there. So you could also just remove it from the dashboard. And this one is telling you how big of a circle it would need to be before it gets to that population number. So it belongs to this circle as well, but again, is unnecessary potentially because we have our two population numbers showing up right as we hover. So we'll remove that as well. So at this point, we have a visualization, or 3 visualizations all on the same page, which is the basics of a dashboard. However, we might want to be able to interact with them a little bit more than just hovering. And so this is where we should look into adding filters. So we have information over time, we have information by country, and we have some information by region here. And one of the quickest things you can do to add functionality to the dashboard is by clicking this Use as Filter button. So if we click this, That means whatever country we click on here will filter the other visualization. And then you can unselect it to go back. Now, that uses filter button actually creates an action here, filter 1 generated, that it's made on its own. Now you can see that when we click on China, it doesn't make a lot of sense to have this pie chart update based on that China click, because it's just going to show duplicated information. So it shows the 20% or the 20% here and the 17 billion. And then here it does the same thing, except for it shows 100% because it's filtered everything else out of the chart, so it now makes up 100% of the circle. So that doesn't make a lot of sense. So there are ways to format your visualization or your actions, modify your actions so that they only affect the things that make sense. So we can come here and click Edit. We're going to call this Country Action, and we want it to use the population by country sheet and then modify only the trend. So now when we click on China, we see China's trend over time. And it doesn't affect our pie because that doesn't make sense for it to affect our pie. We might want to select on our pie Asia or rest of the world and have that affect the other visualization. So we can click Use this filter here and click Asia. And now it zooms into Asia on our map and shows us just the Asia world population trend. And here's rest of the world, and we can see that Asia is grayed out. And there's the rest of the world, and here's the rest of the world population trend. We might also want to be able to use this to filter to a certain year. So if we click Use this filter, then we click on 2011, you can see these numbers are slightly updating. So this is 19%, and we come here, 19.5%, come down here, and we can see that the pie updates a little bit, although it hasn't been anything dramatic. You can kind of see it over time. So that's one way to add filters to your visualization. Another way is to use actual filtering instead of just actions. So if we come back here to our trend, we could take the year, we're going to control click and drag it onto filters. And now we have a year filter, so we could have it the actual year number. So just look at 1 year at a time, or a range of dates. So if we click range of dates, that makes this slider from 2000 to 2012. So if we hit OK, we'll right click and we'll click show filter. We can see it here. And as we drag this, it updates, but kind of messes with our forecast. So let's not do a year filter in this case. So we click remove filter there. But maybe we want a filter just on this for the different years. So let's drag year onto the filters. We're just going to do the year number next. And here's all the years. We're going to let all of them be selected for now. And then we're going to show the filter. And here's all of our years. And we can change the way that our quick filter shows up, and we can make it like a drop down, so they can still select multiples, but it's a drop down. Or maybe we want this visualization to be just 1 year at a time. So we could choose single value in a list, and it lists out all the years, or in a drop down, and we want it to be 2012. And then we want this to show up on our dashboard. So we come to the dashboard and we click more options here, hover over filters, and we can see the filters available, and we can click year of year. And now our formatting hasn't passed on. So that's one thing to remember, that formatting it just on the workbook doesn't necessarily mean that the formatting will pass over to the dashboard. So I tend to not do any formatting on the workbooks and just format it on the dashboards, because the dashboards are what I publish. So we're going to single value drop down. We're going to add it. We're going to move it to the top. So now how we do that, let's talk a little bit about what each of these sections are. Come here to Layout, and you can see we have this layout here, item hierarchy. So tiled is the whole screen, and inside of that we have a horizontal container. And inside this horizontal container, we have another horizontal container. And when you click on something in this view, it shows you where it exists. So we can see this horizontal container is outlined now, and then we change it to vertical, and it outlines this. Now, a horizontal container allows things to be side by side, and a vertical container allows things to be one on top of the other. And so in our vertical container, we see all this extra space for extra things to be on top of each other. But if we wanted to have it at the top, we would maybe want things to be able to be side by side. So if we go back to the dashboard and we grab horizontal and drag it to the top, it adds a horizontal container up here. And now you can see everything that's floating kind of stays in the place that it was, even though all the other things shifted. So that's one of the disadvantages of floating, is that you're kind of just manually choosing where it will stand using your X and Y position, and it's not dynamic. So let's give us a little bit less space up here. We can add a text box into our horizontal container, or we'll say population dashboard. We can format it. Now we have our title up here, and then we can add our filter. We're going to drag it to be on inside of our horizontal container, but on the side here. We can give it more or less space. Let's bring our legends down to places where they make sense again. Perfect. And so now we have this that will affect this only and show you just 2012, 2011, 2010. So we don't want it to affect the trend because we want the trend to show all of time. And just looking at 1 year for this trend that is only at a yearly part and forecasts into the future doesn't make any sense. But we maybe want it to also affect this worksheet so that these two are in sync. And so that the dashboard is basically for 2012 except for the trend, which shows you the past and the future. So one way that you can do that is clicking Apply to Worksheets here. And you can choose Selected Worksheets. And it will show you all the worksheets in this visualization, or in this dashboard. And you can click Show All Worksheets in Workbook, and then if there were other worksheets, it would show them. So we wanted to do Asia versus rest of the world and population contribution by country. Okay? And that's another way we can change what year they show. So it's only going to show 1 year at a time, unless we select all. And then this visualization isn't affected by it. If we don't want to click on a country and have it make the change, if we instead want to have a filter for country, we can do that by taking country and dragging it onto filters. We'll have it show all for now. And then when we go back to our dashboard and we come to this visualization, we can go filters and add country. And it's just added it side by side where we had our other filters, so that's a nice feature of Tableau where it can kind of guess where you might want things. We're going to do multiple value drop down, and right now it only affects that visualization, and we can just look at one country at a time. And we might not want it to affect this visualization because it doesn't do us any good to just look at one region in a pie chart. But maybe we want it to affect the world population trend, so we can do the same thing we did before. And we want it to affect these two. We'll click OK. And so now we could look at all of these countries, and that would update both these visualizations. Another thing I like to do on a filter is Customize and click Show Apply button. And this means we can make all these changes in here. See, I've selected none, however, these visualizations aren't updating. And then I wanted to look at Turkey, so I found Turkey, and then I hit Apply, and that's when they update. Perfect. So now we have a dashboard complete with filters and actions. We also have a title on our dashboard. We can give it a little bit less space, and some legends. We have titles on each of these pieces. However, if we didn't want a title here, we can click Hide Title, and it will just show our visualization there. And this is dashboard number 1. Here's what it looks like in full screen mode. Full screen mode is a good opportunity for you to test it to see what it will look like to the end user. I press escape and get back out, and it doesn't give you these highlights when you hover over things that are dashboard formatting related. You can see that all those extra lines went away, and it just gives you the opportunity to test out your dashboard in a more real way and see how they will use it instead of giving you the dashboard editing options.
Next, we're going to make a dashboard revolving around health information. So first we're going to make a map about birth rates. So we're going to call it birth rate rank map. And to make a map, we're going to double click on country, and we're going to change it to a map type. So we have a filled map here. And then we're going to bring birth rate onto color. So let's define our colors a little bit by clicking on this color part of the marks card. We'll click Edit Colors, and we're going to change it to red and gold. And the idea here is that the red is for a higher birth rate, which is more associated with countries that have poor health. So we'll hit Apply, and now we have our higher birth rate countries highlighted in red. Next, we're going to create a class. So we're going to duplicate birth rate, and let's edit that field. We're going to call it birth rate class. And so we're going to say that anything that is in the top 50 countries with the highest birth rate is categorized as having an alarming birth rate. So we will first do the average birth rate, and then we're going to do a rank on that. So you see sometimes when you're auto-completing your statements, it will replace one of these functions that you have with the one that you pressed tab for. So if I type if, or I start to type if, and then I come here and click on if, it replaced my rank with if. So keep an eye out for that. If you're like, where did my thing go? It's because I was typing it right next to it. So if I put a space and then I start to type if and I click if, it will not delete rank. So we're going to say if the rank of average is less than or equal to 50. So if it's in the top 50, then alarming birth rate. Else if, and we can take this again, is greater than 50, then normal birth rate. And always make sure you put on the end. Also, we didn't necessarily have to have this else if statement. So if we had just done else normal birth rate, that would have covered all of our bases. So with these if statements, just make sure that you're always getting all of the different options that you want. But in this case, we defined both. However, we didn't have to define the second calculation, because if it is not in the top 50, then it's obviously in the bottom, the rest. So we're going to hit OK. And then we're going to put birth rate class onto label. And it's gone around and labeled everything. And I am seeing alarming birth rate on everything. So let's see what the problem is. So if we open this back up by right-clicking and clicking Edit, you can see it says results are computed along table across. So we're going to click Default Table Calculation here, and instead of compute using automatic, we're going to change it to compute using country. We'll hit OK and hit Apply. And that didn't seem to fix it. So this is the first place I would look if it's not doing what you would expect. So we'll put it back to automatic. Okay. The second place I would look is inside of the table calculation that is created. So when we defined rank here, we put a table calculation on it. So when we right click here, we get edit table calculation. And we're going to choose that we want to do the rate based on the specific dimension of country. So now we can see, using the logic, the calculation assistance, that we no longer have just alarming birth rate. We have normal birth rate and alarming birth rate on our screen. So we can close this. And we are done here. But one thing you can do is, when we have allow labels to overlap other marks selected, then it will make sure that every label shows up, but it gets super crazy in there. So there are some times where the labels may overlap a little bit, and so you'll want to select this option. In our case, we don't want that. And now we have a visualization showing birth rate map based on rank. Our next visualization is going to be about average life expectancy, male versus female. So we're going to do a chart across time. So we're going to click year and bring it onto columns, and we're going to change it to this year in the continuous section. So now we have an axis. And we're going to double click on female life expectancy. Oh, there we go. Double click on female life expectancy and then double click on male life expectancy. So what that did was made us two charts, one on top of the other, but we don't want that. So we'll take this off, and we're going to drag male life expectancy right onto this axis for the female life expectancy. And what this has done is made what's called a blended axis chart. So it's not a dual axis chart where we have another axis over here for the second visualization. This one is a blended axis chart. So they necessarily use the same axis, and they necessarily have the same kinds of marks. So we'll take a look and see what the difference is there. So if I were to change this to a bar chart, we would have bar chart for both of them, and I can't define one separately from the other. Change it back to a line chart, and they're both a line chart. Now if we go back to when we just had female life expectancy and we drag male on next to it and we have two charts, now we can change it to a dual axis and we have one on top of the other. However, our axes don't line up. We can see at the top here is 15K and over here it's 14K. So we're going to synchronize the axis, and you can see one on top of the other. And we have two marks cards. So we could have this one be a bar chart and that one be a line chart. So that's some of the differences of those two. We're going to do a blended axis chart. So I'm going to take male and drag it here. And we have our blended axis chart. And now you can see that our scale here is really strange. So what it's doing is it's adding up all of the life expectancies for all the different countries instead of averaging it. So we're going to change that by right-clicking on the measure down in this measure values card, hovering over measure sum, and we're going to change it to average. Since I only changed one of them and they share the same axes, it's really spread out now and it almost looks like a straight line down there. And then let's change the other, and it should get everything a little bit more in sync. There we go. So now we can see the average life expectancy over time, which for both of them seems to be going up. However, it seems to be higher for females. Now let's take a look at our analytics, and let's drag on forecast. So it's forecasted out the next 2 years for both lines. And we'll bring on trend onto linear. And let's change it to a square. So now we see each individual point for the life expectancy for females and males, and we can see what they're expected to be in the future and our trends. And our next visualization is going to be a heat map about multiple different measures, so we'll just call it a heat map for now. And for our heat map, we're going to look at the different countries. So we'll bring country onto rows, and we're going to look at their birth rate. So I just double-clicked on birth rate and brought it on. We're going to look at their health expenditure percentage on GDP, so how much they spend on GDP. So when I double-clicked on it, it did what we did before, where we have a measures value card, and so now whenever we put measures on here, that determines what goes here, because we have our measure names on columns. So every measure in here, their name is going to define the name of the column, and the values define what's in the text right here. Great. We're also going to bring on infant mortality rate and the life expectancy for females. Okay. So now it has changed these to not have decimal points after them, which is not as helpful. So we're going to format those, and you can format it field by field. So for birth rate, we definitely want to have decimals afterwards. As a matter of fact, the birth rate is a percentage. So instead of doing a number standard, we'll just go to percentage. And now we don't need to have those decimals afterwards. We can just look at the birth rate as a rate. And for percent of GDP for health expenditures, we can come click there and do the same thing. And for infant mortality rate, okay. And to make this make a little bit more sense, we again need to change it from a sum to an average. And for some of these, we could change it from a sum to an average right inside of the, for all of these, we could change it from a sum to an average in the default properties under aggregation, so that it will automatically average it whenever we bring it out. Default is sum, but if we make it automatically average, then we won't have to do that again for any other visualizations. I won't do that at this time because I get a little bit confused sometimes when I don't have my sum on there by default, because that's what I'm so used to seeing by default. Great, so we now have a matrix by country and by our different metrics here, and so we can take our measure values and drag it onto color, and we'll make our marks from automatic to square, and it will make our heat map. Now, what happens with a heat map is it colors darkly the higher the number it is in this case, and right now it's doing it for the whole area, so 1% is obviously much smaller than 82. But if we wanted to be able to look at birth rate independently from life expectancy, we can right-click on the measure values on the color and click Use Separate Legends. And so now we have a legend for each one of these. Let's change the colors on those legends so that we can see them separately a little bit more clearly. So we'll change the colors by coming over here to each of the legends, and we'll leave one the same, but we'll change this one. If we click Edit Colors, you can see our different palettes. You can see some of them just have one color, others have one color to another color. We used the red gold before, so now you can see that one is changed. We could use another one that goes from green to blue. Great. You can also define your own. So you can make a custom one that could go from light to dark. And then you can choose what color you want as your dark color. So we could pick a lighter blue, and then we see that last one. And now with these separate color palettes, you can quickly see the difference with birth rate and spending on health. And that is our heat map with separate legends. So let's build this all into a dashboard now. We're going to call it our health dashboard. And for simplicity, we're going to make it automatic so it fills our screen. And then we're going to first bring on our map. We're going to bring on our health-related map with birth rates. Then we're going to bring on our heat map. And we'll bring on our life expectancy lines. Now, as we brought on all of our charts, it brought in our legends here. And we're going to move our legends up to the top. So let's add a horizontal container. And then let's put our legends into the horizontal container. And let's put these ones in order. So life expectancy. Oh, so birth rate is going to be over here. Great. Now, one thing we can do is make these smaller. Well, that's actually just making that one bigger, huh? Okay, so you would make them smaller by making something else bigger or by adding in a blank space, which would then help you adjust the size by taking up the space that you're not using. Another thing to pay attention to is this fixed width. So once you start to drag the size on something, it no longer is dynamic. So if we unfix that width so that it's only taking up whatever space is left. Oh, and that one is not fixed width. And then we can edit the width on this to be even bigger. Then it will squish things over to where we would like them to be. So that's one of the ways you can add space or make things the size you would like them to be. Now let's take a look at filters. Oh, before we take a look at filters, I want to look at this map one more time because I think that it would be useful for our colors to be a little bit more distinct. So one quick way to navigate to your worksheet from your dashboard is to click this Go to Sheet button. And while we're here, I'm going to click on Color, Edit Colors, and we did red and gold, and we're going to change it from this sequence to a stepped color, and we're going to change it to 3 colors. So it's going to either be this color, this color, this color, and when I hit OK, you can kind of see it's a little bit more dramatic in our differences, and it's put everything into the 3 categories we defined. So let's go back to our dashboard, and we can see the difference there. And now we're going to take a look at our filters. So we want to be able to filter by country. So let's bring country onto filters. And we're going to allow it to use all. And we're going to, here you can click Apply to Worksheets. And you can click Selected Worksheets, and it's going to pop up with all the worksheets in the whole workbook. And so one disadvantage of doing it on the worksheet is that you can see all of the worksheets in the workbook, and you have to differentiate between which ones are on the dashboard and which ones aren't. And these are the 3 on this dashboard, so we're going to hit OK. And we're also going to do it by year. So when we drag the year onto filters, we're going to allow them to choose years. So we're going to do the distinct number of years. We'll click Use All. Okay. And we're going to apply to the worksheets this one with the birth rate and the average life expectancy male versus female. We're not going to filter down our line chart by year because we want to be able to see it over time, and if we filter down the time, then we don't get as much context. So we'll hit OK. Let's go back to our dashboard. If I click on more options here and hover over filters, you can see that year filter and that country filter. You should also be able to see both of those filters on the heat map because I told it to apply to that one as well. So here's the country. Oh, I made a mistake. Let's go back to this visualization and apply to worksheets, selected worksheets. See, I wanted it to be on the birth rate and the heat map, not the line chart, and I clicked the wrong one. So that was a good test. So when we go here to the heat map and click down, you can see now we get the year of year as well. So we'll click year of year. Let's put it over here, and we're going to make it a multiple values drop down, and we'll bring it over to the middle. And let's also get the countries filter. Great, so now that we have these in here, we don't need this to be so big, so let's edit the width and make it 300, even smaller, 200. Great, and let's change our country to be a single value drop down, so you can pick one at a time. And let's also change it, or this year of year, since we can select multiples, let's change it so that on customize that you show the apply button. So here, since they can only select one, we don't have the apply button because it will just automatically apply. And here, since they can select multiples, we'll let them unselect all and pick their years and then hit apply. And then you'll see the changes. And you can see that even though I've selected only 2011 and 2012, you still see all of the years on this line chart as expected. And there is our health dashboard.
Our next dashboard is going to have to do with economy. Our first sheet is going to be another map that is going to have to do with overall GDP. And as we usually begin with maps by double-clicking on country and changing it to a map mark type. And this time we're going to bring on GDP onto color and change it to average. And we can edit the colors. Let's this time do a custom diverging, so you get to pick both colors. And let's pick a little bit lighter. Okay, red for there, and then we want to do maybe like a deeper green. And that way, you can see who has the highest GDP, which is green. We hit apply, okay, and then it will eventually get lighter and lighter until it goes to gray, which then it will lead to green. Okay. And next we're going to make scatter plot, which we will call GDP versus GDP per capita. So GDP, or gross domestic product, versus gross domestic product per capita or per person. And to make a scatter plot, you have one measure on one axis, and then another measure, which is going to be GDP per capita, which we will now create on the other axis. So let's start with GDP, and we'll hit duplicate. And let's edit that. And we're going to call it GDP per capita. And we're going to take sum of GDP and divide it by the sum of the total population. So population total. What is my error? Opening parenthesis. There we go. And then we have GDP per capita. So what this will do is sum up the GDP across whatever measures we have in place, across whatever dimensions we have in place, and then sum up the population for those same dimensions, and then divide it, instead of dividing it per row and then doing an aggregation on it. Okay? So now we're going to bring on GDP per capita on the rows. And we have the sum of GDP and the GDP per capita. And to make it more than just one little mark on our scatter plot, we will drag on country to detail. And now we have one mark per country. And you can see some countries have a high GDP per capita, and some countries have a high GDP overall, but not as high of a GDP per capita. And so on. We have some middle of the road people here. So we can change this from automatic to circles, and now they're dots like you might see on a scatter plot. And you can drag region onto color, and now we can see our different regions. And we see a lot of reds here, and it's quick to see what region things belong in. Also, you can click to highlight, and you can see all of the Americas highlighted in context. The next visualization we're going to make is going to be showing how much countries spend on healthcare as a part of their GDP. So we're going to rename it to be GDP on healthcare. And we're going to look at each of our countries. And we're going to make a bar chart that shows the health expense GDP. And we're going to change this to average. And we're also going to show the health expense per capita. Over here it shows how much is spent per person on health. And this is showing how much is spent on health based on GDP. Click at the top and click sort, and it's sorting by this first one. And you can see which countries spend the most of their GDP on health. We can again bring region onto color, so we can see the different regions highlighted. And let's bring on labels. So for our different marks cards, we're going to want to control click this and drag it onto the labels. And we can see that it's a percentage, but it's coming up as a number, so we can right click and click format right there. And we're going to change the number to percentage. Maybe just do 1 decimal place. And then for this one, we're going to control and drag that onto labels. And maybe we'll change this one to currency. However, if you don't want to change it to currency, since we aren't sure necessarily what currency this data set is in, it's worth checking out what currency it is in. So for now, we'll just have it as a number. And now we're going to customize our tooltip. So we're going to go to the overall marks card, and we'll click on tooltip, and we want it to tell us the country in the top. So we'll erase region, and we're going to erase country label and center country. And then we're going to put this country spends this percentage on healthcare. And if you want to preview it, you can hover or click here on preview, and it will show you an example. Marshall Islands spends 2.1% on healthcare. We'll hit enter, and then when we hover, it tells you the country, and it has our custom tooltip on both visualizations, or on both of the different axes. So let's build our dashboard. We'll bring on our map. We'll bring on our healthcare visualization and our GDP versus GDP per capita. And we'll move our legends to the top again by adding a horizontal container to the top and bringing them up here. One thing we can do also is to give this more space. We can have it go all the way to the top, and these legends are just side by side, just above the map and the GDP per capita scatter type plot. An interesting thing you can do in Tableau is you can see this outlier of the United States is making it difficult to see the rest of the information or to visualize if there's any trend there. So you could right click on it and click exclude, and then it will exclude it from your data set very quickly. And then you'll just click this back button to get it back. Great, now let's take a look at filters. We are going to do a single filter. So let's go to this visualization and we'll bring on country. We'll click use all, okay. And we're going to apply it to worksheets. So I showed you how we can apply it to worksheets here. You can also apply it to worksheets once it's on the dashboard. So if we come here and look at filters, we can see that country is on the filters for this visualization. But if we come down here and look at filters, we still see country because it's in the details of the information. So either way, when we add country, since I added it from this visualization, it only affects this visualization. Okay, but we want it to affect all on the worksheet. So we're going to apply to worksheets, and we can click selected worksheets, and we can click all on dashboard. Okay, let's bring this over here. We're going to allow them to see all at once and be able to scroll and select the ones they want. And now, when we select different ones, it affects all 3 worksheets. We're also going to add an action for a URL action. Add action, go to URL, and when we click on a country on the overall GDP map, we want it to take us to the Wikipedia page that talks about the economy for that country. So that is this URL, and it's going to say Wikipedia for economy of, and we're going to add our country to the end. So we hit OK. We have it running on menu, so let's change it to run on select. And as soon as you click it, it will take you there. Okay, so now let's try it. And we can click on Canada, and it will take us to the Wikipedia page for the economy of Canada. Great. We click on Brazil, same thing. So if we unselect on Brazil, then it will make our map highlighted normally again. We can also use this one to filter the other visualizations. And so we could click use this filter here, and then when we click on France, it will filter these 2 other visualizations to France. You can see that when we filter this visualization to a particular country, so if we look at Germany, Germany wasn't green before on our map, but now it is. That happens because our scale has changed just for the ones selected. So if we control click France and Germany and Switzerland and Austria, we now have a scale that reflects only these countries, and the biggest is going to be the darkest green, or the highest GDP is the darkest green, and the lowest is the lightest pink. And there is our economy dashboard. You can see that we have some nulls on these visualizations. That occurs when we don't have all of the data for every point. You can ignore those and they won't show up on the final visualization when you publish it to server, or you can deal with those by clicking on them and filtering that data out, or showing that data at the default position, which is showing the null values at 0. Our final dashboard is going to be about the ease of doing business in a country. So our first visualization is going to be a bar chart, which we will call Days to Start Business. So how many days it takes to start a business is important to know when you're trying to start a business in a country, and also can be an indicator of how easy it will be to do business in that country. So let's make a bar chart that includes every country, and then we're going to bring on days to start a business, and we will sort it smallest to biggest. And we have some days or some countries that don't have any days, so let's filter out those countries. And we're going to filter it to only those that have a good market. We're going to make a calculated field. We're going to define business-friendly market. We're going to define our market based on how easy it is to start a business and how many days it takes. So if it takes less than 25 days to start a business, we'll consider that a good market. And so we're going to do if the days to start a business is less than or equal to 25, then else if days to start a business is greater than 25, then business might or might not work. Doing less than or equal to 25 or greater than 25 allows us to be able to define these two different markets. So we'll hit apply there. And we're going to filter it just to a good market. And we're going to look at just 1 year. We'll look at 2012, our most recent year. And we're going to color it based on region. And we can see which regions tend to have the shorter days to start a business. And we're going to move on and build our next visualization, which is also a bar chart, which we will call Ease of Business. So we have this Ease of Business field, and we can bring on the country and we can bring on Ease of Business. And we want to make it a measure. So the Ease of Business is at this point looking at it like it's a string, and we can change that in our default properties and convert it to a measure, or use it up here and change it to a measure. When we try to change it to a measure here, it wants to treat it like a string, so it wants to take the minimum or the maximum. But if we here convert it to a measure, then it also automatically made it a count. So the first thing to do would be to change the data type to a number. And now we can change it to a measure and aggregate it. So we could do like the sum of Ease of Business. In our use case, we're actually going to do the average of Ease of Business. And then we want to have the smallest on the top. We do have some that don't have Ease of Business ratings, so we're going to filter that data out. And again, we want the year to be 2012, but how we're going to do that is by coming to this visualization and by applying this particular year of 2012. So we'll do it on select workbooks and select ease of business. Okay. And now this one also has the year of 2012 there. And we're going to segment this by creating another header. We're going to call that business friendly. And we're going to say that if the ease of business is, so I guess this is a nice thing to know. So if we start typing in what we want to see, then we can select it from a list here. But you can also interact outside of this box, so you could just grab ease of business and drag it into the dialog box here, and that's really nice. So we're going to say if it is greater than or equal to 1 and less than or equal to 3, then we're going to say it has the most business friendly regulations. Give us a little more room to look at. Okay, and this statement won't work because it's saying and what is less than or equal to 3. So you have to have ease of business in both places. And then this should say then and not the. Great. So now we're just getting an error because we don't have an end. So if that's all we wanted to do, then that's what we would do, but then we'll just do another else if. And it's already taken, this if statement goes through one condition at a time. So it's already classified everything that's between these two numbers. And so now we can just say if ease of business is less than or equal to 10, then we'll call it very, very business friendly regulations. And we'll keep going. Else if ease of business is less than or equal to 50, then we're going to call it moderate. And we're just going to say moderate business regulations. Copy that for later use. Less than or equal to 150, then strict. So the reason that this doesn't grab everything that is less than or equal to 150 is because these sections 1 to 3 and then 4 to 10 and then 11 to 50 have all been classified up to this point. So it's just getting everything else. And we're going to finally say else everything else is going to be called not preferred for business. And see if we get any errors. Calculation is valid. Let's see if this works as we expect. So we'll hit apply and we'll bring business friendly onto our rows. And now it categorizes everything based on what we said. So we want to define what order these go in. So we're going to click sort and we want the most business friendly at the top. Then we want moderate, then strict, then not preferred. Okay. So we have our top 3 that are the most business friendly, and then we've got 4 through 10, which are very, then we've got our moderate, our strict, and our not preferred. So let's bring region again onto color, and we can see which regions are the most business friendly. And we have our year of 2012 there. And now we're going to make this even more useful by adding the business tax rate onto the label so that you can see that business friendly is like Singapore, but they have a pretty high tax rate of 27. Whereas if you get down to some of these that are not preferred, some of them have really low tax rates. So let's make sure that we're getting, the right tax rate. So you can see that 27 is definitely not the highest tax rate that we have for business. But you can also see that there are places that have even lower tax rates, like Saudi Arabia, and we have 8% here. It looks like we don't ever go to that second decimal place. So let's quickly format this. Oh. Business tax rate is also text. So if we could convert our data type to decimal, and then we will format it to be a percentage, and we just need the 1 decimal place. Okay, now let's make some annotations. So we could come and click here on this mark, and then we can annotate that mark, which will make this dialog box, and it's already filled in here. And so we could use some of this information. So I'm going to copy that, and I'll put some hard returns there. So we're going to say that this country is the most business friendly, but has a business tax rate of, and let's grab the tax rate. And then we'll erase this. And we'll hit OK. And I made a typo. So Singapore is the most business friend is not what I meant to say. So I can click edit, business friendly, but has a tax rate of, and you can move this around. Draws the line to Singapore, which is the mark that we wanted to annotate. So that is an annotation on a mark. If we wanted to just make an annotation for the area, then we could point out that more business-friendly countries often have high business taxes. We could change that size, make everything fit. Now we have this second note where our user can come in and see some more information about what's being presented here. Great. And now we're going to make one more visualization, and it's going to be about phone and internet usage, because you may want to know about the phone and internet trends when you're looking to start a business. So we're going to do this one over time. So it does not need to have that year filter on it. And we're doing our axis. And we're going to look at mobile phone usage. So I double clicked it, it shows mobile phone usage over time. And we're going to change it to average so that it's averaging it across the countries. And then we're going to bring on internet usage. So we'll bring it on side by side, so we have two visualizations. And we're going to also make that average. Now, we might not want these to share an axis because they are measured a little bit differently. And so we can make it a dual axis, but allow them to keep their independent axes. Or you can synchronize the axes and see them at their rates. However, the usage is just a little bit of a different measurement. We can have one of them be a bar chart and the other one be a line. Let's have this one be the bar chart. Okay, and then the line is in the front. You can also change which one's in the front by coming and clicking on the axis itself. And you can click Move Marks to Front, and that moves that one to the front. Okay, and now it's made each of these wide, and there's like a start point and an end point on the axis for the bar, and that comes here under Size, where they're all fixed. Or you could have it be manual, where we can define the size of the bars. So we're going to make those bars like this. And we can see them going up over time. We can also change the width of the line itself. Make it thicker or thinner. And we can change the colors here. So let's change it to orange, since red might imply that it's bad in some cultures. And now we can see our internet usage and our phone usage over time and how it's trending. And so this will all come together on our new dashboard, which is about ease of business. You can see that I have a sheet called Ease of Business and a dashboard that I've called Ease of Business, but it won't let you create a dashboard with the same name as your worksheet. So, Ease of Business Dashboard. Let's have it fit the screen. And we're going to bring on our Days to Start Business visual, our Ease of Business visual, and our phone and internet visual. Let's put our legends at the top again. So we'll make our horizontal container. And we'll bring our region legend into there, and then our measure names for internet versus mobile phone. And we have a filter that already is pre-applied to two of the visualizations called Year of Year. And it's selected 2012, and if we select 2011, it's only changing this one, it's filtering out all the information for this visualization and changing this one to 2011. So let's see why that's happening. If we go to this visualization and click the Go to Sheet, we can see year of 2012 is here. Let's click Show Filter. And if we change the filter to 2011, okay, it's not showing up here, and the only filter I can see that could be removing it is this Average Ease of Business that is removing anything that is null. So if I pull that off, you can see that we don't seem to have any information for 2011 for Ease of Business. And the more years I select, I'm not seeing any Ease of Business information. So we're going to want to set this to 2012 only, because that seems to be the only information that is useful for this visualization. So let's go back until we're back to the state we were in when we started. Okay, so here we are. Now we're going to want to remove this filter, and we're going to give it its own filter that only selects 2012. That is not connected to the other filter. So now, when we change year of year, it only changes this visualization. Sometimes that's useful to note, sometimes it's useful to put, let's do a single value drop down. Sometimes it's useful to put this right next to the visualization it affects. So if we could change it to floating and just put it like here, that makes it clear that it's just changing this chart so that people don't get confused. Another thing that we can do, that we should do on all of our visualizations, is change the titles so that they're more business or user friendly. Great. And So we have our filter, and let's use this as a filter, and that way we can click on New Zealand, and we can see its most business-friendly regulations, and we can see its internet and phone usage over time. We can click on a lot of different countries to see those changes. You can see that some countries have a steeper change, so some of them have adopted phone and internet usage and have stayed pretty similar, whereas other ones have only really adopted it in the last couple of years. Also, if we wanted to filter to just one country, we could do what we did before and create a country filter. Here's another way to go to the sheet. You can click this down arrow and click Go to Sheet, or you can come over here. You can see that it's highlighting a visualization over here, or a sheet, and whatever sheet I click on is highlighted over here. And there's this little pop-out arrow here that also takes you to the sheet. And we can bring country on, use them all, go back to our dashboard. We'll go to filters and select country. We'll make it a multiple value drop-down. We're going to add the apply button, and now we're going to make it apply to all the visualizations by clicking apply to workbooks, selected worksheets, all on dashboard, okay. Now we can see that if we just want to look at Afghanistan, okay, we can see how many days it takes to start a business there. It's not preferred for business, and it's internet and phone usage over time. And those are our 4 dashboards. So as a review, we have made a dashboard on population. We made one about health. We made one that had to do with our economy, and one that had to do with our ease of doing business.
Now let's begin with understanding the history of Power BI and Tableau. So what really is Power BI? Power BI is a business analytics service provided by Microsoft. It has the capability to analyze and visualize data, extract insights, and share it across various departments within your organization. Power BI makes data visually appealing. It has easy drag and drop functionality, with features that allow you to copy all formatting across similar visualizations. Power BI fetches data from factory sensors and social media sources to get access to real-time analytics. Let's see what Tableau really is. Tableau is a powerful business intelligence tool which manages the data flow and turns data into actionable information. It can create a wide range of different visualizations to interactively present the data and showcase insights. Tableau has the feature of drag and drop, which allows its users to create interactive visuals quickly. It can also build interactive dashboards with just a few clicks. So Power BI was originally designed by Ron George in the summer of 2010, and the initial release was available for public download on 11th of July 2011. The key components of Power BI are Power BI Desktop, Power BI Service, Power BI Mobile Apps, Power BI Gateway, and Power BI Report Server. Tableau software was founded in 2003 in Mountain View, California, and the Tableau Desktop 1.0 was released in 2004. On 1st of August 2019, Salesforce acquired Tableau. Tableau products include Tableau Desktop, Tableau Server, Tableau Online, Tableau Visible, Tableau Public, and Tableau Reader. Now, let's see how expensive these tools are. Power BI is way less expensive than Tableau software. Power BI Professional version costs less than $10 per month per user. The yearly subscription comes around $100. Power BI Premium is licensed with dedicated cloud compute and storage resources and is priced at $4,995 per month. On the other hand, Tableau is more expensive, where the Pro version of Tableau comes at more than $35 per month per user. The yearly subscription costs around $1,000. Tableau Creator costs around $70 per month, while Tableau Viewer is priced at $12 per month. If you are a startup or a small business, you can opt for Power BI and then upgrade to Tableau if the need arises. Now coming to performance, Power BI is easy to use. It is faster and performs better when the volume of data is limited. Power BI tends to drag slow when handling bulk data. But Tableau can handle large volumes of data easily. It is faster and provides extensive features for visualizing the data. Tableau doesn't limit the number of data points in a visualization or enforce row or size limitations. So you can have a complete view of your data. Tableau's wide range of built-in analytic capabilities allows you to spend less time worrying about manually creating calculations, designing visualizations, and formatting dashboards. Now let's discuss the user interface of these tools. The user interface of Power BI is highly intuitive, and it can easily be integrated with other Microsoft products. Power BI interface is easy to learn and understand. It is user-friendly and allows you to operate better. Power BI Desktop provides 3 views which you can select on the left side of the canvas. The first view is of the report view, where you can create reports and visuals. The next is the data view. In this view, you can see the tables, measures, and other data used in the data model associated with your report, and transform the data for best use in the reports model. And third is the model view. In this view, you can see and manage the relationships among data in your data model. Tableau has an intelligent interface that enables you to create and customize the dashboards according to your requirements easily. It has an inviting workspace area that encourages you to experiment with data and get smart results. The workspace area has different cards and cells, toolbar, sidebar, data source page, status bar, and sheet tabs. With that, let us now talk about the different data sources that Power BI and Tableau can connect with. Another important feature of Power BI is that it supports various data sources but has limited access to other databases and servers compared to Tableau. Some of the examples are Microsoft Excel, text or CSV files, folders, Microsoft SQL Server, AccessDB, Oracle Database, IBM DB2, MySQL Database, PostgreSQL Database, etc. Tableau software has access to numerous data sources and servers such as Excel, text file, PDF, JSON, statistical file, Amazon Redshift, Cloudera Hadoop, Google Analytics, Dropbox, Google Sheets, Google Drive, and lots more. Now let's talk about the ease of use. Power BI enjoys a slight edge in terms of ease of use because it is based on a user interface that has its roots in Microsoft Office 365, which most end users are already familiar with. Tableau provides some essential advantages for exploring and visualizing data in detail. Tableau is also incorporating natural language capabilities into its software. This will help us in finding solutions to complex problems by understanding the data better. Next, let us understand how Power BI and Tableau differ in terms of programming support. Power BI supports data analysis expressions or DAX and M language for data manipulation and data modeling. It can connect with R programming language using Microsoft Revolution Analytics, but it is available only for enterprises level users. Compared to Power BI, Tableau integrates much better with R language. Tableau Software Development Kit can be implemented using any of the 4 programming languages such as C, C++, Java, and Python. By connecting to these programming languages, you can build even more powerful visualizations. Now coming to the most important category, which is data visualization. Power BI provides an easy to use drag and drop functionality. It provides features that make data visually appealing. Power BI offers a wide range of detailed and attractive visualizations to create reports and dashboards. Using Power BI service, you can ask questions about your data and it will give you meaningful insights. Tableau also allows its users to customize dashboards specifically for a device. It delivers interactive visuals that support insights on the fly. It can translate queries to visualizations and makes you ask questions, spot trends, and identify opportunities. No coding knowledge is required to work on Tableau, as Tableau provides inbuilt table calculations to build reports and dashboards. Now talking about machine learning and how they are different from each other. Power BI enjoys the advantages of Microsoft Business Analytics that includes platforms such as Azure Machine Learning, SQL Server-based analysis services, data streaming in real time, and many Azure database offers. It helps to understand the data and analyze the trends and patterns in the data. You can also forecast the data to make future predictions. Tableau supports the features of Python machine learning. This enables it to perform machine learning operations over the dataset. Finally, let's talk about customer support. Microsoft Power BI is relatively younger in the market than Tableau, and hence it has a smaller community. While Tableau has over 160,000 active users participating in over 500 global user groups and over 150,000 active customers participating in the Tableau Online community. Next, on the screen, you can see the Google trends for both the tools over the last 5 years from 2015 onwards. As you can see, Tableau is a clear front runner and is more popular these days with high search volume. Now talking about the Gartner Magic Quadrant for Analytics and Business Intelligence Platforms. So for 13 consecutive years, Gartner has recognized Microsoft as a Magic Quadrant leader in analytics and business intelligence platforms. And it has recognized Tableau as a leader in business intelligence after Microsoft. You can see there are other popular tools such as Qlik, ThoughtSpot, cSense, Oracle, SAS, SAP, and Salesforce. Now I will tell you how Simplilearn can assist you in learning Power BI and Tableau and help you become an expert in business intelligence. So let me take you to our website. I'll open a new tab. Let me search for simplilearn.com. I'll now search for Power BI in the search bar. So let me type Power BI here. I'll click the first link, which is the Power BI certification training course. So this course will help you learn about Microsoft Power BI desktop layouts. You will learn how to build business intelligence reports, dashboards, Power BI data analysis expressions, commands, and functions. So this is the course content. You'll learn about desktop layout, features, the views, connecting to common data sources. You'll learn about the query editor and its functionality. Then you will learn how to create relationships in your data model. You learn about calculated columns and measures, built-in aggregations. You'll also learn about data visualization practices, reports and dashboard layout, creating a sales analysis report, and lots more. Let me go back, and now I'll search for Tableau. I'll click on the first link. So this is the course for Tableau certification training. So it's around 56 hours of in-depth blended learning. There are 4 real-time industry projects. You'll get lifetime access to self-paced learning videos, 2 simulation exams. On the right, you can see the skills that will be covered as part of this course. We'll learn Tableau statistics, building interactive dashboards. There's arithmetic, logical, and LOD calculations, which is level of detail. Learn about heat map, waterfall, Pareto, clustering, forecasting. And here you can see the entire course content. After learning this course, you can go ahead and take the Tableau certification.
Let us begin with the differences between the two fundamental business analytics tools, Excel versus Tableau. So the first difference is who prefers to use Tableau and who prefers to use Excel. So basically, Excel is preferred by the professionals who are proficient in extract, transform, and load operations. Other than ETL, DBA also prefers an Excel sheet, and some real-time developers also prefer to use Excel sheets. And now getting into Tableau, the professionals who are experts in data science and data analytics prefer to use Tableau. The next difference between the two is the real-time support. So when you're performing some mathematical operations on either of these tools, that is Excel and Tableau, there are some fundamental requirements that needs to be satisfied. In case of Excel, Excel needs external programs for running real-time applications, whereas in Tableau provides all the real-time interactions without the need of any external programs to perform the mathematical operations or to create visualizations. Now the next difference between the two is the skills required. Now when you come into Excel, you need some basic programming skills and scripting skills to use Excel. But in case of Tableau, you don't need any coding skills because it already has all the database queries run against all the data that you have loaded onto Tableau in the background without the necessity for you to code something new. Now followed by this, the next difference between the two is functionality. So the basic functionality of Excel is to store and manipulate data according to the user's requirements. But when it comes to Tableau, the fundamental functionality of Tableau is only to visualize data and represent the data in the form of visually appealing charts and graphs. The next difference is related to automation. Automation is something which doesn't require the human interaction with data. But now when we come into Excel, the data refreshment or whatever the changes you made to the data, if you want that changes to be implemented onto your data, you need to manually refresh it. But when it comes to Tableau, Tableau will automatically take care of all the data changes that you have implemented. So the next difference between the two is cost. The Microsoft Excel is not available as a single product. If you want to use Microsoft Excel, then you need to buy all the Microsoft products such as Microsoft Access, Microsoft PowerPoint, etc., as all of these come as a single package. Now when it comes to Tableau, Tableau is available in different versions. The open source version, that is the Tableau Public, the desktop version, that is the Tableau Desktop. So relatively you have 5 to 6 varieties in Tableau and everything has a different cost. And Tableau Public is completely open source and free. So compared to Tableau, Excel happens to be a little expensive and Tableau is a little less expensive compared to Excel. Now the next difference between the both, business purpose. So the major business purpose for what Excel is used is to get quick on and off reports, whereas for Tableau, the main purpose of Tableau is to learn the business patterns and extract data insights to take up business-oriented decisions. Followed by this, we have our next difference, the data source integration. Now this is where the Tableau has the sharper edge against Excel. Since Excel has compatibility with limited sources such as another Excel sheet or some database, it cannot compete with Tableau head-to-head. Whereas Tableau has powerful compatibility with almost every available data source, maybe a JSON file, maybe an Excel sheet, maybe a data source such as DBMS, RDBMS, etc., or cloud, anything, even a website. Now followed by this, the next difference between the both. So the next difference is the capacity. So Excel is suitable for small scale data such as an organization data, but whereas Tableau, it has a powerful capacity. It can support both small scale and large scale and some bigger data sources such as cloud. Followed by capacity, the next major difference between Excel and Tableau is the language support. The Microsoft Excel has limited compatibility with programming languages. It can support only C# and C++. Whereas Tableau is compatible with a wide range of programming languages like C++, C#, Python, R, etc. Now, these were the fundamental differences between the Excel and Tableau. Now, let us move on to our next topic where we will discuss the average highest salary of Tableau experts. So, according to Glassdoor, the average highest salary of a Tableau expert is nearly 10 lakh rupees per annum in India. Now, we shall also discuss the average highest salary of Excel experts in India. So, according to Glassdoor, the average highest salary of Excel experts in India is nearly 8 lakhs per annum. Now, we shall discuss the career options for Tableau. So, the career options for Tableau experts are as follows: the Tableau Consultant, Tableau Architect, Tableau Developer, Data Analyst, and Business Analyst. Now let us discuss the career options for Excel experts. So the career options for Excel experts are to become an administrative executive, project manager, data journalist, financial analyst, and business analyst. Let's begin with our first project. So in this first project, we'll be dealing with the COVID-19 dataset, and using that dataset, we'll be getting some insights. So what are those insights? Those are, what are the total number of confirmed cases in different nations? What are the total number of recovered cases in different nations? So we'll be using the map chart for these, and we'll be finding out the insights about how are the cases going on in the current situation or in the current date or year. Followed by that, we'll also look into the insights of the confirmed and recovered cases in India as well. Followed by that, we'll enter into the next query where we'll find out the trend line of COVID-19 in the international level, like how it started, how is it going on. And moving forward, we'll create a group of Indian states and we'll find out the COVID hits there, and then we will discuss about the death rates. So highest death rates at international level and the least death rates in the international level. Then we'll enter into the next segment where we'll find out the variation in COVID-19 cases around the world. And then finally, we'll discuss the future of COVID-19 in the international levels. Basically, we'll create a trend line which will give us the forecast levels of the COVID-19, like is it going to increase or is it going to decrease, or what's going to happen in the near future. So I hope I made myself clear with the queries or the insights that we're going to take from the COVID-19 dataset using Tableau. So without further ado, let's get started with the Tableau. So we are on Tableau right now, so we'll be using an Excel data file. So we'll be using the COVID-19 data file. So this particular data set is available on Kaggle, and if you don't find it there, don't worry, we'll be attaching that particular data set in the description box below. You can use that as well. Now let's just select open to get connected with that particular data. So you can see that we just got connected with that data, and there will be some minute errors in the data, or there will be some problem with the data which the Tableau might identify, and when it identifies something messy with the data, it will show you an option. Maybe you might want to use the data interpreter, so I prefer using that. So whenever I see that particular option on the left hand side, I better use it for the safer side, for being on safer side with the data. And let's also select these, not a problem. Yeah, so the data got clean now. You can see that over here. So to do that, you can also check the review results. So when you click that review results option, then you'll get into this particular Excel document, which will help you with the changes made to that data set. So you can see that the orange color one says the data is interpreted as column headers or field name, and the green box suggests you that data is interpreted as values in your data source. And now you can see that. There you go. So now we'll get back to Tableau. Now you can see that the data has been interpreted successfully by the Tableau, and everything is as expected by the Tableau. Every data element in the dataset is as expected by the Tableau, and it's really fine now. Now we'll check the columns what we have in our dataset right over here. So we have the serial numbers, observation dates, province, state, and country or region, last update, and confirmed death recovered. So basically these three columns will be telling us the confirmed cases in that particular region, country or state, and the deaths happen in that region, country or state, and recovered rate, and the last update, when was the last test done, the latest test done, and in which region, and what's the observation date, what's the observation results on that particular date, and the serial numbers, etc., etc. So we have the clear understanding of a data set now. Let's get started with the first sheet what we have over here. So according to our first query, we had to find out the total number of confirmed cases in different nations. So for that, we might want to select the country or region, and then the confirmed from measures. So for that, we'll be selecting the map chart for this, so that we have the data shown in a more appealing format. So now we have the bluer color of map on our screen right now, where the darkest color shows the maximum number of cases confirmed, and the lighter ones represent the lower number of cases confirmed. Now let's make this look a little more interesting. So for that, we can select the edit color options, and inside that, let's select the red to green diverging. Yeah, this is it. Red to green, white diverging. And as you can see, the colors are a little opposite right now. So we want the greener one in the lower side and the red colored one on the higher side. This should be good. So let's select OK and apply and OK. So you can see that the red color now represents the highest number of cases, and a lighter red one here, you can see a little touch of red, which shows that the India's got some good amount of cases as well, and in the Brazil and etc. etc. So even Russia has a little light green, so this shows it also has some good amount of cases, not completely green though. Yeah, so this is how it looks. Now let's rename the sheet as confirmed cases. At the international level. Now, according to our second query, we are supposed to find the total number of recovered cases in different nations. So now let's create a new sheet for that. Now for that, we'll be selecting the country or region, and then we'll be selecting the recovered, and hover over to the show me icon, and let's select the map for that. Now you can see that we have a lot of recovery happening in India. So according to the stats, we get to hear that the virus which we have in India is a little, kind of harmful than comparatively what we had in China and other states of the world, or the other nations of the world. So yeah, we have a good recovery rate in India. Now let's rename the sheet as recovered cases. International level. Yeah. So I'm naming these sheets separately because we'll be using these sheets to create a dashboard at the end. Now let's get into the third query. What we have right now is find the total number of confirmed cases in India and what are the total number of recovered cases in India. So for that, let's create a new sheet and let's select country or region and confirmed. Now we'll be selecting the text table, and we have the complete data set right now. We have all the nations over here. So what we are looking for is just India. So for that, now we'll drag the country or region into filters, and inside this you can see we have an option of selecting India. Now let's search for India. GHI. So we have India over here. Let's select apply and OK. So we have the total number of cases in India. Now we can drag the state or province into rows, add all members. So in India we have all the states, and so all the states have their own confirmed cases. So this is the total confirmed state or confirmed count in India. Let's rename the sheet confirmed cases in India. Similarly, let's find the recovery cases in India. Let's create a new sheet for that. Rename it as recovery cases in India. So now let's select the country or region, recovery, and then let's close the show me icon, and now let's drag the country or region to filters, then none, select India, apply, OK, and let's drag the state or province here, add all members. Yeah, so you have the text chart here, which represents the total number of recovered cases in India according to the state-wise. Now, yeah, this looks okay, but we can make it look a little more appealing so that it's more visible and understandable, readable. So we can make that happen. So let's make a duplicate of this and recovery cases as well. Now I would like to change the confirmed cases in India into a pie chart, which looks a little bit more readable and understandable. Let's select the entire view so that we have a bigger pie chart and a little bit understandable or readable. Let's increase the size a little bit, and let's select the label and select the show mark label so that we have all the numbers over here. We can even select the province or state and drag it into detail, so we have the state's name as well. Or should we tag it into label? Yeah, now the recovered into label again. Yeah, there you go. We have the state and we have the confirmed number over here. So this is how we can make the data look a bit more appealing and understandable. So we can see that Maharashtra has a larger number of confirmed cases. It's the biggest state of India. So maybe, yeah, that's true. And now we'll get back to the duplicate sheet of recovery cases in India. And now let's make it look a bit more appealing by changing the way the data looks. So for this, we can select the packed bubble option. Now we can see the packed bubbles which show the recovery states happening in the Indian states, or the recovery cases. So you can see that everything is looking in blue color, a bit difficult to understand. So for that, let's drag the province or state into color so that we can have different colors for different states. Yeah, now this is good. We have the country name and state name. This is fine. Now we can make it a bit more readable by dragging the recovered icon into, or the recovered pill into the label. So we have the count of recoveries happening in that particular state and that particular country. Now it's a bit more readable. Now we have Maharashtra at the leading place. We have a good recovery in Maharashtra. Yeah, that's fine. Now let's get back to the presentation mode and see our next query. So can we forecast a trend line of COVID-19? Yeah. So how it started, how is it going on? So we can do that. Let's get back to Tableau again. So let's create a new sheet. We have the new sheet over here. Let's rename that as trend line. Yeah, the sheet got renamed. Now let's select the observation date from the dimensions, since we're making a trend line. So let's keep it observation date, or you can even select the last update. Let's go with the last update. Now let's select the confirmed pill from measures. So let's select a line chart, or we can do that from here as well. Okay, so we're not getting the line chart, so there might be some problem with the date format over here. So we have to change the data type of, so I think this might be something with the date. Yeah, let's select the date pill and change data type to date or date and time from string. So you can see we had string first, so now it's changed to date and time. Now we'll be getting a proper trend line. So now we have it according to the year, so we can make it according to quarter, and even in the form of months. And so if you see this a little bit readable, you can keep it that way, or you can even change to days. So yeah, I think there is some problem with date and time value. So let's keep it in the form of months. It's more readable in one screen. So yeah, it's good. Let's remove this. So we have the month update. Now let's go to analytics to create a trend line, and you can select the trend line and drag it over here and select the linear option. So you can see here we have the trend line over here which reads the R-squared and p-values and confirmed, and we have a formula for that. So basically Tableau creates a formula to create a trend line, so which is 5.280 exponent to the power of 8 into month of last update. So pretty complex formula, yet understandable. So this is how you create a trend line. So according to the trends, we have January, February, the quarters, Q1, Q2, Q3, Q4, and this is the first month of January. So here it is. So in January we find one. Okay, this is in billions, maybe, yeah, maybe even trillions, who knows. But based on the data we have in the last year, we have a decrement of the confirmed cases in January. So it's basically indicating that corona is basically or slowly decreasing. That's a good sign. Now let's try to find out the trend line for India. Let's duplicate this. So for that, let's drag the country into filters. We have the filter option, and let's select all. No, not all. We might want to select the Indian icon. Yeah, let's select apply. Okay. So now we have the trend line for India. Let's kind of rename it. Yeah. Even you can see a gradual drop of corona in India as well. So the number has decreased in India as well. In the earlier year, we had a lot of cases above 30 crores. Now we have nearly 20 crores. That's a good sign in India as well. Now let's get back to the presentation mode and try to select the next query. So according to the next query, can we group Indian states and find COVID-19 hits? Yeah, we can do that. Now let's get back to Tableau for that. Let's create a new sheet and let's rename it as grouped. So the sheet got renamed. Now we're going to select the country or region or province. Now for that, you can see the create option over here. Now inside that, let's select the group. Now we have to create a group of Indian nations. So select Andaman and Nicobar, hold control, select Andhra Pradesh. Now let's select a couple of states we know which are in India. Arunachal Pradesh, Assam. Don't forget to hold the control key for this, or else the options might vanish. We have Bihar. We have Chandigarh. We have Chhattisgarh. We have Dadar and Nagar Haveli, Dayu, Daman. We have Delhi. Yeah, we are going to just select a couple of states just to show how group can be done. So fetching all the states in this particular column would be a little difficult, or we might even miss a few. We have Gujarat. We have Haryana. We have Islamabad, Jammu and Kashmir, Jharkhand, we have Karnataka, we have Kerala, Ladakh, Lakshadweep, we have Madhya Pradesh, Maharashtra, Nagaland, we have Punjab, we have Rajasthan, we have Tamil Nadu, we have Telangana, we have Uttar Pradesh, we have West Bengal, and let's rename the group as Indian States Group. Let's select apply and OK. So after selecting the apply option and clicking OK, so we can have a new pill in the dimensions section that happens to be Indian States Group. So what we're gonna do is drag that pill into detail option so that we can have the results on our screen. So there you go, the states what we selected are right over here, all the Jammu Kashmir, Ladakh, and Punjab, Maharashtra, Gujarat, etc., and our Lakshadweep and the Andaman and Nicobar Islands. Right, so we have all the states of India right on our screen. Okay, let's expand it a little bit. Scrolling on Tableau is a little bit difficult. I don't know how to select the default option for the screen. Yes, we can see these states. I don't know where the scroller is at. Yeah, we can always undo what we did in Tableau, so that's the best part. Now let's drag the states pill again so that we can have a perfect map in the screen right now. Yeah, I would like to not to mess with it again. It's pretty good right now. Let's keep it as it is. Now let's quickly get back to our presentation and check out our next query. So find the highest death rates at international level. So we are basically going to find which nation or the country has the highest death rates, and which is the country with the least amount of death rates, so which is the safest country. Now let's get back to Tableau. Now we're not going to mess with this particular sheet. Let's create a new sheet. Let's rename the sheet as highest death rates. International, INTL. Let's enter. So the sheet got renamed successfully. Let's drag in country. And let's drag in confirmed cases. So we have a map over here. So Tableau basically kind of selected the map as default. We can drag the deaths, and now we can actually change this to a text chart. Now let's drag the measure names into rows. So we have a little bit more, sorted kind of data. So you can see we have the confirmed cases over here and death rates here. Now if we kind of sort it in the descending order, yeah, so the order is being changed now. So we have our charts processed by Tableau for a better visual. So our chart got rearranged or ordered in the descending order. So with that we have the highest deaths and confirmed cases in US. So we can even do that using a parameter where you can create the top 10 or top 5 nations with highest confirmed and death values. So for that you can drag both, or no, you need to create a parameter. I think it's not required over here. Let's continue with the next sheet, or you can just simply duplicate this. Since the dataset is a little huge, it takes a little bit of time. Now let's rename this. Yeah. Now let's rename this sheet. It's still taking a little bit of time. Yeah, now I think we can rename it least death rates. So now for that we're gonna rearrange it in the ascending order. So yeah, after sorting and changing some layouts, we have the least number of cases or death rates in the country called Macau, where we have least number of deaths and least number of confirmed cases. So with that, let's move into the presentation mode again. And in the presentation mode, we have our next query that says, can we find the variation in COVID-19 cases around the world? So for that, let's create a new sheet again.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
So after changing some arrangements, or by making an ascending order arrangement and changing the layout or the orientation and everything, we have our final result, which states that we have the least number of deaths and confirmations of COVID-19 in the country of Afghanistan. So yeah, so we have the pretty well sorted, arranged data over here on the screen. Now let's get back to the presentation mode, and in the presentation mode, the next query that we have to deal with is, can we find the variation in COVID-19 cases around the world? Yeah, we can do that. So let's get back to Tableau and create a new sheet. Let's rename the sheet as variation of C19. Yeah, it's done. So to find out the variation of COVID-19, we might want to use the boxes and whiskers chart. Let's select the country or region pill from dimensions and confirm from measures. Let's hover over to the show me tab and select the box and whisker plot. Yeah, so you can see that we just have one box or whisker over here. When you see something like this happening on your sheet, then directly head over to analytics and uncheck the aggregate measures. So we have this kind of visualization. Maybe we forgot something, so we forgot the country or region to be placed in columns. So when you place it in the columns section, then you find out all the countries and the variation of COVID-19 in their region. Now let's sort it in the descending order so that we can find out the maximum variation which is happening in France. So of course there are less number of confirmed cases, but there is a lot of variation which states that they have something wrong with the climatic conditions or the weather conditions there. Yeah, we have a larger confirmations and or larger cases in US, but there is some data which shows that France is leading in some variation. Yeah, so since we are calculating the variation of the confirmation of COVID-19 presence, we have France in the first place, where it shows that there is a lot of variation in the confirmed cases in France rather than US. Yeah, that's how we can find the variation of presence of COVID-19 in a particular country. So with that, let's move into the next query. So the next query is, can we forecast the sheet of future and reference of COVID-19 presence? Yes, we can do that. Let's get back to Tableau. For that, let's create a new sheet and rename it as forecast of COVID-19 presence. So the sheet got renamed successfully. Now we'll select the observation date from the dimensions and confirmed fill from measures. So we'll use them, drag it to columns, and the confirmed from, yeah. Now we're going to change this. Okay, there is something wrong with the observation date. So for that, let's select the observation fill and change the data type to date. Yeah, so far so good. Now let's select this to day. We can change that to year. Now let's select forecast option. Yeah, so this is how it's gonna be. So in the year of 2020, we had the confirmed cases around this number, which is 760,705,3464, so which is nearly 76,370 lakh. And in the 2021, the number got a little decreased, which is 17,130 lakh cases. And in the end of 2022, which is the forecast, we can see there is a little more drop. So it's a good sign that the COVID-19 is getting decreased. So this is the forecast of the COVID-19 presence in India. So we can change the path to step 1. The line is okay. The line is pretty good. No worries on that. So basically, we've finished the queries on our presentation mode. So yeah, if we get back to the presentation mode, so all the queries on the COVID-19 data are finished. Now let's create a dashboard. Yeah, we have the dashboard right now, so we can change the layout of dashboard. Let me increase the width to 1320 and decrease the height to 70 or 760. So we have the entire screen right now. Now let's drag in the confirmed cases of international level and the recovery cases of the international level. Yeah, now we have it. Okay, or let's keep it in the top and that in the bottom. The trend line of COVID in the international level and the highest death rates in the international level. It takes a little time. It's still taking a little bit more time. I don't know what's wrong. Okay, it should be done in some time. Let's wait. It's basically taking a lot of time because we have a lot of data in that particular sheet. Let's kind of change that a little. Now, let's change the sheet to yeah. Or we can just remove this from the dashboard and select the least death rate or the top 10 least death rates. So we have the sheet right over here. We have the top 10 ones only here. Yeah, this is good. So this is how we can have the dashboard. And now let's create another dashboard for Indian results. So again, let's change the dimensions of the screen. Yeah, it's pretty good. Now let's take the confirmed cases in India and drop it over here, and recovery cases in India and drop it over there, and trend lines in India over here, and Indian states, and the forecast somewhere over here. And if we get back to the dashboard 1, we can even add the forecast data or the variation data somewhere over here. And we can always change the height so that it's a bit more visible. So we can rename the dashboard C19 International Dashboard, and this one as C19 Indian Dashboard. Yeah, so with that we have finished the first project based on the COVID-19 dataset. Now we'll continue with the next dataset, that is the airline dataset. So now we are in the second project, and the second project is about the airline dataset. And in this particular dataset, we're going to take the insights, which are as follows. What are the total number of flights which are taking off in a day from the San Francisco airport? And followed by that, we have the next query, which reads out, find the busiest day of San Francisco airport. We'll be finding out the top 5 busiest days in the San Francisco airport, and followed by that, we'll also find what are the total number of flights per day in a month. Then we'll find out what are the top 10 busiest flight routes. Then we'll find out what are the top 10 longest flight routes from San Francisco airport. Then we have to represent the flights flying outside the San Francisco towards different parts of the world using a map chart. So these are the queries that we'll be executing in our second project. Without further ado, let's get back to the Tableau. So now we are back on the Tableau dashboard. So let's select our dataset for today. So our dataset is somewhere here. Yeah, this is the air travel dataset we were looking for. Now we got our air travel dataset loaded onto Tableau. So remember I said about the interpreter. I'll select that and show all the. Okay, let the query execute. Yeah, so the interpreter query got executed. Now the data has been cleaned. We can review the results by clicking on Review Results option over here. We have another query executing now. So basically, this query will take us to the Microsoft Excel sheet where our cleaned data is readily available for us. There you go. You can see that the red colored data is the data that is interpreted as column headers or field names. The green color one is the data interpreted as values in your data source. So it looks something like this. So we have our data fine over here, just looking fine. Now, when you come into the root column, you have San Francisco to the other parts of the world. For example, we have Los Angeles here, etc., etc. But we don't have a separate field for origin and destination. So what we'll be doing is we'll be splitting this particular column right away here. So let's navigate to the last column, which will show us the root. So you can right click this and select the option of split, which will basically split it into two halves, which will give us the from destination or the origin of the airplane and to or the destination of the plane. So from, to, or the origin, destination fields we have right now over here. You can see that. So far so good. So let's quickly begin with our worksheet. Now we are on the worksheet right now. So what was our first query? So our first query was to find the total number of flights in a day. So for that, we have a simple step. So basically we'll have a particular number of rows, right? For the dataset what we've selected, we will have some thousands of datasets. So each and every row is actually a flight. So what we will do is just create a calculated field and just name it as number of rows. Okay, since we are trying to calculate the total number of flights, let's kind of not name it as rows. Instead we'll name it as flights, and inside the calculated field just write 1 and it should be done. So you can see the number of flights just over here. Just hover down the text and we'll have the number over here. So this is the total number of flights per day which takes off from the San Francisco airport. Let's kind of increase the text size so that it's a bit more visible. Yeah, that should be it. Let's rename the sheet. From here I would do the renaming from here because it's a little simple. Total number of flights. Yeah, that should be it. Now let's get on to the presentation mode again. Now let's execute the second query. Find the busiest day at San Francisco airport. So to execute the second query, let's just simply duplicate the sheet and rename the sheet as busiest. Okay, we can actually schedules of flights, or no, not schedules of flights, number of flights, or we can rename this as flights taking off. So when we get the count of flights taking off, then we can actually find the date which was really busy, like the date with the maximum amount of flights taking off. That would be the busiest day. So the data type is date by default. That's great. Now let's drag it to columns. Now the sum of numbers at this place. Analysis. Let's uncheck this to get a map. Let's make it by month or day. Okay, we don't need this. We don't need this. We don't need this as well. Now we have a chart over here. Let's change it to scatterplot maybe. Yeah, so we have the chart. No worries on the scatterplot thing. It's really a scatterplot. No worries on that. So right now we need to find out the busiest days. So for that we might want to drag the date into filter, and let's select the individual dates. Select next, and inside the top we have the we need to select by field, and now we have the top 10 number of flights. We need the top 10 flights. So let's select apply. We needed top 1, but why not top 10? You will select top 10 for that. Now we have the scatter plot on my sheet right now. So let's kind of arrange it in the descending order. This shows the highest number of flights, or okay. We need to change this value to sum. Yeah, it is sum. So yeah, I got to know where we made a mistake. So inside analysis we were supposed to aggregate the measures so that we can get the sum of number of flights. Now we have the total number of flights. Now let's quickly arrange this. Now we have the 3166, 3200, 3295. Yeah, so 3295 happens to be our busiest day in the year 2020, that is the 6th March, which had the maximum number of flights taking off. So we can actually make a set of these. The set of these, which happens to be in the March. So March happens to be the busiest month for San Francisco Airport. So with that we have finished the second query. Now let's create a new sheet for our third query. Let's get back to the presentation. And the third query reads that what are the total number of flights per day in a month? So for that, let's get back to Tableau. Let's try to rename it total flights in a month. Done. So for that, let's select date and drag it to columns, and let's make it to month. Let's remove this. Let's remove this. Let's remove this as well. Now let's check it to day, and now number of flights. So automatically we have a line chart, and we have the flights taking off from March 1st to March 31st, which happens to be the busiest month for San Francisco Airport. Now let's just tick the show mark label so that we have the number of flights taking off every day. So as we got the result in the previous sheet, 3,295 flights on the date of 6th March, or is it 3rd March maybe? Yeah, that happened 6th March. That happened to be the busiest day of San Francisco Airport. Now let's get back to the presentation and check the fourth query. So the fourth query reads, what are the top 10 busiest flight routes? For that, let's get back to Tableau again. Let's rename the newly created sheet busiest routes. Now the sheet is being replaced or renamed. Now to find out the top busiest routes, we need a calculated field to remove the effects of San Francisco Airport first. So create a calculated field, and we can name it as busiest route, busy. And now inside the calculated field we need an if condition. Then if route 1 split 1 is equals to SFO, then route 2 split 2, else route 1. And yeah, the calculation is valid. Let's apply and OK. Now we have the newly created calculated field somewhere here. I will drag that into rows, and now we'll drag the number of flights to columns. So there we go. We have the bar chart over here. Let's rearrange it in descending order so that we get the descending order. Now we needed the top 10 or top busiest routes. For that, let's drag busy into filters, select top, and by field we have top 10. Let's just select apply and OK, and we have the top busiest routes from San Francisco Airport, or SFO. Now let's get back to the presentation mode, and in the presentation mode the next query is which are the top longest flight routes from SFO. So to find out the longest routes, we'll create a new sheet and rename it as busiest, no, not busiest, longest routes. Yeah, the sheet is renamed, and you can see that we have geometric coordinates 0, 0, 0, 1, 1, 0, and 1, 1. So these 1, 1 and 1, 0 coordinates basically provide the origin information, and 0, 0 and 0, 1 provide the destination information. So we'll be creating a calculated field for that. Now let's create a calculated field. So let's rename the calculated field as origin, and inside the origin we'll make use of make point, and inside make point we'll write geometry coordinates 1, 1 and geometry coordinates we'll need the geometry coordinates 1, 1 and geometry coordinates 1, 0 separated by comma, and done. So we have the origin. Now let's create another for destination. We are creating a calculated field destination, and inside destination we are going to use the same make point and geometric coordinates 0, 0 comma geometric coordinates 0, 1, and select apply. OK. Now the origin and destination are created. Now we need to create another calculated field for distance. So we'll write it as distance, and inside that we'll use the distance function, and we'll write origin comma destination, and we'll represent the distance using kilometers. And select apply. OK. Now we have the newly created distance measure in the measure section. Now we'll drag the busy into columns and distance into rows. Okay, we made something. Oh, there's no problem. We can actually change the orientation. And now let's rearrange it in the form of descending order. Now we have the distance sorted in the descending order, but there is a small change. We have to change the sum to average. So once you change that, you want to arrange it again. Now we have the BLR, Bangalore as the farthest airport from SFO. Yeah. Now we might want to drag the busy into filters again. Now we have the top 10, apply. Okay, so we have the top 10 longest routes from SFO. So with that, we have finished our 5th query. Let's get back to presentation mode. And the 6th query: represent the flights flying outside SFO towards different parts of the world. Yeah, that can be done. Let's get back to Tableau again. Now for the 6th query, let's create a new sheet. Let's name it as map flights from SFO. Okay, so for that, let's select the latitude and longitude and select a map. So we have the map right here. Now let's change that to map. Yeah, it's in the map section by default. Let's create a calculated field called lines. So we are basically using lines to represent the flights taking off from SFO. So I'll name it as line, or we can name it as flights line. Okay, and inside the calculated field, let's type in make line, and so inside the field, let's make use of make line function, and inside that, let's write an origin and separated by comma destination, and the calculation is valid. Apply OK. Now we have the newly created flight line over here. Now we'll drag that flight line to detail. Now once we drag that flight line to the detail, we have the lines or flights taking off from SFO to different parts of the world. Now we can make it look a bit more appealing or more informative by dragging the routes, or into detail. So we have the details of routes, and we can even drag the distance into detail. So when we hover over to the line, we'll have the route and the distance as well. Yeah, so that's how it is done. Now we're basically done with all the queries. Now let's create a dashboard. So now let's kind of arrange the dashboard size convenient to our monitor. So I'll increase it to 1320 width and decrease the height to 760. So that's the proper size what I was looking for. Now we'll drag the details into the sheet. Longest routes. We have the flights taking off, busiest routes, longest routes, and total flights into here. Now it looks more readable. Fine, so we have the busiest routes, we have the longest routes, we have the flights taking off in the month of March. The busiest month was the March, and the busiest day was 6th of March. I don't know what was so special on that day. If you know it, please let me know in the comment section below. And yeah, so totally we created a dashboard. Now let's rename the dashboard as SFO Flight Data Dashboard. And we are done. So we're done with the second project. Now let's get back to our presentation and let's check the last project, that happens to be the space missions dataset. So now we are in the third project, which is based on space missions dataset. So using this particular dataset, we're going to get some insights which are based on the queries on my screen right now. So we're going to find out what are the average temperature details of the launch sites, what are the average wind speed details of the launch sites, what are the average humidity details of the launch sites. So we need all these to, before launching a satellite or a rocket into space. Everything needs to be in ideal condition. So followed by that, we have what are the different varieties of launch vehicles used by different companies. So there are a lot many companies. Few are from government sector, few are from private sector. For example, USA military satellites belong to government, and private satellites like SpaceX, and few others. Next, we have what is the mission status of the company. So we have a list of satellites launched already, right? So we need the mission status of that particular satellite. Is it a successful launch, or was there some failure record or something like that? Next, at the last query, we have the track records of launch sites. So what are the track records? So what are the successful launches? What are the failure launches? What are the satellites launched by different companies, etc., etc. We'll have a complete track record of that, of all the launch sites which are available in our data set. Now, without further ado, let's get back to Tableau and start the project. So we are on Tableau. Now we're going to extract the data set. So the data set we need is the space missions data set. You can get this in the Kaggle, or you can even have the access to this data set from the description box below. Select open to open the data. So yeah, the data got successfully loaded. Again, use the interpreter, and it's a good habit of using the interpreter to clean your data and make everything understandable or look understandable. Show all aliases, everything is fine. So we're good to go with the dataset what we have in our Tableau right now. Now with that, let's get back to the first sheet. Now let's check the first query that we have in our presentation. What are the average temperature details of launch sites? So for that, let's create a new sheet. Yeah, it's created. Rename it as AVG temperatures. Or launch site temperatures. So now we need the launch site and select the temperature, and hover over to the show me tab, and let's select the bubbles chart. So now you can see the temperature is in the sum, but we don't need the sum here. We need to change that to average. Now we have the average temperatures of the launch sites. Now let's kind of select the label show marks here. So we can do one more thing. We can drag the temperature onto the label. Now we have the temperature here. Now let's again change the measure to average. Now we have the average temperatures of the launch sites in Fahrenheit. Yeah, that's pretty well. Now let's get back to the presentation, and the next query is what are the average wind speed details of the launch sites. Let's get back to Tableau again. Let's create a new sheet, launch site wind speeds. Now let's drag the launch site into columns and wind speed from measures into rows, and you can see automatically we have a bar chart. But to make it a little bit more readable, let's select the boxes and whiskers chart. Yeah, you know what to do now. Go to analysis, uncheck the aggregate measures options, and let's drag the launch site again onto columns. Now we have the different box and whiskers for different sites. So let's kind of arrange it. Yeah, so the wind speeds at Kennedy Space Center are here, 20 miles, and 23 at Vandenberg, and Marshall at 9. Yeah, so this is the wind speeds at different launch sites. Now let's get back to the presentation mode, and now we have to find the humidity details of launch sites. So let's get back to Tableau. We are back on Tableau. Let's rename it humidity launch site Now let's select the launch site and humidity, then a pie chart. The pie chart is really small, so we can select the entire view. Now we have the sum of humidity, but we need the average humidity. And now let's drag humidity onto label and launch site to label. Now we have the detailed humidity. No, we need to select the measure to average again, and here to average again. Yeah, so we have the humidity percentage of launch sites on the pie chart over here. So with that we are done. Now let's get back to presentation again. Now our fourth query, which states that what are the different varieties of launch vehicles used by different companies. For that, let's get back to Tableau. Now let's create a new sheet. Launch vehicle details. Yeah. Now this query is pretty straightforward. Select company and vehicle type, and we should be done. So there we go. We have the company name and vehicles used for the launching of satellites process. Now let's get back to the presentation mode. Let's select the next query. What is the mission status of companies? Now let's get back to Tableau. Let's create a new sheet and rename it as mission status. Now we are back on Tableau. Now let's select the company, drag that to columns, and mission status to columns, and we'll select one parameter from measures so that we can get a good bar chart, side-by-side bar chart. And now we can drag the company to color so that we can have different colors for different companies. So we have the mission details. So SpaceX found a maximum success in the recent days and little failures, and yeah, Boeing found good success as well and some failures. So these are the mission status of different companies and different satellites as well. So we have even US Air Force here faced some satellites here, some failures in some satellites. It's okay. So now let's get back to presentation mode. Now the sixth query is track records of launch sites. Okay, we had the payload as sum, so we change it to count, distinct count. So now we have a better observation of failures and successes over here. So as we discussed in the sixth query, now we need to find the track records of launch sites. Now let's create a new sheet, rename it as track records. And now let's drag the company to columns and mission status to columns again. And now let's drag the launch site. Yeah, I think we might want to drag the mission status to rows. Yeah. Let's click on text. Now let's drag the space missions count to color and space mission count to labels. Let's use this one. Yeah. Now we have the stats or the track records of different space centers or launch sites, and we have the failures and success rates over here. Yeah, so basically we have done the last sheet or last query executed. Now let's create a new dashboard. As we always do, change the resolution according to the monitor we have. So I'm going to use 1030p. And height as 760. Now let's drag the sheets. So we have the launch temperatures, launch wind speeds, and launch site humidity at one place. Now the launch vehicles used, mission status, and the track records. So we'll kind of drag it here, and this one over here, this little bit over here, and this one over here. So now we can actually, select the track records of Cape Carnival. We have the site temperature, we have the site humidity, we have the site wind speed, and the track records of that particular site, and launch vehicles launched, mission status, everything on one single dashboard. So that's how you make use of dashboards in real time.
Today we'll be going over answers to common interview questions for Tableau positions. First question is, what are the data types supported in Tableau? We have string, date and time, numerical, Boolean, so true or false, and geographical. In Tableau, you can tell what kind of data type you have. So when you're on the data source tab, you can see that this is numerical and this is string. Here we have a date. We don't have any date times here. That would have the little clock icon. And we also have geographical. These are set by default, and you can change them by clicking on the icon. And say we wanted row ID to allow text, so we'll change it to string. And you can see the icon changes there. The next question has to do with how well you understand dimensions and measures. So a key thing to remember is that dimensions are qualitative and measures are quantitative. And if you can remember those particular words, it helps convey what the interviewer is looking for. So dimensions are qualitative, and you can use them to categorize your data. So for example, you can categorize your data by what country it comes from. And measures are quantitative and can be aggregated. So you can do a sum of sales, or you can do the average profit. Did you know that Tableau automatically assigns each field a data type and a role, and that it automatically aggregates your measures using sum? But you can change what the default aggregation is. Question 3. What do you understand by discrete and continuous in Tableau? So we have discrete values and continuous values. Discrete is represented as blue and continuous is represented as green. So let's look in Tableau. When we go to our worksheet, you can see that all of the dimensions are automatically blue and all of the measures are green. However, you can have a continuous dimension and you can have a discrete measure. So we have discrete dimensions, which is a blue dimension, but also continuous dimensions, and date is a good example of that. Let's take a look. So we pull on order date. We right now have year, and it's making categories instead of a continuous axis, so it's making a finite list there. But we can change it to be, you can see now it's marked as continuous here, and it's green, and we can change it to be an axis. Instead of different categories, it would be a continuous axis. So you can also have discrete measures, which are blue measures, and continuous measures in the green. So for example, let's say we had a visualization that had the region and sales and profit. But instead of having an axis for profit, maybe we just wanted to have a number for the profit listed right next to the region, and then we could have the sales visualization. So what we could do is change it to a discrete value and put it next to region, and now it's part of the labels. And that's an example of having a discrete measure. Did you know that continuous is infinite and discrete is finite? Those are some key words that you could use also to describe the difference between continuous and discrete. And also just remember that discrete is blue and continuous is green. The next question, number 4, is what are filters? And name the different filters in Tableau. So filters are a way to restrict the data that allows you to only see the data that you want to see in your workbook or dashboard. And there are these different types of filters, and they also have a specific order. So if you can remember the different filters, that's helpful. but also if you can remember what order they apply in, that'll get you some definite bonus points in your interview. We have extract filters that filter the data as it extracts, and it will affect how big your extract is. We also have data source filters here, which will filter the data out of the data source. However, the extract will still be the same size. So let's take a look at this handy visualization that Tableau has on their website. We have the order of operations, and in blue we have our filters. So extracts is first, and it filters down your extract to just what you've selected. Then we have data source filters that will apply to the entire data source. So any visualization that uses that data source will have these filters. We also have context filters, which are next, which come before some of these level of details. That's the major difference, is that it applies before some of these sets and conditional values. And then you will do dimensions and then measures. So any filters that happen on dimensions happen before any measure filters. The last type of filter we have is a table calculation filter, which happens after all of the rest of them and basically just applies to your visualization, just the one visualization. Question number 5. There are 3 customer segments in the Superstore dataset. What % of the total profits is associated with the corporate segment? Perfect. So in some Tableau interviews, you may be asked to build a visualization. For our examples here, we'll be using the Superstore dataset, and if you don't have access to the Superstore dataset, just comment below and somebody on the Simplilearn team will help you get access to that. Also, this is a fun opportunity to pause the video, and then you can work on this on your own, and then come back and see if what you did was the right thing or how we did it differently. Also, you can comment below on what your answer is, and we'll see if we can all get the right thing. So let's build this. 3 customer segments in the Superstore dataset. What % of the total profits is associated with corporate segment? Great. So we're going to bring on our segments, and we have consumer, corporate, and home office. And let's bring on our total profit. So I just did that by double clicking, and now it's just bringing on the sum for each of those by default, but we want to figure out what % of the total each of these are. So we can change this to be a table calculation. We can click add table calculation, or we can do a quick table calculation and find % of total. So let's go back to our question. We wanted to know the % of total profits associated with the corporate segment. And the corporate segment has 32.12% of the total profits. And here's our solution with 32.12%. So did you get it right? Comment below if you got that. What are the different joins in Tableau? Give an example. So in Tableau, you can join your data. So if we wanted to look at orders and tie it to people, we can pull on people and it will give you this visualization, and you can see all the different joins here, and we'll discuss those in just a second. You also have the opportunity to union information, which would be if we had maybe 2 Excel sheets that had orders information. Perhaps one of them had 2012 and one of them had 2013. Then you could take your orders and pull it. So you see that pop up, drag table to union. And that's another way to add more data. And so those are all worth mentioning. Let's take a look at the different kinds of joins. We have our inner join, which will only give you the values that have matches in both tables. Our left join, that will give you all the values in the left table and its matches in the right table. And then the right join, which will give you all the values in the right table and its matches in the left table. The outer join, also known as a full outer join, will give you all the values in the left and the right table. And then as we discussed the union, you can see it's represented by a more vertical join, and what it does is it adds more rows. All the rest of these are about adding more columns, but this will add more rows in the same columns that you had before. If you have the opportunity to draw out the answer to this question and make these Venn diagrams, it's a really helpful way for you to explain your point, and it really portrays that you know what you're talking about. What is the difference between a join and blending in Tableau? So I just showed you how to make a join here, and we are joining an Excel sheet to another Excel sheet, all within the same connection to that Excel file. So when you're joining data, we'll look over here at the joining side, that's when you're bringing 2 or more tables within the same data source, and that's how you join it. And so we're all inside of a data source here, which, when I go to sheet 1, just has one data source here called orders, whatever we wanted to call it, and that is all within one data source. However, let's say we already had 2 different data sources in Tableau, and we wanted to bring together 2 of them. So in this case, it's an Oracle table, and we brought in an Oracle table and we made a data source, and then also an Excel table that had a second data source, and you can blend it together to get your combined data set. So the major difference, what you're going to really want to take away from this, is that blending is from 2 separate Tableau data sources, and that joining is all within one data source, and it ends up just being one data source in the end. In blending, each data source contains its own set of dimensions and measures, and when you join, it will combine it into one set of dimensions and measures. So let's go back to our example here. Let's bring on people. It is automatically said we're going to join it on region, and we're going to do an inner join. That's fine by me. And so we come here, and now we have just one set of dimension and measures under orders. However, if we were to add a second data source, which we will, it'll be an Excel file, and it will be based off of this rank example. We'll open that up, and now when we go to sheet 1, we have 2 data sources. And if we were to blend this data together, we would still see 2 separate sets of data, only we would be able to pull in from this set some information, and we'd pull in from this set some other information. So that's a visual difference between blending and joining. Question number 8 is, what is the difference between a live and an extract? So first we'll talk about live, and we'll say that your dashboard is connected live to a database. And so a live connection will query that database every time you open up the dashboard or visualization, so that you're getting the most recent information each time. And it's useful for if you need information that's a little bit more real-time. However, it can be slower, especially if your queries are complicated. With an extract, it will run the query beforehand and store the information on Tableau server or on your local machine, and so that it's faster to get to. However, it is not real-time information. So if you had a refresh of your extract that runs every day in the morning, and then during the day somebody has made a change to your database, they won't see that change on your dashboard until the next time the refresh runs for your extract. In Tableau, you can set if you want the connection to be live or extract when you first are making your data source. And this is in Tableau Desktop. In Tableau Public, you don't have that option. Did you know that the reason that extracts are faster is because Tableau doesn't need to access the database each time it builds the visualization? And did you know that you can set up a refresh schedule on Tableau server in order to be able to see your extracted data update? Question 9, what is a calculated field and how will you create one? So if we look at our data set here, we have the opportunity to see the difference between order date and ship date. So to create a calculated field, you click Create Calculated Field with this drop-down arrow at the top, or you can right-click in white space, Create Calculated Field, then you give it a name, and we're going to call it Shipping Delay, and we are going to do a date diff. So if you don't see this dialog box here, you can click this arrow to see that. Our date part is day, the start date is order date, and the end date is ship date. So to remember how to create a calculated field, it's by clicking this down arrow and clicking Create Calculated Field, and then writing your query here. And a calculated field is an additional field made up using the data that you already have. So we've made a new field here, and it has the equal sign at the beginning. That might be worth mentioning, how to tell if it's a calculated field or if it was an original field. And then we can bring shipping delay here, and we can see the number of days that it took between the order date and the ship date. We could also duplicate a calculated field. So now we have shipping delay copy. And we're going to call this average shipping delay. And we're going to encapsulate it inside an average function. And now if we take off the order ID, the order date, and the ship date, it's automatically summing up those days, but we can bring on our average shipping delay. And you can see on average how many days it took. And let's change our number here to include decimal places. So a calculated field is a new field made from existing data. It can be used to create more robust visualizations, and it does not affect the original data set. For example, we made our average delay function here using data from our original data set. Question 10. How can you display top 5 and last 5 sales in the same view? You can show top 5 and last 5 sales for a same dimension by creating a set. So let's take a look at doing that here. We have our customers. So let's bring on customer name. And we're going to do it based on profit. So now that we've done it on profit, we can see these are our top 5 profit, and I've sorted it by profit. And here's our bottom 5. And we can create a set by coming and clicking on the dimension that we want the set to be based on. We'll right click there, and we will come to create and click set. And we're going to call this top customers. Top by field, top 5 by sum of profit. And now we have a set. It makes a set section here. Now we're going to make a second set off of customer name. Create set. Bottom customers. Bottom 5 by sum of profit. We'll hit OK. And now we're going to combine these two sets. So I'm going to control click, and then we have both of them selected. And we're going to click create combined set. Top and bottom customers. And we're going to have it include all members of both sets. And now we can pull top and bottom customers onto filters. And you can see our top 5 and our bottom 5. So if we control drag profit onto color, then it's colored by that as well. So key thing to remember is that you can use sets to show both the top and the bottom in the same visualization, and that you can combine those sets. Is there a difference between sets and groups in Tableau? The answer to this is yes. You can describe a group as being simpler and using only one dimension to determine the group, whereas a set can be more complex. So you could say sets are more complex, and you can use conditions to create the sets, and you can also use multiple dimensions and measures to create the sets. For example, here we create a group of subcategory. So we grab all of these things together and can group it, and that we'll have copiers and envelopes, and then we'll have one group of all of these together. Over here, you could create a set that looks at sales and profits to create a set. So the best way I can describe this is by looking at what we did here. And so we were able to use dynamic filtering here to create our sets, and where it will look at the top 5 or the bottom 5. And let's do the same thing we did there, but use a group. So for a group, we could see that these, we've sorted it, and we can say 1, 2, 3, 4, 5. This is the top 5. So we could create a group. That's this paperclip here. And now we have a group of the top 5. And it's added that group. It makes a new group, customer name group. And it put it on the color for us. Now let's go to the bottom. And we're going to go 1, 2, 3, 4, 5. And we'll create our group. So now we have a top 5 group, a bottom 5 group, so let's name them that. And we'll do that by clicking Edit Alias. Top customers. Okay, and we'll come here and we'll rename that. Bottom customers. Okay, and we'll put our top customers on top. And then let's hide all of the others. So we'll click Exclude there. And now we have a similar visualization as we had before for our sets. Top, bottom. However, a key difference here is that we had to go through and select the top 5 and the bottom 5. So let's say that maybe let's say Henry Goldwyn has suddenly had much more positive profit associated with them. If that changes, he's going to still stay in our group. This group is just using these customer names to determine who's in the group. So the group is Henry, Sherelle, Luke, Grant, and Cindy, no matter if their data changes. So say tomorrow all of this data is different, it's still going to put these people into the group. However, the sets, as you saw before, is based off of the profit, the sum of profit, and who has the top 5 and who has the bottom 5. If Raymond suddenly has a lot less profit and falls out of the group, then the groups won't pick it up, but the sets will. So that's one thing to remember, is that it could be based on conditions. And then you saw how we took 2 sets and put them together into our combined group. You could also have a set that is based off of 2 different dimensions or 2 different measures. And that's how you could put those 2 sets together and get dynamic sets. So the major differences, as we saw, is that a group is just based off of 1 dimension, and a set can have conditions and be based off of other dimensions. Also, you need to know that groups cannot be used in calculated fields, but sets can. Question 12. What is a parameter in Tableau, and give an example? A parameter is a dynamic value that a customer could select, and you can use it to replace constant values in calculations, filters, and reference lines. So, for example, here we determined we wanted bottom 5 and top 5 customers, but let's give them some options. So we'll create a parameter, and we'll call it select number of top, bottom customers. And we're going to let it be a range with a minimum of 5 and a maximum of 20 and a step size of 5. So we'll let them go 5 at a time. Okay? Now if we click show parameter control, we can see our parameter control, and you can do 5, 10, 15, or 20. But since it's not in any of our calculated fields or sets or filters, then it's not making any difference. So let's put it inside of these. We'll edit our set, and instead of top or bottom 5, we'll click bottom, select number of top bottom customers. So now it's taking our parameter and inserting it in to our set there. We'll do the same thing with top customers. Okay, and now right now we see top 5, bottom 5. If we change it, now we see top 10, bottom 10, 15, and there's our 20. So it replaces a constant value and allows the end user to select the value. Question 13. What is the difference between tree maps and heat maps? So let's first talk about what each of these are. Heat maps compare categories using size and color. I think the biggest thing about heat maps is the color. Size is somewhat optional, so let's build this visualization quickly. So we have region, category, and subcategory. And we're making a heat map, so we want to bring profit onto color. And you can see we've got hotter and colder. In this case, for a heat map, we might want to change. So in this case, what it's doing is hotter is negative, but we could reverse that, and then hotter is positive. And so hotter maybe means this is where more activity is. We can also double click on profit. We can also bring profit onto label, and we'll change this to square, and now it's marked at what everything is. So a heat map will use color to draw your eye to the places where there's heat or maybe activity. We could also use size in this case. So it's not just defined by color necessarily. Maybe we want the size to be defined by sales. So we get things that are bigger but they're blue, which means that they are bigger in sales but their profit is negative. And it draws your eyes to technology. So machines in the South are doing a lot of sales, but they're not having positive profit necessarily. Also, you can see some things that have darker colors but are smaller. So high profit, but not a lot of sales. So that is a heat map. A tree map is used to represent hierarchical data. Now, hierarchy is the term you need to remember when you're talking about the difference between a tree map and a heat map. In the heat map, none of these boxes have to do with the hierarchy with each other. Whereas with a tree map, you can see that this box has a thick white line between it and the other ones. And that means that that section are all connected. So these are all technology. And the bigger this section is, that means the bigger the, size is based off of profit. So this bigger section means that technology has more profit than furniture. So let's build this one. When I build tree maps, I like to use our Show Me tool. So here's a tree map, and it says 1 or more dimensions or 1 to 2 measures. So we're going to grab category, and we're going to control-click subcategory, and we're going to control-click profit and sales. And we'll click on our tree map. Perfect. And so the darker the color, that means the more sales there is. And that's pretty similar to our heat map over here. So the color indicated, in this case it was profit. So the color indicates the difference and the size indicates the difference. And that's true over here. The color indicates the difference and the size indicates the difference. However, there is a hierarchy to it. Over here you can see that there is hierarchies because we have furniture, and then that puts that all together under furniture. And then here's the subcategories. However, if you were trying to compare furniture to office supplies, it's really difficult to tell which one has more sales. But if we go over to sheet 7 that has our tree map on it, you can see really quickly that office supplies has much more sales than furniture. In this case, office supplies has much more profit than furniture. The biggest difference is that tree maps have the hierarchy. Question number 14. What is the difference between TWBX and TWB? So these are all Tableau file formats, and the TWBX contains all of the necessary information to build a visualization. So it's called a packaged workbook, and it compresses it all together. However, the TWB just contains instructions about how to interact with the data source. So when it's building a visualization, Tableau will look at the data source and then build the visualization. With an extract, it contains all of the information that you need, so all of the data is wrapped up inside of there, and there's no connection that has to be made between Tableau and the data source because it's all right inside. Whereas with the TWB, it has to connect to the data source or else it doesn't have the data to build the visualizations. It just knows, it has the instructions of what to do with that data. So the biggest difference is TWBX has the data inside of it, whereas a TWB only has the instructions. Question 15. Explain the difference between Tableau Worksheet, Dashboard, Story, and Workbook. Perfect. Here's a breakdown and explanation of each of those. And in Tableau, this entire thing that we've been looking at, all of these sheets, is a workbook. However, this sheet 7 is just one worksheet. All of them together is a workbook, and sheet 7 is a worksheet. The big difference between a worksheet and a dashboard is that the worksheet is just one visualization, and so it is only one set of columns and rows here. And a dashboard could contain multiple visualizations. So if we wanted to see our heat map and our tree map on the same page, that would be a dashboard. And then a story is somewhat similar to a presentation mode. And so you can have different pages. And so we could say, here is our heat map. And then we could make another page and look at our tree map. And then look at our heat map. And then we could duplicate that page. And we could say, let's focus on furniture. So we're going to highlight furniture. And then, so if we were to go through these one at a time, we would say, here's our tree map, and then we would look at information there, and we would say, here's our heat map, and then the next screen we'll say, let's focus on furniture, and you can see that it highlighted furniture for me when I went to the next seat. So a story can show you things one at a time. It's like a presentation mode. So the differences are the workbook contains the sheets and the dashboards are the stories. The worksheet is a single view, dashboard is multiple views, and a story is a sequence. A sequence is a good keyword to remember when you're describing a story. And did you know that the only place that you can access the dimensions and the measures and custom fields we've made is on a worksheet? So when you're looking at a dashboard, so on a worksheet we see dimensions and measures. When you're looking at a dashboard, you no longer see dimensions and measures. What you do see are all of the worksheets. Similarly, when you look at a story, you no longer see any dimensions and measures, but you do see all the worksheets and the dashboards. Question 16. What do you understand by blended axis? With a blended axis, you can use two measures that share an axis, and that means they necessarily have the same scale. So let's build something with a blended axis. So we could make a visualization that looks at sales over time. We'll bring on order date. And let's just do order date by month. There we go. So we can see sales over time. And say we wanted to also see profit. This is two visualizations that have two different axes. But if we wanted them to have the same axes and just the same marks card, you see how I made two different marks cards? We could bring on measure values and take off all the measures that we don't want. We just want. When we take them off here, it's creating this filter here for measure names. And let's take off these two extra visualizations. And now we have a visualization that has a blended axis for sales over time and profit over time. And you can see that they necessarily have the same axes. There is no second axis. What is the use of a dual axis? And how do you create one? Perfect. So a dual axis allows you to compare measures and you can have two different scales. So if we had this same visualization, that same information that we wanted to see with, again, profit and sales over time, we'll do, okay, great. And we wanted them to have the same axes. We could right click on the second pill of the measures and click dual axis. And now you can see that they do not share the same axis, and you can see profit is much higher here, right there. And so the use of this would be, sometimes you need things to have different axes. If you come here and you click synchronize axes, you end up getting a pretty similar visualization, but you do get two separate marks cards. So a key thing to bring up if you are asked the difference between a blended axis and a dual axis chart is, one, that the blended axis uses the same scale and a dual axis could have two different scales. And two, a dual axis has two marks cards. So let's say we wanted our profit to not be a line chart, but to be a bar chart. That gives you that option. When you go to the blended axis, we only have one marks card, so we change it to bar, everything is bar. But back over here, we change it to circles, and we see the circles. So if we wanted to show sales by year and profit ratio by year in the same view, that's where two different scales could be handy. Let's build that visualization. So we'll make a new chart, and we'll bring on sales and profit ratio over time. That is profit. I still did profit, so I'll drag profit ratio right over top of profit. There we go. And you can see that they can't use the same scale because this is a percentage, and so if we had them on a blended axis, 20% is really 0.2, and it would just be so tiny. But if we wanted them on the same area to apply to the same space here, we could dual axis it. That you can still see useful information there. But otherwise, this would just be in such a tiny, tiny space. So our profit ratio would just show up right here, almost like a straight line. Question 18. What will the following function return? Left 3, Tableau. Here's the question again, and here are the potential answers: tab or EAU, error, or none of the above. So just take a moment and see if you can answer this question correctly. Go ahead and pause the video, and if you get the answer, you can comment below and then we will discuss. We've taken some time to answer this question, and let's go ahead and see what the answer is. The answer is it will return an error. That's because the syntax for left is that the string must go first. First you say left, then you put the string, and then you put the number. So let's talk about what left does. It returns a specific number of characters from the left, and if you had done it correctly, the left is this side. So if you had done the string first and you said you want 3, the result would be TAB. There's also one called right, and that would come from the other end and go EAU. So that's where these answers came from. Question 19. How do you handle null and other special values? Tableau is unable to plot null values or zeros or negative values on a logarithmic axis, and so it will display an indicator in the lower right corner, which looks like this, telling you that it is unable to draw those 2 points. So when you click on the indicator, you can choose from the following. First, you can choose to filter the data, which will exclude the null values from the visualization, or you can click Show Data at the Default Position. So we'll look at both of these. So you click on your indicator and it will say, what do you want to do with these 2 values? If we click Filter the Data, then you can see that it has filtered that blank space and drawn a line connecting those dates in between. Even though there is no point for the 29th or the 30th, it goes straight from the 28th to the 31st. So what's happening on our visualization is it's adding this filter. If we press the back button, we see that filter disappears. If we come down and select Filter the Data, it adds a filter here that then only includes non-null values. So those are all removed from our visualization. And up to this point, you can see that we have 1 point per day, the 21st, the 22nd, the 23rd, the 24th. But then when we get to the 28th, we don't have a 29th or 30th, and it just draws that line to the 31st. Assuming that during that time period, what we want is a straight line. Now the other option would be, we could also make the assumption that whenever there is a null value, that actually means 0 sales have happened during that time. So that's when you would click Show Data at Default Position. And now it draws those 2 points at the 0 line. And when you hover, it still shows sales null. So, and when you hover here, you can see the actual amount for sales during that time. So if a null in your data means 0, then Show at Default Position is good for you. And if it doesn't necessarily mean 0, then you can filter the data, or you can leave it disconnected like this. Question 20. Find the top product subcategories by sales within each delivery method. Which subcategory is ranked number 2 for first class ship mode? If you'd like to pause the video and work on this on your own and then see if what you did matches what we did, then you're welcome to now at this time, and comment below what your answer is. Okay. So we want to know by subcategory and by ship mode which subcategory ranks the highest for each ship mode. So in sales. So if we take sales onto the visualization, we can see that by the ship mode, it's already split up, and we could see that maybe this one for standard class, it would be chairs. You can kind of look through and kind of, oh, it's not chairs. Chairs isn't number 1 because we have this one, it's phones. So to make it easier, we're going to change sum of sales to a rank table calculation. So we're going to come here and click Add Table Calculation. And we're going to change the calculation type to rank. And it's going to rank them in order of sales. So, but right now, we can see that it's highlighting. That's called Calculation Assistance, helping us understand how it's ranking us. So if I unselect Calculation Assistance, then it gets rid of it. But you can see right now, it's ranking it across the table. So it says accessories has most sales in standard class, then second class, then first class, then same day. And that's not what we want to see. We want to see it up and down. We want to see for first class which subcategory has the highest sales and second highest sales. So let's turn back on our calculation assistants and we're going to click table down. And you can see now it's going up and down. Within first class, what are all the subcategories ranked? So that's what we want. Now, as soon as you click things in the table calculation, it applies it over here, so you don't have an OK button. So you can just close that out. And you can see now we have a rank up and down for the subcategory. So back to the question was which subcategory is ranked second for first class ship mode? Here's first class. Let's find number 2. It's chairs. Question number 21. Find the customer with the lowest overall profit. What is his/her profit ratio? Let's go ahead and build this visualization. Customer profit. And we're going to bring all of our customers on. And then we're going to bring on profit. Let's do it as a visualization, so I'll bring it on to columns. And then let's sort smallest to biggest. So Cindy Stewart is the one who has our lowest profit. And now to figure out her profit ratio, we need to make a calculated field, which I've already made here. So in this calculated field, we take the sum of profit and divide it by the sum of sales. We do this so that it will sum up all of the profit per row. So for Cindy, we want to take all of her profit over all of her transactions and divide it by all of her sales instead of doing it row by row, profit divided by sales, and then summing that up at the end. So we'll take our profit ratio and put it on the label, and we can see what her profit ratio is. And since it's a ratio, here I have it in a percent. If you don't have your profit ratio set up as a percent, it will look like this, -1.65. Question number 22. What is the rank function in Tableau? We got a look at the rank function earlier when we figured out our top product subcategories by sales and what was ranked number 2. So I'm sure you're familiar with what ranking is, which is assigning something a position like first place or second place, usually within a category and usually based on a measure. So Tableau is able to rank in several different ways, where you can do rank or rank dense, rank modified, or rank unique. And we'll take a look at these in a visualization here and talk about the difference. But if you are asked about the rank function in Tableau, it's worth bringing up that there are several different ways to rank, and going into a little bit of detail on those different ways will be helpful for you. So let's build off of this rank example instead. So we're going to bring on our store, and we've got store A, B, C, D, and E. And then we'll bring on our sales. And store A had $10 and E had $40. So now let's create a calculated field. We're going to call it rank. We're going to do a rank calculated field based on sales. We're going to do a rank calculated field based on sum of sales. Perfect. Okay. We'll double click on rank, and we can see first place is the one who had the most sales, and fifth place is the one with the least sales. Now, we had a tie here at 20, and it gave them both third place, and then it skipped fourth place and went to fifth place. And that's how the basic rank function works. So if we duplicate it, and we edit our copy, and we're going to make this one rank dense. You know what? Let's do rank modified second. Okay. And we bring on rank modified. Let's have this happen in order. So sum of sales, then rank modified. Now you can see it's similar to rank, first, second, but then it skips third and goes to fourth, and then fifth. So over here it gave them higher number when there was a tie, and over here it gave them the lower number when there was a tie. So if you could remember that rank gives them the higher number and rank modified gives them the lower number, that will be helpful for your interview. Now we're going to take a look at rank dense. Rank dense, apply. And rank dense doesn't skip a number. So it goes 1, 2, 3, 4, and it condenses the ranking without skipping any numbers. And now let's do our last one, which is going to be rank unique. Okay, and with rank unique, it refuses to give two the same rank. And how it determines when there is a tie is it will look at the dimension that's in the visualization and do whichever one comes first in ASCII. So it goes 1, 2, and these are a tie, and since capital B comes before lowercase c, then it's doing B first, then C, then A. So in your interview, it would be really impressive to talk about the different versions of ranks and how they all work. Question 23. How can you embed a web page in a dashboard? So we're just going to build this and then explain it. So I have here my map by sales, and we're going to build a dashboard. We'll bring on, first we'll change our layout so I can fill up the screen. Then let's bring on my map. And I've added the state name and the sales on the map here. For an embedded web page, you can grab it from the objects section, the web page, and then you could put a URL right inside of here, and then that will embed that page underneath. So if we wanted to do Wikipedia or something, we can hit OK, and it will take you to Wikipedia. But what we're going to do is make this page dynamic based on what state you select. It'll look up that Wikipedia page for that state, so you could maybe look at some population data. We'll close that, and we'll try again. We're going to bring on our web page. It's going to ask for a URL, but we're just going to hit OK and not provide it with a URL. And then we'll use this dashboard action and create a URL action that then contains our URL with our state appended at the end, which is how Wikipedia formats their URL. So we'll hit OK. Oh, I forgot one more thing. Let's do it on select instead of on menu, so whenever we select something, it will run this. OK, OK, and now when we select Texas, it brings up the Texas Wikipedia page. When we select Nebraska, it'll change. So the major points to know on how to embed a web page is you bring it in from the objects section, and then if they ask how to make it dynamic, you use dashboard actions and a URL action. Question 24. Design a view to show region-wide profit and sales. So one way you could do this is by bringing on region and then bringing on profit and sales. And that's a pretty simple view of profit and sales by region. However, one thing that interviewers may be looking for when asking a question about region is your mapping capabilities in Tableau. So what we could do is, region is not a geographic location, so it takes a little bit of creativity, but if you bring on state by double-clicking it and it maps out the states, you can make it a map here and it fills it in, and then you can bring region onto color, and that splits it up by region. And then if you bring on profit and sales on the labels, and let's also bring on the state onto labels. And then you can look at your profit and sales inside of their regions, inside of their states. And so that is another view where you could look at profit and sales by region. And it's a little bit more, takes advantage of some of the mapping capabilities in Tableau. It may be what your interviewer is looking for. So you could discuss multiple ways to look at it. but here is one way that we could recommend it. Question 25. How can you optimize the performance of a dashboard? There are multiple ways to optimize the performance of the dashboard. Some of the things that you might mention is that you could exclude any fields you're not using from your visualization, just keep them off, or you can use extract filters, and if you recall, extract filters will remove out rows of data from the extract, and so only focus on the data that you need. Another thing you can do is try and limit the amount of filters that you use, and when you do use filters, avoid using quick filters, and you can use action filters and parameter filters instead. Filters cause your queries in the database to be a little bit more complex and can keep them from running as efficiently as they could. Use min and max instead of average because average functions require more processing time than min and max. Also, you can try to use Boolean and numerical calculations because computers do better with integers and Booleans than they do with strings. So, quick things to remember is keep your data simple, use fewer filters, and when you do use filters, use parameters or actions. Avoid using average, use min and max. And avoid using strings by using Booleans and numerical calculations. Question 26. Which visualization will be used in the given scenarios? Here we have 3 scenarios of opportunities that you might want to visualize, and there is no perfectly exact answer for these, but there are some visualizations that tend better for certain types of data. However, there sometimes could be different ways to visualize it, and it doesn't mean that these are the very best ways. However, if you want to take a moment, go ahead and pause the video and go through and figure out what your 3 answers are and comment below, and we can discuss what we think the best ways are. So first we want to show aggregated sales totals across a range of product categories and subcategories. We want to show the duration of events or activities, and we want to show quarter-wise profit growth. So to show aggregated sales totals across a range of products, subcategories, and categories, you could use a tree map. The reason we bring up a tree map here is that they are known for allowing you to show a visualization using hierarchies. So let's take a look at that. We're going to show aggregated sales totals across a range of product categories and subcategories. So if we come here and make a sheet, and we want to see sales across control click category and subcategory, and then we click a tree map, what happens, it's showing it based on size and color, and so it shows the size, the bigger the size, the more sales, and the darker the color, the more sales. And the reason we choose a tree map over just a normal heat map is that it makes a category here. So we can compare this box that has all the technology in it, see how all of these are technology, to this box that has all of the office supplies. And you can quickly see that technology has more than office supplies, but you can also see that phones has more than art. And it breaks it up as a hierarchy and breaks it up based on your sum of sales. And question 2 is show duration or events, a duration of events or activities. And you would use a Gantt chart. Gantt charts are used to show duration. And each of these lines is a duration. So it's like it's got a start date and an end date basically. And it shows you how long everything takes. And the last one is to show profit growth, and you can use a waterfall chart. And that looks like this, where you can see how the profit changes across every period and if it's going up or down, and each one of these show you how much up or how much down they go. But as we said, there are potentially other answers to this question, so if you have any questions about why we didn't say this chart or that chart, go ahead and comment below and we can start a discussion. Question 27. What would you do if some countries or provinces or any geographical entity is missing and displaying a null when you use map view? So when you start to map the geographical fields that you have, sometimes Tableau is unable to map them because their locations are unknown or ambiguous, meaning a lot of states have a city called Springfield, and it won't know where to draw that city. So for example, let's look at here. So we've taken city as our detail, and it's drawn a lot of cities. However, it's got a lot of unknown values here. So if this question comes up, you've got to remember these 3 things. You can edit locations, filter the data, or show data at default position. Edit locations allows you to correct the locations by putting in their unique names, We'll show you an example of this. Filter the data means just keep them off of the view, and show data at default position means show it at 0, 0 on the map. So edit locations. Here we can say, here's all of these cities that seem to exist in multiple locations. And we could say, well, we know what state they're in as well, and that should help you answer the question. So you could choose a field that will define the state. So here we're saying the state is from the state field, and we hit OK, and then it can draw the rest of those cities. Sometimes you want to keep them off. Perhaps maybe they spelled city names wrong, and you just want to exclude those. And the last one is show data at default position, which is 0, 0. 28. What is a level of detail expression? A level of detail expression, or an LOD expression, is maybe the way they will present it to you, and LOD stands for level of detail. So obviously it helps you get to the level of detail that you want in your visualization, but it also is used to run complex queries at the data source level instead of all in the Tableau interface. So we're going to take a look at an example here, which is adding a dimension to an already calculated aggregate field. In our case, we're going to exclude a dimension from a calculated field. So here we have a visualization that I built, and right now it's just looking at sales by category and subcategory. But say we wanted to look at the total sales for furniture and not break it up by the subcategory. So if we take off subcategory, then we get the total sales for furniture. But if we want a side-by-side, and so that you can see the total sales for furniture and you can see it broken up by subcategory, you can use a level of detail calculation. This, I already made the field for it. I've called it exclude subcategory, so that's right here. Right now it just contains sales, but we're going to use the level of detail calculation exclude, and we're going to tell it what to exclude, which is subcategory, and then we're going to do sum of sales so that it will sum it up for us. And once I apply these changes, it should change it here and our labels. Perfect. So now we can see that it's ignoring the fact that this is chairs and this is tables and this is bookcases. It's just doing the total for furniture and just ignoring these because we told it to exclude. So level of detail helps you to be able to define the level that you want to in your visualization, regardless of what else exists on your visualization. It also moves some of the logic from inside of Tableau to the actual database. And there are 3 level of detail calculations. This will be an important thing to bring up in interviews. They might give you brownie points when you can remember all 3 of the level of detail calculations, which are, we looked at exclude, but we have exclude, include, and fixed. So include, exclude are pretty easy to remember, and just always remember fixed as well. Question 29. How do you calculate daily profit measure using level of detail? Here's another opportunity for you to pause the video and take a look at calculating a daily profit measure using level of detail. We are going to get started. Profitable level of detail. So we want to have a daily profit measure, and I already made a place for it, profit per day. And we want to look at the profit for a day regardless of what else is on the visualization. So we're going to use a fixed instead of an include or an exclude, which will only take into account whatever you put in for include or exclude. Fixed will take into account everything. It will ignore everything else on the visualization and only look at what's in your list here. So we're going to fix it by day. And you have to put a colon. And we're going to do a sum of profit for each of those days. And close it off. So now we have our profit per day. And we'll hit OK. And now we're going to make a KPI, which for our purposes, if profit for a day is greater than 2,000, then that day is highly profitable. If it's less than 0, then it's unprofitable. Otherwise, it is profitable. So we're going to go if our profit per day is greater than 2,000, then we're going to call it highly profitable. Else if we're going to do less than or equal to 0, then profitable, else otherwise it is profitable. Always have to end with an end. Great. Okay. So now we're going to make some visualizations, and it's going to look at it by year. Now it all fits in one view. We can rotate these labels to make it easier to see. And we're going to bring on order ID. But now it's showing like a lot of orders. And so we actually want it to be used as a measure, and we're going to do a count distinct. Great. So now we can see how many orders were on each day. And so that's helpful for us to see how many orders are on this day each day, but we want to see the orders on each day that are highly profitable versus unprofitable versus just profitable. So we're going to use our level of detail and break it up into different sections. So we have highly profitable, profitable, and unprofitable. Let's also bring this onto our color. Highly profitable, profitable, unprofitable. And now we can see that the profitable ones are going up. Unprofitable ones seem to be going down in 2015, and that's nice, but they are going up. And highly profitable is not very many. Oh, in this case we did area charts instead of just line charts. To make that change, you change it from automatic to area, and that helps you see some of that spatially as well. Comment below if you were able to make this visualization on your own. Question 30. How can you schedule a workbook in Tableau after publishing it? So when you publish a workbook in Tableau, if you've used an extract, you're going to need to refresh that extract. So in Tableau, when you create a Tableau data source and it's an extract version of the data source, it will no longer update if the data from your database updates. So somebody's made some changes to your database or your Excel file, and you want to see that in your Tableau visualization. Well, you're not going to see it, but you can see it if you make a refresh. So you do that on Tableau server, and you can remember that you have to get all the way to your data source. So you can go to your data sources or to your workbooks, and then you look at the data source on your workbook, and you go Actions, Extract, Refresh. And then you select Schedule a Refresh, so that looks like this. You can press these three dots next to it and click Refresh Extracts, or you can go to Actions, and then here you click Schedule a Refresh instead of Refresh Now. And then oftentimes in Tableau you'll have several different options. You can choose daily at 7 a.m. or every 4 hours. If an interviewer is asking you about how to schedule a refresh, it might be worthwhile bringing up the fact that you only need to schedule a refresh if you are using an extract on your data source, and then that will help them know that you know the difference between live and extracts if they didn't ever ask that question.
Now with that, we have come to an end of this session on data visualization with Tableau. If you have any queries regarding any of the topics covered in this session, or if you require the datasets or any resources that we used in this session, then please feel free to let us know in the comment section below, and our team of experts will be more than happy to resolve all your queries at the earliest. Until next time, thank you, stay safe, and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.